supposed to rewrite this.
It's all good.
Take it away, May.
Hello, welcome back to NIDC Day 2. Yesterday, big recap, over 400 attendees. Really, I'm just flabbergasted. It was just, we weren't expecting that many people. And just the chat, everything was fantastic for the day. Of course, despite the technical difficulties, so I'm really glad that at the end of the day, we found our feet and everyone seemed to have enjoyed the talks. And now we're on to day 2. And because we missed the fantastic introduction between myself and Mark, so we're going to try and replicate that with art. Hey.
I'm there, this is Mark.
Yeah, so just a very quick recap for anybody who wasn't here yesterday. We have volunteers on the chat, so anybody with a V or an M after their name, if you need to get any help or you have concerns, just send them a message and they'll help you as best they can. We also have a code of conduct on our website, so again, refer to that if you think there are any issues or even if you're just being nosy. There will be all day and after the event, we have hubs, Mozilla hubs running simultaneously, which has proven to be quite fun. You can join as a flaming marshmallow or, you know, a duck and get chatting to people. And Hopin itself, very quick recap, you've got your main stage where our track 1 talks will be. Track 2 will be in our sessions. And also in track 2, between 11 and 12 today, John Greer from Sensata will be available to have a chat with whoever wants to have a chat with him. So check in, it'll be fantastic. It's a good chance to find out what they're doing. Also as well, your sponsors. We couldn't do this without the sponsors, so drop into their booths, say hello. Some of them will have opportunities, so if you're looking to change your job, you've got that. And everybody who's missing the hallways, you know, where you just bump into people, you've got your networking. So drop in the networking, see who's around, get chatting. You never know who you might connect with. And that's pretty much all from me. Over onto Yart.
I have to really stretch these 3 bullet points that I wrote down. Let's give it a go. So we do have 2 tracks today, but there's a bit of a 3rd track happening, which is the games and the competitions. You've seen it a little bit yesterday with the Tetris game posted on Twitter and the winner, Michael Martin, whose prize will be announced at the end of the day today, along with other winners for more competitions. At lunch, we'll have another game, which is secret for now, but will be announced soon. So keep an eye on Twitter. Between 12 p.m. and 1 p.m. for that. It's quite a good prize. Took me some thinking yesterday. Additionally, there will be some competitions running throughout the whole day. There will be 2 announced just after I'm off camera here, with a bit of delay. One of them is a crossword around our sponsors, Gold, Silver, and Platinum, where if you can figure out which sponsor is which clue, you will be entered into a raffle specifically for only the people that fulfill the crossword, so you have a much higher chance to win a pretty good prize. In the evening, like yesterday, there will be a quiz about the conference. So if you're watching the videos, keeping an eye on Twitter, chatting with people, those are the things that will have the questions on the quiz about. Again, a pretty good prize to be announced. All of these prizes are sponsored by two specific companies that say we really want to do this for the community, and that is the Vertical Structure and Van Rath. So big thank you to those sponsors for making this happen and bringing a little extra fun into the conference. If you're not a fan of competing and just want something, we also have that for you. O'Reilly have provided a special code that you will receive an email about with more details from Joan whenever this is over, as well as Pluralsight, a learning platform that we have 50 codes for. So if you're really into online learning, make use of that. If you already have an account, There'll be details about what to do with that. And if you're not really into it, let someone else have that. There's a limited number of those available. One last thing, and this is a really important one. Sorry, May. Because we're able to take NIDC online live this year, there is a bit of a special emphasis on social media, as you may have noticed. So there is one competition that has already started. And you may have accidentally entered it yourself. And that is the most retweeted tweet with the hashtag NIDC 2020. From 9 a.m. the 8th of October until 5 p.m. today, will receive a prize. So if you haven't started, get going. And if you've already started, keep pushing out your tweet.
That sounds like a lot of fun. Thank you, Art, for all the hard work you put into doing that. And of course, for all of this, we couldn't have done it without the sponsors. And I wanted to give a special shout out to BCS, who have supported us every year of the conference so far. And we also have, for our silver sponsors, ESO, Farsight Labs, yay, HHA Exchange, Open Data NI, Cork, Shopkeep, and SpotX. For our gold sponsors, we have Allstate, Flexera, GCD, Instill, Rapid7, and Signified. And last but not least, we have platinum sponsors, Sensata, whose very own John Greer will be in session between 11 and 12 today just to have a chat. So it's a really good chance to find out what they do and what opportunities there are in Sensata. And I believe we are also doing something special at the end of the day.
Well, that is true. It's cheesy as hell, but I'll do it. So, similarly to the credits for a Marvel movie, we are doing something special for the people that stick around, or at least skip to the end of the conference to watch what's happening. There will be special things for attendees that are watching the conference, so you will hear your name come up. If you're not there, you miss out. If you're there, then you get something. Similarly, we're looking at the conference on social media, on the chat, in the studio, and we're collecting some moments to highlight. So if you've got something that you've noticed that you think was really cool about this year, let us know, and we'll let everybody else know too. But that's not all. You may have heard about a certain accident happening on a stunt set for NIDC filming a week ago or so.
A week or so ago, yeah.
Everything is well, but the video is finally ready. All the waivers have been signed. It's all good. And that video will be the ending note of the conference. So watch out for that.
Yes, do stick around for that. And I suppose it's time to get into our talks. So the day can finally start. We can stop speaking. You don't have to listen to us anymore. But do you want to introduce our track 2?
I know. It was supposed to be back to me. I forgot. Sorry, mate. So you may have seen a little tweet yesterday where it's somebody doing maybe 5 things at once, multitasking a lot. That is going to be our first speaker in track 2. If you know who I'm talking about, you know who I'm talking about. It's, of course, Chris Laughlin. He'll be asking, is micro front-end architecture the future of web application development? It's not mobile application, it's web application.
Web application.
And on track 1?
Track 1, we have Jonathan McDowell, or better known as Noodles. So if you're looking for his Slack handles, that's what it is. And he'll be going into his experiences, advantages, disadvantages of Go, especially from a C background. So kick it away, Jonathan.
He's over there.
So yeah, a year on the go. I'm going to start with something I don't normally go into too much, which is about me. This is relevant context for the rest that follows. I have 20 years of commercial development experience. I'm old. I'm mostly an embedded stroke systems programmer. That means that I generally write back-end applications that run on servers or on pieces of hardware rather than things that are running on your desktop or running in a browser, that sort of thing. I've done a lot of C. I've got 20 years of C experience. I've done C++, I've done COBOL, I've done Pascal, I've done Perl, I've done Python, I've done Tcl. All of those in a commercial environment. And that's relevant because I'm going to rant a bit about Go, and I don't want you to think that I just hate anything that isn't C. but also that I pick up languages as and when I need them rather than just because I want to. The other thing is I'm a Debian developer, and that's applicable because I have experience building Linux distributions and packaging things, and I'm also a big advocate of free software, so I have opinions about the way that thing happened, and both of those impact on the way that I interact with languages such as Go. I'm also going to have a commercial break here. Again, it's relevant context. I run the Belfast site for Nebulon, and why that's relevant is that when I took this job, I had written absolutely 0 lines of Go. I had been to a couple of talks about Go, I had been aware of the language, I had always meant to get around to looking at it, I had never had a pressing need, and therefore I'd never made the time to look at it. I took the job partly because it was an opportunity to do something cool in a language I didn't know. We build cloud-defined storage, and that sort of means that we have a cloud management component, and then we also have an on-prem piece of hardware. And the really interesting piece is we use Go all the way from the I/O level stack at the bottom all the way up into our cloud. So the traditional cloud application Kubernetes development that maybe Go is more commonly seen in, but then also actually on the piece of hardware that runs on premises. And all the way up to the APIs. We are hiring, feel free to talk to me. This is the sort of thing that if we were an in-person conference, I'd say grab me at one of the breaks, but I'm on Slack, I'm on Twitter, I'm vaguely on the chat channels for this conference. All of that said, this is all me. If you've heard me rant about Go in the past, this is my personal set of rants about Go, but I like to think that now I've been writing it for over a year, they're a bit more well-informed, and perhaps I'm a bit nicer about Go than I used to be. So yeah, this is all me, not my employer, not anyone I work with, not any of the NIDC organizers, anything like that. My rants. So let's talk about why Go. Go is one of the attempts to make a more modern compiled language. So a lot of what we have in terms of languages out there that are compiled are much older school. So C, C++, even the likes of Java now is what, 20 plus years old. It has a different set of requirements to some of the system languages, which Go is designed to sort of fit into the space of. So if you've been writing stuff in C, high performance, the idea is that Go is a language that can be used for that. There are others, I'll talk about a couple in a minute, but the aim is to be efficient, scalable, and productive. If you go and read, there's a paper by Rob Pike that's really very good from about 2012, and it talks about Google's design decisions when they were making Go. And one of them was, it had to be easy to pick up, so it has C-like syntax so that people who know C can pick it up. It has sort of fast compilation so that people can do fast cycles. And if you go and read that, you'll understand a bunch of the design decisions that Google made in this about, they're not trying to make sort of the best language and what some of the other languages go down about adding new computer science features into languages. Now we have more powerful compilers. They're trying to make something that is an incremental improvement but builds on modern technology. So it's familiar and C-like. And if we were in person, then what I'd be doing here is listening to Chris Nixon heckle me. So I deliberately have a slide, why not Rust? The decision to go with Go for the product I work on was made some time ago. It was made about 2 years ago. At that time, Rust was still not quite there for enterprise. It was if someone's telling me to pull the nightly version of the compiler on a sort of daily or weekly basis to get some features that are annoying me, I don't consider you to be a stable enough language for me to build enterprise level software on. There's a steeper learning curve because it is very much about doing some neat things because we have more powerful computers for compilers. It gives you a different language than something that's based on C quite heavily. I think it does show a lot of promise. There are other languages out there that are trying to do the same thing, but I think Go and Rust are the two major contenders to look at, and they're definitely the two that are the most stable. In particular with Rust, one of the things that we didn't have was tier 1 ARM64 support, which I believe has arrived in sort of the last 6 months or so, so it's definitely getting there. I like this t-shirt. This is actually a reference to, I think, an American sports ball team, and I can't remember which one, but it seemed appropriate. Enterprise. Apologies for the disturbing gopher suit, but I couldn't resist. Enterprise, so the thing about cloud development is fairly fast-paced. You can roll out new versions of it. You have full control over what's actually deployed. You generally have a good CI/CD pipeline that means that you control the entire environment and can be a bit more confident about the changes you push out. You can roll back if there's a problem, Enterprise generally means it's on someone's premises. You have to talk them into doing updates, and people don't do updates. They like find something that works and then they don't want to make changes because, hey, it works. And that annoying bug that crashes once a week, well, at least they understand that and they can work around that. Or, you know, that slight glitch in the user interface that sort of is very weird, but once you know about it, you can work around it. They'll live with that rather than take other instability that they can't work around or can't deal with. They also tend to expect longer uptime. So I work in data storage. People get really, really unhappy if they can't get access to their data. So the idea of eventually consistent, no, not good enough. Your data has to be there. It has to be there in a timely fashion. There's an expectation of both reliability and uptime overall. So it's a slightly different way of thinking about software development. That's why I think that a language that doesn't have a sort of a firm compiler, has a long established track record, isn't something you want to be building enterprise software in just yet, because this is something you might have to support for 5 years out in the field or longer, depending on what it is. Talking about Go itself then, and what it gives me over C environment and maps. It's not just things that begin with M, it was just that the M things were the things that came to mind. Maps, dicts and hashes, the ability to take an object and store it based on the value of something else rather than just a simple array. It's so simple, but it's something C doesn't have, and every time I have to write a hash table lookup in C, I cry a little inside. Everything else does this. It's a basic thing. Most of you that are familiar with more advanced languages will be wondering why I even bring this up, but if you don't have it, you really miss it. Method receivers. So the idea that you can tie methods to structs, and that receives the struct. That's actually quite nice in terms of this halfway house between full object orientation and just bare functions that you get in C. So I've actually found those much more useful than I would have expected in terms of things like encapsulation, being able to design clean interfaces, and that sort of thing, that they've been really quite convenient. Multiple return values, that turns out to be quite handy, rather than passing things in as a pointer so that you can return a value in it and then also return an error code. You can just return the thing that you're interested in plus the error code. I didn't put strings on this. Again, strings are one of those things that every other language than C just makes easy. You can add strings together, you can put things on strings. The memory allocation happens automatically. Most other languages don't make it quite so easy to overflow a buffer with a string as C does. Go again adds in proper string support and being able to do that. I haven't had to fight Unicode in it too much. I'm not doing anything weird there, so I'm not sure off the top of my head just how good it is, though I do expect that it actually has proper Unicode support, which again, C doesn't. Things are byte strings, and that's what it is. Concurrency is the big thing that comes with Go. People make Go routines, they're easy to spin up. You can literally, with one extra word in front of a function, spin it off in its own thread. That's quite nice. That's much easier than doing pthread stuff. They add in channels to effectively give you a way of doing message passing between your Go routines, but there's not really anything else groundbreaking that Go adds there. So if you have a model where you've got lots of workers and each worker is independent and you can throw things off to a worker thread and then it will eventually give you the answer and there's no interaction between those threads, Go's superb. So in a microservices architecture where you've got lots of web requests coming in, they don't really need to talk to each other. They're going to go and talk to a back end, do some processing of that information, then feed it back to the client. Go's great. Not so great as soon as you get into anything that actually requires shared access to a resource. So you can shoehorn things into channels and do this, but if you're trying to build a back end database that's all trying to access the same data store, channels get to be a bit sort of convoluted for what you want to do. Now, Go has all of the standard concurrency primitives that you would expect in terms of mutexes, semaphores, shared memory, shared variables. That all works just fine, but there's nothing added there to help with the concurrency side. So I think there's something there that's been missed out in terms of, yes, if you've got worker threads, there's some extra tools that make it much easier, but if you're actually doing something that needs shared access to a resource, it's much harder to fit that into a proper Go idiom. And I've talked to people about this, and all they've come up with is ways to shoehorn it into channels rather than actually telling me I'm missing something massively. So I don't think I'm being unfair in the language here. And what it adds is better than C, and it doesn't take anything away. I just think that there's some extra work there that could be done to actually improve that sort of concurrency operation. Packages. This is ecosystem features of the language. This is good. I sit on the fence. I've ranted about the packages in the past to people, and I'm still not sure about it. It depends which hat I'm wearing. So if I wear my developer hat, this is great, right? I can pull in a dependency. It automatically gets downloaded. There's a big suite of packages available. So, you know, coming from a Perl background, I'm used to CPAN. Obviously with Python, there's pip. These things let you grab these packages. Even with Perl and Python, they don't automatically get downloaded and put into your build environment and installed into your workspace in the same way as the likes of Go, where it will just pull things down whenever you try and do a build. And that's one hand, that's really good. I really like that fact. It's much easier than trying to install the C library, build it, install development files, make sure that those things are then on the target machine. But on the other hand, it's quite bad. You can pull in a package and you add one package to your list and it pulls in 20 dependencies. And we're not as bad as Node with all of the NPM dependencies and one-line packages, but you just have pulled in a chunk of code that you haven't properly audited because it's one line in your source file that's pulled all these things in. You're not quite sure what version you've got to, though we've added module support, which now means at least you get the same version next time you compile. And there's a whole bunch of auditing that makes it quite hard. It's like, well, do I need to pull to a later version? When do I know I need to pull to a later version? Why did I end up with the version I ended up with? And there's a set of curation around the packages that, because it's so easy, it's much harder to remember to go and do. And I think that's one of the downsides, and that's one of the downsides that really comes with my Debian head on about, I care about versions of things. I care about, do I need a security update for this package that is really just a point release rather than updating to the latest version that's going to bring in uncertainty. There's still a lot of work to be done there. I don't have any answers for how that should work, but I think that part of the problem is that a lot of people pushing packages out aren't thinking about these things. They just push a latest version. So it's always the latest version, which is bug fixes, major changes, potentially API changes, and you get everything. Building stable versions of packages with security support and bug fixes alone is more work, and a lot of these things are done by people in their spare time. So I get it, but it's a downside of that ease of pulling in packages. Static binaries, kind of the other side of this. Again, with my distro head on, I hate static binaries. So that's when you take all of your dependencies and bundle it all up into one single file that you can then distribute. That's great in one sense. You can. When I started playing with Go, I built some stuff on my build machine, and then I pushed it to my server, and I didn't have to worry about what modules I'd pulled in because everything got bundled up in a static binary. So from one point of view, I really liked it, especially when I was getting started with Go. Again, with my distro head on, if I have a security issue in something I've shipped in a distro, I suddenly have to recompile every single Go package. And I've seen that in the last sort of year or two in Debian, where one of the crypto libraries had a fix or something, and Debian had to basically go and recompile all of the Go tools that were using that library. Whereas if something like libSSL changes, you drop a new library and it's dynamically linked against applications, and you don't have to ship everything. You're also not shipping multiple copies of that code. I get why Google did it. It makes a lot of sense for containers. The premise of Go is for a container, you could build a single binary. Your container would run a single binary and doesn't need anything else shipped in it. If you're rebuilding the world every time you ship something, static binaries are just fine. If your container only runs one application, static binaries are just fine. If you're trying to ship something that runs on someone's desktop, this gets to be a bit more of a problem. And that's not the space I'm sitting in at the minute, but it is a problem I have with the language, that static binaries are two-edged, double-edged sword. The other nice piece about Go is cross-compiling. It's a standard part of the Go that you can download and work with. You can compile for different architectures and OSs. I build for both AMD 64 and ARM 64 as part of my day job. If you've never had to cross-compile, you really won't understand how amazingly useful this is. So the idea that Go will go and pull down all the packages as source, Go's compiler will cross-compile it for me, and that I can do all of that sitting on my own laptop and build two different entire architectures is amazing. I don't think about cross-compiling on a day-to-day basis. We have some C libraries we link against. That's the only cross-compiling complexity I deal with. But essentially, we can now build for embedded hardware, more limited platforms on sort of big beefy AMD 64-based servers, and yeah, nothing else I've used does this as well. I have played a lot with C cross-compilers, and they're always a nightmare. Rust may do it as well. I haven't touched that, but Go has been a really good experience from that point of view. Debugging. This needs some work. And some of this might be my familiarity. I'm obviously very familiar with working with the C environment and how to debug that, but equally I know how to debug a bunch of stuff with Python and Perl and pieces like that. Delve is the Go debugger. It's trying to be GDB, but it's missing a bunch of the features, especially given that Go supports such easy concurrency. It doesn't make it easy to manipulate a lot of Go routines. If I have over 1,000 Go routines running, I can't easily search for which one is running a particular function. I can see where it currently is, but if it's currently sitting waiting for a lock, then they're all sitting waiting for a lock, and I can't distinguish it. And I end up doing a backtrace of every single running Go routine and then running grep on it, which just sort of seems counterintuitive. And maybe I'm missing something, but again, I've asked people, and there's labels you can put on functions that's supposed to help, but it's not really there in terms of how do I easily debug this very concurrent, very complex program with this sort of very basic tool that really requires me to do a lot of the heavy lifting myself. And the binaries have the information in them, so there's no reason you couldn't add some more of that. And it's coming, but it's not there yet. And also, whenever we started out, the ARM64 support wasn't properly there, and we had to do a bit of development to actually make sure that that worked. And it seems to mostly work now, but it wasn't there. And on that subject, you can cross-compile nice and easily, but for cross-debugging, not so much. I end up having to log into an ARM64 machine in order to debug an ARM64 binary. I can build that on an AMD 64 machine. I can't then run Delve on it. People have talked about it, but as far as I can tell, the work isn't there yet. So debugging definitely needs some work. On the flip side, I do love the fact that I can get complete backtraces of everything in the output whenever I crash. So instead of just getting a seg fault or a random abort or something like that, I get an output of what happened. And actually, for a lot of what I do, if I can see where the crash happened and what else was going on, I don't often need to fire up the debugger because that's enough information to go on with. And it's very good for after the fact debugging whenever I wasn't paying attention or it was something that happened overnight, that I can look at that log file and I can see the full backtrace because Go just spits that out by default. And it's something you can do in C, and it's something a lot of other languages do as well, but it's a nice thing to have by default. Memory allocation. This is, I think, my major problem with Go. Stack versus heap is not always obvious. It can cause, it's to do with the garbage collection, which I'll get onto afterwards, which I have issues with as well. But because of the way Go allocates memory, you're not always sure whether it's going on the stack or going on the heap. There's some escape analysis you can do to go, hey, does this piece of memory live in a global heap that therefore I have to track a bit harder, or is it something I can keep contained within my function, which is a bit more efficient? And I shouldn't have to run the compiler with some special options to work out whether or not it thinks it's escaped. And maybe that's, again, just my familiarity with the language, but it does seem to be counterintuitive at points in time. The use of pointers could cause issues with the garbage collector. The garbage collector will look for references based on all of that. Again, I'll talk about the garbage collector separately because it's a whole slide by itself. And you're not talking about the same rules with the memory allocation here as with C. So in C, it's very simple. If I want to pass something efficiently, I'll pass a pointer. Now that means you can modify it, but it means that I'm literally just passing a pointer. If I try and pass a struct, I'm automatically getting a copy. Whereas in Go, I might get a copy if Go decides it needs to do a copy, but again, it's not always entirely clear, and there can be unintended consequences of pushing that pointer, that struct through rather than just a pointer. But again, if I push the pointer through, I get some issues with the garbage collector, so I have to make a decision. And really, the garbage collection is the biggest thing I have with Go as a language. You give up control, right? The idea is that memory leaks are a terrible thing, and everyone writes memory leaks somewhere in their code. You end up with a garbage collector that will then clean up all your memory allocation. I don't have to worry about cleaning up when I'm done with something, because as soon as nothing needs it anymore, the garbage collector will clean it up. Well, yeah, except the garbage collector can still cause you problems if you keep a reference to something hanging around. So if I know I need to free something up and explicitly free it, it's gone. I might have a use after free, but I've deliberately freed it up and the resource is freed. With the garbage collector, I have to make sure that I haven't accidentally got a pointer hanging around to it in some other structure somewhere. So you still end up with the potential to have memory leaks, and yes, I've written memory leaks in Go because I can write bad code in any language. The hope is it makes it easier. But again, the garbage collector takes work. So if you're actually used to working in an embedded environment, then all of a sudden you've got the runtime of your code that will actually go and stop and go and look at things and take some CPU away from you and potentially mean that your latency access is not quite what you expect. And if you go and look on the web, there are countless articles out there about people trying to trick the garbage collector. My favorite one is the folk building a web application who basically allocated sort of 400 megs of memory because the garbage collector only kicks in, I think, whenever you've used up half of the available space, and that meant that their available space would hit another 400 before it would start to garbage collect. And if you're having to do those sorts of levels of tricks, I think it indicates that there's some more tuning that needs to be available within the language to give you some more control back there. On the flip side, it does mean that you can easily sort of allocate things. Things like the string allocation, things like freeing that up become much easier when you've got a garbage collector involved rather than having to explicitly go, oh right, I reallocated that because I needed more space, I need to go and free it. This one's the hardest one to deal with for me. I think talking about embedded systems, when I say embedded earlier, I mean a system with an OS. So I'm actually able to run a full OS. And that these days means Linux. It actually means they're quite powerful. You've got gigabytes of memory. If you're trying to run this on a true embedded system, I don't think it's going to fly. Like an STM32 with 192K of memory, Go is going to be extremely difficult to get running on that. Whereas I know Rust will work on that, and of course C, perfectly happy to write some C on that because you can cope with the constrained environment. So I don't think Go goes down quite as far as it could, partly because its standard library is doing things under the hood like the garbage collection. On the flip side, the standard library is superb. So things like being able to make web requests, those being part of the standard library, the crypto routines that are generally available as part of Go, just having that sort of full suite of functionality that we kind of expect available but not cluttering up the language. So the language itself is still nice and clean and easy to use, but that ability to pull in packages gives you that ability to have a nice full featured standard library that doesn't pollute your namespace too much. So I like that. So I've raced through this, I think. In summary, some of my problems about Go, I'll accept, are my relative newness of the language. I have a year and a half-ish experience with Go. I have 20 years experience with C. I am much more comfortable with the warts of C and the limitations. Some of the problems I can see are the price I pay for the benefits. So the garbage collector, the price you pay is then suddenly the OS has to do garbage, or the runtime has to do garbage collection for you. Equally, the ease of pulling in packages is something you then pay for, is that, well, I have to do some curation of that rather than sort of having to pull it in the first place and doing the curation up front. I don't hate it as much as I thought I would. I have picked it up and written some personal projects in it. I'm still more of a C developer than a Go developer in my spare time, but I do like it as a language. I find it really interesting to sort of look at that and take that next step into a language that is supposed to be better than C, has a lot of the same features, and is an easy enough one to pick up. But at that point, I think, even though May's telling me I have 5 minutes left, I think I'm pretty much done and I'm ready for questions. So thank you for listening to my rant about Go. I have to say that the NIDC folk have done a wonderful job in getting this sort of space set up and making it nice and easy for us presenters. But, thank you very much for your time.
Hello. Well, that was a good talk. Thank you, Jonathan. Really appreciate that. And of course, we've had Slido up and running, and got a couple of questions in just for Jonathan to answer. So, thank you. So that was really good. And I thought you were bringing a gopher in.
Yeah, no, I should have brought a gopher. I wasn't sure what the policy on live animals was.
I was just remember seeing your Twitter. It's like, we got to go for? I was getting excited. I thought I was going to
Sorry, no.
have an animal to pet. Yeah, so got a couple of questions come in. So Kieran was asking, did you get a chance to use Go in the AWS Lambda environment?
No, so our cloud-based environment is EC2 with Kubernetes and Go binaries based on that. The only Lambda experience I've got is with Python, so I haven't touched Go there.
Yeah. Do you think you will?
I'm not a big fan of serverless. I can understand the need for it, but in general, probably not likely to touch that myself anytime soon.
Yeah, no worries. And then another one here, is Go a good language for graduates?
It's certainly a better language for graduates than C. I think that the flexibility, the amount of stuff available in the standard library is really useful in terms of being able to do things like talk to web servers, talk to REST APIs. The amount of stuff you can easily pull in makes it very useful from that point of view. The garbage collection does make it easier in terms of memory access. So I think I would pick up Python as my first language over Go. But I think that a lot of people are moving to Go as something from Python. It's like, I need something more performant than Python. I need something that means I can drive things harder and do more complex stuff.
Yeah.
Python's concurrency, I think, is getting better with async, but certainly in the past has not been great in terms of the giant lock and that sort of stuff. So I think I'd pick up Python over Go, but if I already knew Python, I was looking for a compiled language to learn, Go's not a bad choice.
Yeah, oh, that's good. It's always good to know these things. Don't know if this one's a controversial one. Do you think they made the right decision not including generics in the language? In Go, obviously.
Yeah, I think they're trying to bring it into Go 2.0, and I think that's an interesting decision to sort of fundamentally change the language. I don't think it worked well for Perl going from 5 to 6, and I'm not sure it's worked particularly well for Python going 2 to 3 and doing a lot of breaks. I don't have a strong opinion on generics because I come from a C background. It's not something I generally make a lot of use of. I've used them in C++ usefully, but I think if you're going to try and stick to C, then not including them wasn't a bad decision. But equally, I could have understood if they wanted to pull them in. I refuse to get drawn into the controversy.
I think that's a really smart idea. I mean, every language has its place, right?
Yeah.
Absolutely. And then, this is a good one, I think. How much time did you spend learning and upskilling in Go before you came to this conclusion? If you're taught.
I mean, I'm still learning and upskilling in Go. I was still learning and upskilling in C. I mean, there's bits and pieces. I'm always learning about the language. The pieces that at the moment I'm still learning about in Go are a lot of that runtime behavior. The language itself, as a C programmer, wasn't too hard to come to. The compiler's quite good about complaining about things. There's lots of good examples out there. I wrote a couple of personal projects before I actually started the job, knowing that I was going to be using Go. And then also I personally find that, first of all, having a defined project to do in a language helps me learn it. So I wrote some stuff of my own to do that. And then secondly, coming to a pre-existing code base with developers who are trying to use the correct idioms for that language is really a very good way to learn. So you spend some time learning it yourself, but then like code review and whatever will correct you, and each time you write a new piece of code, someone corrects the idioms you've missed or tells you about something new, and that's been really useful. Timescale, I mean, I wrote myself a useful piece of Go within, a couple of months of picking it up in my spare time, and that piece of code is still running in my home automation system, and I'm working just fine. And I was writing productive code in the job, certainly within, I don't know, but not within an unreasonable time frame.
Yeah. How is the home automation system going?
Home automation hasn't changed much since last year, otherwise I would have talked about that, but you know.
Because I remember there was a lot of interest in your talk last year in home automation, so
Yeah.
I think that's stuck in the minds of quite a few people. So I suppose, you know, a lot of people are really interested in that aspect because it's just coming into our lives a lot more, the smart speakers and so on. And so any particular big projects going?
The one that's interesting to me that I haven't yet done on my home automation, to completely veer off topic, is speech recognition. So Phil Weird actually pointed me at some free software that will do speech recognition in the home. So rather than having something like an Alexa or a Google Home Assistant, you can actually build a device that will do speech to text decoding, and then you can write some stuff around doing that sort of thing. So you can say turn on the lights and that sort of piece. So that's the final piece that's really interesting to me in terms of keeping it all in the home rather than going out to the cloud for any of the stuff that I need to do my day-to-day life in my home.
Brilliant. I love that. I'm still working all that out myself. One more question. Your personal projects in Go, were they fun to do when it when it wasn't for work?
Yeah, they were fun to do. So I am terrible at writing code that doesn't have a purpose, which is one of the reasons it took me so long to come to Go. I think I saw my first talk about Go certainly at least 8 years ago. Yeah. And I sort of always meant to get to it, and it was having the job that gave me the reason to actually look at it. And when I came to write something, I had to have a reason for it, and that it has to. I'm big on being entertained, right? Don't do anything unless, on the whole, it entertains you. So I wrote a piece of Go that listens for Bluetooth broadcast beacons from a temperature sensor and then sends those via MQTT. And that sounds sort of quite complicated, and it wasn't really, because the Go modules made it all very easy. So there was an MQT package I could install, which was very much, I already was familiar with it from Python. Yeah. It worked in very much the same way. So that was kind of fun to get working, because at the end of it I had something that was useful to me, and I tend to find that's the way I learn a language, if I do something that's useful to me or comes out of it. So I'm not one for going and doing, I keep meaning to do Advent of Code, and I start Advent of Code every year, and I get through like 2 or 3 days of it, and then I forget about it, and then I'm like, oh, I'm not going back to it, because it's very much a day-by-day thing, and it just doesn't suit my way of learning.
Yeah, because that sort of forces you rather than...
But I know a lot of people have used Advent of Code, which, if you don't know about it, is a thing that runs in December, and every day they give you a new challenge and you have to solve it, and then you move on to the next level. And there are, I think, people on the NITech Slack who have a leaderboard and do it all together, but I'm terrible at it because I do 3 days and drop out. People use it as a way to learn a new language. Here are a set of problems to solve in a language I don't know, and it will give me these challenges, whereas I'm like, who's got the time for that?
Yeah, I'm something similar. I would start it and then oh, I forgot.
Yeah.
So if it's not work or a personal project, it kind of gets forgotten. Another question here. They're flying in.
I was not expecting so many questions.
People are interested.
People are awake. I was kind of thinking morning slot, everyone would be asleep. Saturday morning was safe.
But you're over. No, you're not getting away with that. What resources are best for learning Go? What was your favorite? What were your favorite places to go?
So the
go to, pun intended.
golang.org website is where I started out. There's I can't even remember what it's called. There's the Go Playground, so there is a walk through the features. That's the first thing I actually did in Go, was they have a Go Playground where you can go and type in code in the web page and it'll run it, and they actually run you through all of the basic features of Go. So, if you're familiar with programming, they're all the concepts you're used to, like functions and loops and all of that stuff, but just shows you the Go syntax, and because you can actually see it and run it and tweak it, that immediate feedback thing, given it's a compiled language, it's a little bit harder, but you can do it all in the browser and it gives you the output. That was really good.
That's fantastic.
In terms of just being able to walk through, and I still find myself going back to that whenever I go. I've written some C recently. How do I write a for loop in Go again? And it's just the syntax is very slightly different, and how you do a while thing is very slightly different. And I actually found myself in C the other week dropping off semicolons because you don't need them in Go, and then all of a sudden my C wasn't compiling because I'm now used to writing Go. So I think that means I've been writing Go long enough to. But the Go Playground is superb, and even now, still for sort of trying to figure out behavior, I'll go to the Go Playground and kick it to see what happens in the web browser, and it's really very useful.
That's fantastic. Thank you very much, Jonathan.
You're welcome. Thank you.
I will release you now back into the wild. But thank you, Jonathan, for coming in. So we're on to now our next set of talks. In track 1, we have Andrew Bolster. Some of you may know him, and he's discussing the tools and skills for a data science newbie to understand complex production data structures. And then track 1, we have Kieran Conliffe on creating your own domain-specific language and the tools and challenges that he faces with it. So over to Kieran.
Sure. So hello everyone, and welcome to Creating Your Own Domain-Specific Language for Fun and Profit. My name's Kieran Conliffe, and I'm here today to talk to you about language and complexity. Complexity is a tricky thing in software engineering, which I think is a side effect of the way we're taught how to program. We're given these techniques and then we're given simple examples to use them in, which is all well and good when you're just learning, but it trains people to expect simplicity. And then you get out of university, you go to the industry, and all of a sudden very complicated things are thrown at you and you're expected to understand them immediately. Things like this. This is the Goose Game. This was very popular back in the 18th and 19th century. It was one of the first board games printed in Europe with a custom board. And this presentation of it is extremely complicated. But it's also a great demonstration of the different ways that something can be complicated. In his 1986 paper, No Silver Bullet, Fred Brooks defined two different types of complexity. Essential complexity, which is how complicated a problem is in and of itself. In this case, the game is quite tricky. There's a load of special spaces, and if you land on them, weird things happen, and it's a lot to take in and learn. But also, there's accidental complexity, which is the complexity that we add to a problem through how we explain it and how we implement it. The explanation here is a big block of cursive that's quite hard to read, and the implementation is this whole non-linear arrangement of circular squares and muddy illustrations. It all adds up into something very complicated and very hard to understand. What I'm here to talk to you about today is a problem that I had to deal with 10 years ago that was extremely complicated, and how we used a domain-specific language to help strip away all the layers of accidental complexity so we could deal with the real underlying problem. Since I work for Liberty IT, it shouldn't be that surprising that the problem involves insurance. More specifically, it involves the fundamental difference between insurance here and insurance in America, which is driven by Americans' love of freedom of choice. Over here, insurance is fairly simple and straightforward. Your home insurance is how much does your home worth, how much your content's worth, here's your quote. Car insurance, what type of car do you have, how old is it, what's your driving history, do you want third party or fully comp? In America, it's much more customizable, and there's all different ways you can tune your insurance. If you're insuring your car, you can say, I don't want to insure my windshield. I do want to insure my windshield, but if it's damaged, I'll pay the first 150 quid. I do want to insure my windshield, but only up to $1,000, and then anything beyond that I'll pay myself. Multiply that by all the other different possible coverages, which is what we call them, such as uninsured motorist coverage, where an uninsured motorist runs into you, or accidental coverage, or collision, and you get a very complicated problem. The second layer of essential complexity of the problem, though, is that America is composed of 50 different states, each with different laws and regulations around insurance, and those can vary greatly. Texas is completely different from Massachusetts. That speaks to the fact that all those states have different cultures, which means that your marketing teams have different strategies that they want to apply. So you might have exactly the same coverage in two different states, but with a different name because they decided that one would appeal more. The third layer of complexity is that this isn't static. All of these change over time. Obviously, your marketing team want to do different things as time goes on, but also the laws and regulations are constantly in flux. At one stage, I was coming into work every morning and checking the Florida local news to see whether I needed to push a particular change to production, because they had allowed their law that you needed to have insurance to drive lapse, and they didn't have time to get through a new law in time. So there was a period where you didn't need insurance to drive, and it was going to become law again, but we didn't know when. And as soon as they actually scheduled the law to go through, I was able to push my change to production to put that back into force. That's where I come into the problem, by the way, which is that I was responsible for an application that customers could use to service their policies online. So they could register their policies, they could pay simple bills, file simple claims, and view what coverages and options they had on their particular policy. This is not that application because it's a lot easier for me to clear this stuff with our legal and comms department if it's an obviously fictional example. So this is a mock-up, but it is straightforward analogous to how we would have presented home insurance in that application. Just for the rest of this, I will be talking about space stations instead. This is actually the simplest possible iteration of this problem, because we're just reading in what's on your policy and showing it to you. And that would seem to be fairly straightforward, but this one screen was responsible for 75% of all production defects in that application. The reason for that is, A, it's a very complex problem, but B, this is how our requirements were set out. Because I said this was 10 years ago. This was the era of waterfall, where you had these gigantic requirements documents. And so we had about 100 of these packed into a Word document about how different coverages might be displayed in the app. This is really hard to parse. It's hard to translate into programming code. It's hard to test it and figure out what the different cases are. And what you can't tell from this is that it's actually missing key information. For example, that Martian oxygen coverage, we need to know that in 3 pages time for a completely different rule. So we would have code in here to record that, but that's not expressed in the requirement. Luckily for us, the whole internet thing kind of caught on, and it became more important as a tool of communication with the customers. And that meant that there was a lot of focus on the application, and we wanted to scale it up. We wanted to make it a better user experience, make it easier to customize, and that gave us the opportunity to rewrite this particular page and change how we handle these requirements. And my architect at the time said, why don't we use a domain-specific language for that? And I said, what's a domain-specific language? What is a domain-specific language? Well, it's a language that is specifically designed for solving problems in a domain. Simple. This is as opposed to a general purpose language. Most programming languages are general purpose, so C or Java are designed to solve problems across all possible domains. There are 3 main categories of domain-specific languages. There's markup languages, like HTML, which is designed for the domain of how do you display a web page. There are domain-specific programming languages. My favorite example is Twine, which is specifically designed for producing interactive fiction games. And then there are domain-specific modeling languages. They're a bit different because they don't directly feed into computers. They're more designed for helping you to specify problems at a high level. And as a result, they're usually a lot more custom, and building your own is usually what you would do in our type of situation. So it seemed like a good fit to us. It seemed like it would solve our problems. However, we did have to sell this to the business side of things. This was a technical solution to a business problem, which is always a tricky sell. So we flew over to this lovely building in Portsmouth, New Hampshire, and sat down with them and went through the possible benefits. We showed them all the defects that could be tracked back to that particular screen. We showed them our projections for how long it would take us to code and test the screen with the current state of the requirements. And they were convinced. They said, like, yeah, no, you've sold us on this, but we'd like to do a little time-boxed experiment to prove out the value of this. So myself and 2 of our more technically minded business people, Andrew and Nama, who were brilliant, and I was really lucky to have them at the time, we went into a room and sat down and said, okay, by the end of this, we're going to come out with an approach for documenting our requirements in an unambiguous way. So the first thing we did was go to what we currently had and start diagramming it out. So on this particular example, what's in red is the criteria for taking particular actions, and what's in blue is the actions that we take. Now, a few things become apparent as soon as you do this. The first of these is that this is an awful way to document this, and this shows the shortfalls of human language for documenting it, because all the red and blue are completely mixed together, and it's not necessarily clear which relates to the other. The other thing is that there are loads of possible outcomes, there are loads of possible criteria, there are actually multiple rules bundled up here together that all relate to the same thing. So we started pulling those out and creating atomic clauses which were the words of our new language. And this is what we pulled out of that particular requirement, and we were able to collapse things together like, okay, there's a few different things that relate to specific planets. So the planet that you're at is a clause that has a variable into it, which is the specific planet, that sort of a thing. And we also documented the actions, and we added in the actions that we knew weren't documented. And we repeated this for a whole bunch of these different requirements, and we were able to go, okay, let's find some commonalities, let's start collapsing things together a bit more. At that stage we had, okay, here's how we can express this, but how do we document it? What's the best way to communicate it? We could have done another big document out or a big wiki page or something, but that would still have been fairly indecipherable. So we decided to go with a business solution, which is a spreadsheet. And I mean, spreadsheets get a bad rap, but in this case it was good. It allowed us to put some structure on the way that this was expressed. So in this particular example, each row is a single rule that will have a single output, and each of these columns is a criteria. And we have it set so that a criteria is, for example, planet, and then each cell is a variable that that rule feeds into that criteria. And one thing with this is we have to be careful that these criteria don't overlap. So you might notice at the start we have a rule that it applies to orbital stations, and then every rule after that says this rule doesn't apply to orbital stations, so that we don't get confused. We also documented the actions that we would take based on those rules, and that includes the functional ones like the label we're showing or the format we're displaying the amount in, but it also includes things like the display order and so on, because we needed to document that somewhere, and this is as good a place as any to do it. So we had this format for documenting these unambiguously, and the business were delighted with it. They thought the experiment was a success. They were happy to go forward with it. We had other plans. We wanted to take this a bit further. So you might notice the second row there has what looks like pseudocode for each of those rules. And that relates into the other big cause of errors on that original page, which was programmers having to take these rules and put them into code. Now that we had these stated unambiguously, the next logical step was to automate turning them into code. So we chose to do this through a rules engine, and we chose Drools as our rules engine. It was a good fit for us because it's Java-based, and this was a big Java project. It was also handy that Drools stores its rules as simple text files, so we could have a Java class that just fed in our spreadsheet and knew this column turns into this line in Drools, and I just drop the variable into it. In this particular case, then, the way this acts is the code that's using the engine has a request parameters object and a list of coverages, and it feeds them through the rules, and the rules say, okay, set these extra fields on the coverages and then add it to the list that we pass to the client. And then the client is able to read these fields and use that to drive the display. And each rule is named so that it maps back to the specific spreadsheet row, so if there's an issue, then we can trace it back and go, okay, that's where that exact problem is in our requirements. We did still have to test all this because automation is a fantastic way to more efficiently make mistakes. And so we decided to use FIT for that, which is the framework for integrated tests. It's not really used that much these days. FitNess is sort of its successor, but it was what we decided to go with. The big advantage was that the actual input test cases is these big HTML tables, so it was fairly easy to put that in front of the business and get them to verify it and build out tables using HTML editor. The way it works is it has a piece of code called a fixture that reads this in and then feeds that into your rules. That was actually a bit of a pain point for us because that fixture was quite complicated and we wound up having to test it. And whenever you're getting defects in your testing code, that's a sign that things have gone wrong. But the other problem with this was actually really good for our initial release. When we had a big bang, we had a huge number of these to cover. But as time went on, it proved a bit brittle, and updating it became a bit of a pain. But what did happen when all of this came together? Well, basic result was that all the defects from that page that had been 75% of all our production defects dropped to almost zero. And that's not just the defects that came in from that accidental complexity where people had made errors in terms of taking the requirements and turning them into code or transcribing the requirements, but also the logical errors. Because it turned out that the business were now able to see much more clearly what their rules were and what their requirements were. And they were able to make more intelligent decisions about what they were going to do and not be caught by unintended consequences of changes. So that was really good. The only real problem was that we became victims of our own success because people would come onto the project and go, why do you have this whole complicated process for this page when you don't get any defects on it? And it's like, yeah, no, okay, so what do you think we would do? And then if people actually had good ideas for changes to it, we just took their ideas and rolled them into it. But usually once people saw the underlying essential complexity, they started to understand why we needed to do this. So it's the future now. We live in 2020, 10 years later. How would I do this if I had to do this again today? Well, number one is like lessons I've learned from this. Separating out, I mentioned like we had issues with the testing, and the root cause of that, I think, is that we were separating out the requirements and the tests, which is a consequence of using waterfall, but luckily we're all agile now, so we're not really tied into that. So I would find some way to bind those together a bit more. We were kind of constrained by the data as well. Like we were only one of multiple applications that used the same back-end services to handle this data, and a more modern pattern like a system of engagement would help us to separate that out. And the other thing is the actual underlying architecture. So again, this was 10 years ago. This was a SOA project. I don't know if anyone remembers SOA, but it was the first attempt at doing microservices, and it was really just monoliths with an API on the front. And I think modern functional architectures and serverless architectures would actually be a really good fit for this in terms of being able to deal with each rule on a more atomic level. So at a very early, like just with a quick amount of thought, here's kind of how I would do this today. I'd probably still go with spreadsheets for the requirements capture. It worked fairly well. Again, like you're getting the business to put this in is a great way to get data in a coherent format from non-technical people. And there are much nicer tools in terms of collaboratively using spreadsheets and tracking the history of them, which was one big problem for us. Source control at the time did not like Excel spreadsheets, so it got kind of tricky. In terms of the testing, I'd probably go with Cucumber. I think like BDD is actually very closely aligned to what we were doing in terms of building out this language, and Gherkin is really just a way of creating a domain-specific language for your testing. So, and I think it'd be fairly easy to automate having your requirements go over into Gherkin scripts and sort of feed in variables. So again, like you wouldn't have to maintain them entirely separately. For the rules engine, Drools is still around. JBoss maintain it now. It's quite nice. It's got like a graphical front end to it now, so you can see your rules as tables and map them out and so on. But other rules engines are available, and as I said, I think doing this in a serverless way would probably give you a lot more options in terms of coding it yourself as opposed to relying on a rules engine. So that'd be fun. So it'd be good to dig into. So what have we learned from this? Well, if you're faced with complicated requirements that are really difficult to understand, break them apart and build them back up again in your own language. And that way you can state them unambiguously. Once you have things stated unambiguously, then automate turning those into code so that you're taking out any human factors in the error. But still make sure that you're testing everything and that you're not leaving yourself open to having mistakes go out there without you being in the middle to intervene. Lastly, remember that even though you're automating this, even though you're creating this magical language for it, people are still going to have to deal with this. You need to make sure that this is something that people can comprehend and work with. Going back to the Florida example, I had, in that particular case, I didn't want to be in on the specific date when this change went live, but luckily we'd had added rules clauses that let you say this particular rule will become effective on this particular date. So that was all taken care of and I could push my change as soon as I found out rather than waiting until the day. So hopefully this will all prove useful to you, and thank you very much.
Another fantastic talk from Kieran, another reliable speaker there. We now have a couple of videos coming up just from our sponsors, Signified and Instill. So have a look, check out their culture and life at these companies.
Well, back in the day, there was no Stack Overflow, no Mozilla Developer Network, nothing like that. And most vendors charged a subscription for their documentation and for their developer content. So it was our job to be the provider of the information that developers needed. But these days, developers are drowning in documentation, blog posts, tutorials, all kinds of content. So our job is to kind of be a tour guide, and to educate them to the point where they can navigate the sea of information for themselves.
I'd say from a technical standpoint, for actually doing the job, not really. The proliferation of free tools, tutorials and information have meant that we've got some excellent developers who have been self-taught and learned through engagement in non-academic activities. But saying that, a degree will make it easier to get your foot in the door, and a higher level degree will usually command a higher starting salary. But within a few years, this usually levels off and the degree doesn't really pose much of an advantage. But in the current climate where students are learning remote and paying £9,000 for the degree, there may be a shift in the industry.
In terms of programming trends, we definitely live in interesting times. We see Kotlin and Scala continuing to drive innovation on the JVM, with many new features being added to Java as a result. TypeScript is popularizing new ideas like structural typing and type-driven development. There are new programming languages growing in popularity, like Rust, Elm, and Reason ML. Then thinking beyond languages, serverless continues to rise in popularity, and also NoSQL databases and machine learning and so on. They continue to make steady progress into mainstream IT. So there's an awful lot going on.
Just do it. Just get out there. Talk about something that you're passionate about and excited about. And if you're excited about it and you put that into your content, other people will respond naturally. I would say rehearse, and also don't try to bite off more than you can chew. I've seen some good talks go awry whenever people try to do too elaborate live demos and things like that there. So start off small and work your way up. But yeah, just get out there.
The Belfast office is not just an engineering centre. They have our risk team, data science, so it's kind of that they're growing the whole office as opposed to just that kind of engineering side of things.
So the main technology I'm using at Signified is mainly Java-based languages along with Amazon Web Services and the likes of Cassandra for a database.
We are deployed within the cloud, so we are a SaaS-based company. We leverage Kubernetes and AWS. The thing to say really about our tech stack is I can tell you what we have today, what we have tomorrow. I can't tell you, but we are continually evolving that tech stack so that it meets the business and technical requirements of the platform.
It's quite a challenge. You're building things from the ground up. So other companies might offer just like fixing old products or kind of adding new features on, whereas we're building things from scratch.
One of the things that attracted me to Signified was the idea of small teams. So 4 to 5 people on a team with a principal developer in each team means you're not getting lost in a load of people. It's one of the most attractive Java opportunities in Belfast.
It's an agile environment where there's 2-week sprints. So really anybody can get up and take a task on the board and take it right through from design to implementation all the way through to production.
Everybody chips in, so there's a hands-on approach. So you're involved from the design, DevOps work, testing as well. So there's a real kind of broad spectrum of work you take on.
We roll up our sleeves, we get on with it. Nobody at Signified will tell you how to do your job, but we're all there to support each other and make sure that we're all making the right decisions. If anybody needs help, we're not afraid to ask.
Every year Signified hold on-site meetups for everybody in the company to kind of gather in San Jose. So in May I got to head out for a week and participate in a hackathon and different activities for it.
You do turn around and help other people, you come together, and it's quite like a family in that way. You know, it's got a lovely environment to it, and it's a lot of hard-working people, which I really value that really highly.
And a big thank you to those sponsors. Make sure to check out their booths at the expo. Now, next up on track 2, we have a talk from Paul McBride, the personable tech educator, developer, and general tech enthusiast that many of us know. He will be talking about the history and use of state machines and introducing state charts into JavaScript. On track 1, we have the well-known Emma Mulholland of Instill, known for also her accomplishments outside, such as co-founding Product Camp Belfast, Product Tank Belfast, and Lean Coffee Belfast. That's quite a lot. She'll be talking about empathy as a superpower, and we'll hear about empathy, what it is, and why it is important when you're building products. Over to you, Emma.
Instill, I think everyone knows, has been around for the last 15 years as a local software company and works with many cool clients. The exciting thing that's happening in Instill at the moment is that Instill is actually moving towards product creation as opposed to just software creation. So we've now got designers and product people. So it's an exciting time at Instill at the moment. Okay, cool. So what exactly is empathy? The word gets thrown around a fair bit, and people seem to understand what it is. However, it's sometimes misunderstood. I want to explain it, putting it in place against sympathy, because they often get mixed up. So actually, firstly, empathy is sometimes kind of presented as this superpower, this alien thing, this other thing that doesn't really apply to us. And that's a bit of a disservice that sci fantasy has done. So you've got like Mantis in Guardians of the Galaxy, or even Spock. But actually, empathy is an innately human trait. And in this talk, I want to explain that it's also a skill that you can learn. Okay, so definition. It's the ability to share someone else's feelings or experiences by imagining what it would be like to be in that situation. And it's the imagination part that's critical, and that I'll come back to later. And this kind of contrasts with sympathy, which drives disconnection. So it's less about being on a par with someone and sharing that experience, and more about kind of almost looking down on someone with almost like a patronizing feeling. Empathy drives connection, whereas sympathy actually drives disconnection. So a nice way to think about empathy is that basically you've fallen into this hole, and it's dark, and you're stuck, and you're overwhelmed, and someone comes along and they look down into the hole, and they're saying, oh man, that's a sticky situation, that's not great. And then someone else comes along and they climb down into the hole with you, and they say, you know, I've been here, I know what this is like, and they stay there with you. It's a really nice thing, and it's a connecting thing. This actually exact example was used in The West Wing. I don't know how many of you are West Wing fans, but it's part of the storyline. Josh Lyman was shot, and then he suffered from PTSD. And there was like a critical episode where that was explored, and he became really scared that he'd lose his job. And he was told by Leo, he was chief of staff, Like, I know what this is like, and I've had my troubles, and as long as I have a job, you have a job. It's kind of that I got you feeling. Okay, so what are the elements of empathy? So the example I was talking about earlier, that was in a video by Brené Brown, and she calls out these 4 elements of empathy. So one is perspective taking, staying out of judgment, and that's a difficult thing to do as humans because we innately judge people. Recognizing emotion, and then communication, the recognition of that emotion. So why is it important? It's important for like many, many reasons, but especially for us as software developers and product people and in the creation of technology products. That's actually easy to do. And I know it's a little bit flippant because I do understand it's difficult and developers are very skilled, but actually you can create technology and software fairly easily, and it's the people bit that's hard. People as in working with people, but also in the creation of usable, desirable, delightful products. Kind of empathy and that usability factor is the differentiator in technology nowadays, and that can be quite difficult to get. Not only that, but it's also an essential skill for the future of work. There are a number of studies that have called this out, that in the future as things become automated, emotional intelligence and skills like empathy will become critical for the workforce. So this is a McKinsey study that shows how that difference is going to happen, but also the OECD has called it out as a key skill for children, so they're trying to get into the curriculum as a key skill for 2030. Okay, and how do we use it to build better products? I'm going to go through this section quite quickly because this could be a talk or multiple talks in their own right, but that's not what I want to focus on, but it's just to highlight how we use it in creating products. So always, everywhere, everyone, empathy is used at every stage of the product development process and in every role. So I'm not saying this as a product person needs to be empathetic and designers need to be empathetic. Everyone needs to be empathetic in order to make awesome products. But specific areas that empathy is used is within your immediate team, within stakeholders in the kind of the wider project, and to talk to your end users and fully understand them when you're building for them. So here's some tools that you can use to improve your team dynamics. Firstly, understand yourself as an individual and then understand each other as individuals. I will hit on that later on in the talk. Secondly, have really good feedback loops. So this is tools such as retros, or just give each other individual feedback in the moment. You can create the team canvas, that's what I've got up here at the moment. So that allows the team to discuss their values and how they want to work. And it's a living document, so you can return to that and just keep everyone aligned. And all of these different elements then create psychological safety. And then with stakeholders, you see all the time, and it starts to drive me a bit mad, this concept of stakeholder management. You know, as if they're this outside thing you've got to control, but actually I prefer the concept of stakeholder engagement. And this is where you use your empathy to understand your stakeholders as humans individually, and then to start to bring all your stakeholders together to align them to your common purpose. So this diagram is shuttle diplomacy, which is a tool to kind of engage stakeholders. And finally, users. And this is the core part of a product manager's job and a designer's job. It's this whole concept of fully understanding your user's world and making sure you're building to meet their needs and goals and to solve their problems. The thing that I'd say at this point is user research. It's not just the quantitative side or even the sort of surveys and getting that user feedback. To be truly empathetic and to actually get it, I'd highly recommend immersive user research. So this is where you go to your user and you actually fully immerse yourself in their world. So you're understanding not just how they're using your product, but everything around it, their environment and all the other things they're using and all the other things that are going on in that situation. And that will make sure that you truly understand and truly empathize with them. Okay, cool. So kind of covered what is empathy and why is it important and, you know, all of that. How do you actually start to improve your own empathy skills? So the first thing, and the thing that we're going to talk most about, is know yourself. This sounds like a pretty strange thing to say, but actually very few people are self-aware. Before you can start to imagine other people's worlds, as we understood the definition, you actually need to fully understand your world. You need to understand who you are, why you think the way you think, because all humans are completely different. We all have an individual view of reality because there isn't one objective view of reality. This model is called steps of inference, and it shows how you actually end up with your thoughts and your behaviors. And it also shows how that they actually amplify themselves. So as you start to create this version of your world, you actually amplify it, and it kind of becomes more and more embedded. And the thing about this is, the critical thing that you've got to understand is that as human beings, we have all these shortcuts in our brains to help us understand the world as quickly as possible. So these first steps where you observe and select data that you're going to start to interpret, we've shortcutted that with things like stereotypes and biases and all these patterns and heuristics. And they're going to be subjective and they're going to have biases. And you need to start to understand those, because you need to be able to decouple those so that you can start to put yourself in other people's positions. And the scary thing is that we find it hard to understand ourselves, why we think the way we do, but the outside world is actually controlling this so much more than it ever did. I mean, every time we interact with technology and screens, it's not the same thing that every other human is saying, because all these companies and all these how little control we have over our own reality anymore. I mean, we're all in this, the quote they use is, we are all inside our own Truman shows. So even before we had technology, the process of understanding ourselves was hard. It's so much harder now, and we have to make like an active effort to try and break that and understand ourselves more. Okay, so how do we become self-aware? The first thing I'd say, and actually I should probably put this afterwards after I've kind of told you the tools, but actually becoming self-aware is going to be difficult, and it's going to be really painful, because obviously we all think that our view of reality is good and real, and you know, and all the rest of that, and starting to understand like how people perceive us, and starting to like understand our behaviors and try and change them is really very difficult, but it is so worth it. Okay, so tools and techniques to become self-aware. The way I like to think about this is, if we're all like viewing the world through this lens, this is how you start to clean that lens. Hence my little Lego man. Okay, and the first thing you do, and this actually gets used in sort of counselling and therapy a fair bit as well, is to create your own timeline. This might sound like a strange thing, but every single person is basically the output or the outcome of their life experiences, their culture, all the interactions they've ever had, good and bad. And if you actually spend some time to step back and map all of that out, you'll start to understand why you react in certain ways. And sometimes things that are happening in your world today, or how you're reacting, is actually the result of something you've experienced in the past. And sometimes we overreact and we get angry, and it's actually all linked to other events. This is why I put the Marvel timeline up, because essentially it's a whole myriad of different characters and different timelines and different loops, and that's kind of almost like a human being. I mean, we have a chronological timeline, but its impact and how everything happens can be out of time as well. Okay, so other things that you can do to become self-aware. Start to notice how you react to things. As painful as it might be, things that really piss us off and really frustrate us, especially in other people, are often things that we do ourselves. And so we have this mirroring effect, and actually taking the time to reflect on that and understand what's frustrating us, that probably leads us to understand ourselves more. Get feedback, and I don't mean this in kind of a platitude work way, you know, I'm great and need a promotion. Get 360 honest feedback from people in your personal life as well as your work life, and listen to it honestly and reflect on it, because this will also most probably be quite different from what you're expecting, and that's a good thing because it will help you understand yourself. And this is an ongoing thing as well, because you will start to change and you will get more feedback, and it's an ongoing process. All of this is an ongoing lifetime process. Journaling. This isn't something that just, teenagers do, like writing in their diary in the evening. This is actually something that's useful for all humans, and we should be doing it on a regular basis, giving ourselves the headspace to kind of critically reflect on ourselves. And then mindfulness is a really helpful tool. I personally have got really into meditation since lockdown, and Headspace has been a complete game changer for me. But mindfulness in general is separate from meditation, which is one form of it. But essentially mindfulness lets you start to understand a situation and feel everything associated to it, and kind of just stop reacting and pushing emotions away, if that makes sense. Because what you need to start to do to empathize and to understand yourself is to start to just let yourself experience these emotions, and then start to understand what other people are feeling as well. Quite often we don't even know what we feel, and we either push it away, or we react too quickly, or we externalize things. And just allowing yourself to do that is really powerful, and again, also quite difficult. And then finally, once you've kind of started to understand yourself, you can create a user manual to share with others. And this is one of the steps that I would recommend to do as a team, is to start to kind of compare and contrast how all of you operate as humans. So this particular one was created by Stephen Limmer, who is a local Agile coach. I do know that other companies do similar things. Atlassian has a playbook of lots of tools and frameworks, and one of theirs is a user manual as well. Okay, so that's self-awareness, which is the first step to becoming empathetic. But then what else can you start to do? So read from a diverse range of source material and diversify your social media and your social circles. This is linking back to that whole concept of our world is controlled by algorithms. And yes, it might be nice to think that we, have the one right view of the world, but that's not actually true. And yes, it can be upsetting and frustrating to follow people on Twitter or other social media platforms that you disagree with. But the truth of the matter is that, the world is made up of lots of different humans, and if you close yourself off from lots of different views, then you are removing the ability to be empathetic. And I'm going to keep going because we're losing time. Okay, then there's this empathy model. This was created by Helen Rees, who is an associate professor at Harvard Medical School. She has done a lot of research into doctors and psychiatrists and their patients, and she, from a neurobiological and point of view, and she found that this model actually created better outcomes because you can actually measure and track empathy, and that's what she was doing. So, takeaways. Empathy is a critical skill, but you can learn it. Self-awareness is the key. Yes, it is difficult, but what I would say is be kind to yourself throughout this process, because it will be difficult, and then be kind to others. And that's me. So thank you very much.
And a big thank you to Emma for that thought-provoking and informative talk. Now, it provoked quite a few thoughts, so we have quite a lot of questions from the audience here.
Oh, no.
Oh, yes.
Really? That's worrying. I wasn't sure if I should be nervous if I didn't get questions, or nervous if I did get questions.
Well,
Okay.
Now we know the answer. So at the very start, you were talking about the empathy being innate human nature and also a learned skill. Mm-hmm. Which path did you find yourself on?
Both. I am innately a very empathetic person. So do you know if you walk through an office and you walk past people and you can immediately tell how they're feeling, or you start to feel it? That's something I've always had. But it's something that I've also been working on, and specifically the last couple of years have actually been quite difficult at different times. And the reason that I had to learn to become more empathetic, to understand people, to understand situations, to start to make them better. So it's a bit of both.
Did you find there was maybe one tip that you thought worked really well for you to improve your empathy?
Oh, man. I think, well, we used tools in a situation before that basically you start to walk through with someone, like, this is what I need, and what do you need, and how do you, what do you value? Do you know what I mean? So actually having open and honest conversations with people about about their needs. It's almost like that user manual, that actually is a real critical game changer, because how we perceive the world and how we want to be communicated to or loved or many other things is very different to how other people want to be. So you need to understand that as a starting point.
It's really hard to read and ask at the same time. Please bear with me. So you're working on your empathy, you're trying to get more people to realize its importance. Have you ever met people that think they're empathetic but aren't really?
Yes, sometimes. And sometimes I'm sure I've even done it, where you think you're empathetic or you want to be empathetic, but it can be really difficult to be empathetic when you disagree with people, or be empathetic when you don't agree with the course of action that's happening. So that can be difficult.
In a lot of the things that the people before in human nature, there's a bias. Is there a way to find out about a bias that people have without just outright asking them?
How can you find out if someone has a certain bias? I don't know, because it would depend what the bias is, I would say. So, for example, people have biases about how they want to absorb information, which sounds strange, but some people are visual communicators, whereas some people like lots of detail and words, and some people don't mind being told information in the moment and being able to respond to it, and some people actually are reflective thinkers and need. So, I mean, a way you can find things out like that is just experiment, which is actually a bit like product in general, is that you kind of start with an assumption or a baseline and experiment to work out if it's valid or not. Which almost sounds like you're testing people. That almost sounds wrong in its own right. But yeah, I guess you could experiment.
Is there something you would recommend people reading to learn a little bit more about this?
The Helen Rees is actually really good around all the empathetic models. Yeah.
Helen Rees, and quite a few people enjoyed your materials today. Do you share your slides and the likes of the template that you had on the Team Canvas slide?
Yes, I can make those available.
With Twitter or something like that?
Yeah, I can tweet that out.
There you go, on Twitter. And there is one last question that is, I think, rhetorical. This was awesome.
What?
The question is, this was awesome.
Oh, thank you very much,
Emma.
Okay, cool, thank you.
Now, let's see what we have on the next track. And next up on track 2, we've got Andrew Bolster talking about the tools and skills for a data science newbie to understand complex production data structures. And on track 1, Kieran Conliffe, who'll be talking about creating your own domain-specific language, tools, and challenges.
Hi, welcome to my talk at NIDevConf. This is Developing for Developers. So just for context, hi, I'm Claire. I'm an accessibility advocate and a software engineer at Carrick in Belfast. And you can see on the slide my Twitter, my handle on Slack and everywhere else, that sort of thing. So what I'm going to talk today about is when you're developing something that's going to be used by other developers. So the differences that makes in how you develop and what you have to think about compared to if you were building a standard site or app that would only be used by your end user. So the first question really in this is, what is the thing you're building? There's a couple different areas of development that cover building things for other developers to use. So an API perhaps where you're providing data for other people. There are frameworks, so if you're building something like React or Angular, that is going to then be used by other people to make their own app. There are plugins, so like Python libraries, NPM plugins, things that someone might use as a small part to give them a bit of extra functionality in their own app or site. And then there are component libraries, which is what we're going to talk about today, which is mostly where you build components that someone can then use to build up their own site or their own app without having to do all those tiny pieces of development themselves. So what are the biggest questions in this? And then we'll sort of come back to how this affects things as we go through the talk, is who are you building this for? Are you building it internally to people that work in the same company as you, that are maybe just going to use it within other apps that are built by the same company? Are you building it for a client? So maybe you have to build it for a set date and then you hand it off and you never see it again. And that might be, they might be planning to use it in a different way. from if you were continually working on it internally in your own company? Are you building it for customers? So in the example of an API, people might be paying you for access to the thing that you're building. Or are you building it for the general public? So something like React and Angular and those things that we talk about, where everyone and anyone on the internet can grab the thing that you're using and build it into their own project. And those things will affect things like how you document it and how you build it and how you tell people about it. So we're going to focus on component libraries, mostly because that's where my experience is. But a lot of the things that we'll talk about through this will apply to a couple different areas that I've talked about, and things like APIs and frameworks as well. So when you're building a library, when you think about the whole library altogether, there's a couple things that you want it to be. You want it to be cohesive, you want it to feel like I have this set of components and it makes sense and it works together, and I can basically build an app with these components or build a site with these components and it seems logical and it fits together. You want them to work side by side so they can be on the same page. You can have a button and an input and a menu on the same page and they're not clashing with each other or causing any difficulties that way. You want them to be consistent as well. So if I use a button in one place and then I use a slightly different button in another place, I want it to feel the same. I want to know, okay, I've done this before and it worked this way, so this is the way it'll work again. And you want it to be familiar, particularly this counts with things like material design and things that are quite famous, because it means that if somebody lands onto a site that's using this, they already know how things work. This also counts whenever, the example we talked about, if it's something internal. If you're building components and your company is going to use it in 3 different apps, they will want the experience of those 3 apps to be consistent for their customers. They'll be like, the menu is always in the same place, the toolbar is always the same color, things like that. So you want that consistency, and component library is a really good way to do that. That means that you're not having to do the same work over and over again. You have that consistency built in the one place where these components live. And when we look at the individual components, which is the other side of this, the first question is, what are these components? And that's really sort of part of what we're going to cover today. The components are the building blocks. So if you have a component library, you're really building all the little pieces of the things that are going to go together to build your site or your app. Ideally, a component would be the smallest thing that you can whittle something down to. So you wouldn't make a component that is an entire page, because it doesn't provide enough flexibility and it's not likely to be reused multiple times. So you want something that's like small and sensible. You want it to be reusable, so you can say, okay, I have it on 3 different pages. Partly because that's the whole benefit of a component library, is something that you can use multiple times. If you're not going to use it multiple times, do you even want to put it in your component library? There will be things when you're building a site or a page that you only ever need once. So you wouldn't put them into a component library, because you're sort of just doing that work. Unless you think in the future you're going to use it somewhere else, you're just sort of doing that work in the wrong place, and you might as well just build it into your own app. And the most important thing with components that come into a component library is that they have to be customizable, because chances are, and I'll sort of go into this with an example later, it's not going to be used exactly the same in every place. You're going to want maybe slight variations depending on where you're using it and what the intention is on that page. So the first thing I'm going to talk about in this section is, as we get into actually making the components, is looking at your work and figuring out what should be a component that goes into a component library. So the first thing you want to look at is the user has a task that they want to complete, something that they want to accomplish. They will have a certain goal to get through, like a page or a section of a page on your app. And the first thing to look at often is, does anything like this already exist? If you already have a component library, this might be a case of looking at the components you've already built. It could be that you go, well, we have something that's really, really similar to this, and if we make just the tiniest tweak, we could have this already existing. So say, for example, you have a side menu that slides in and out whenever someone clicks on it, and you need a menu that stays put all the time. You're not going to want to build a whole second side menu for that, because it's just a small tweak to the functionality. But what you might do in that case is say, okay, we could just make a small like check or wait for someone to customize this and say, yes, it's the same component, but it behaves slightly differently. The next thing you want to look at is, what does the user expect? What are they used to within your app, and what are they used to in the wider world? If I'm making a date picker, I will look at how do booking websites do it, how do planning websites do it, you know, what are people used to? I don't want to build a date picker that's completely new that no one's ever seen before, because most likely people will just be confused and not know how to use it. The next step after that is you also need to figure out how will it fit in with the place that you're using it. So if I'm using this component within a website, I want to say, okay, it has to look like the rest of the page that it's on. I want to have the right color scheme, I want to have the right feel, the right kind of interactions. I also want to be solving a problem just once. I want to be saying, okay, this solves this problem, and then I won't have this problem again. Not just this solves this problem for this very, very specific use case, but ideally we can solve this problem in a way that we have solved it for any time we need to do this thing again. And then, as we talked about it, we also want it to be flexible. We want to say, okay, if we're solving this problem, that's great, but we might have very slight different ways that we need to solve this depending on the context of the page, or the different app even that it's in. So we want to be able to build in a little bit of that flexibility to say, okay, if we need to change a slight thing, we can. So when you come down to actually starting to build the component, the biggest thing whenever you're building for other developers is what you need to think about is how will they use the component that you're building, because you're not just building for the person that's sitting on the other end looking at the website, but you're thinking of, if I was sitting down developing, building this, using this component to build my thing, what would I want, what would I need? So the biggest question on this is these first two bullet points: what is external, what is internal to the component? There will be certain things that I want to say, the component works a certain way, it has a particular task to accomplish, and certain amounts of that functionality should be built in because they will always happen. If I have something where I need to put in a number, say a range of numbers, a slider, the behavior of that slider should be built into that component, and we don't want someone to change that every time, because then it's not really doing anything. The component really isn't a slider, it could be anything at all, and you haven't really accomplished your goal. But there are other things that you do want to expose that will allow developers to sort of customize it for their context. So in the example of a slider, you might say you can change the jump. So if I'm going, I might say sometimes I want it to go 10, 20, 30, 40, but then other times if I'm working in a much wider range of numbers, I want it to jump up 100, 200, 300. So you might say we will expose the ability for people to change the step of the slider, but we won't expose the basic functionality of, like, say, how someone drags the numbers up and down or steps the numbers up and down. Because if they change that, then it suddenly doesn't behave like the component we've designed and doesn't fit in with the rest of our library. We also want to think about how much we want to be able to customize in terms of, say, if I have a button, do I want people to be able to put icons in that button or not? Do I want people to be able to change the size of something? Do I want to say, okay, if this is the header on my page as a component, do I want people to be able to change how big or small that is? Maybe not, because it would change how that page works, but do I want people to be able to change the color of the text that sits over the image? Probably yes, because we want it to fit in with the context. One of the biggest things for me in building a component is we need to be able to build for localization, and we need to be able to build for accessibility. So this means that, say if I'm building an app and I know that I will have users in 3 languages, I don't want the text to be built into these components in such a way where I have to build, say, an English version of this component and a Russian version of this component and a German version of this component, because that sort of ruins the benefit of having all these components, and that leads us down a path of having different sites and different builds for every language. So in that case, what you want to be able to do is let someone pass in the text so that they can say, okay, I'm giving you the localized version, so this will work the same place everywhere. And the same with accessibility. There will be certain things where you can handle the accessibility inside the component yourself. So if someone says, like, say a tooltip, and they pass in the text that the tooltip should say. Inside that component, you can build in accessibility functionality to say if someone is focused on the component, that it also reads out that text, because a person with a screen reader won't see the tooltip. Whereas there will be other things where you say if someone is passing in an image, you might say, okay, I'm going to make it a required part of this component that they have to pass in descriptive text for this image. So it means that you're sort of enforcing people to do the best way of using this component and the best practices web-wise. So you can say, okay, in this case you have to pass in this thing, and if it's not passed in, it won't work. The other big thing with building a component that you have to think about, especially in modern web dev, is frameworks. A lot of people who are using your components might be using a framework. So whenever you're, say, building inside your own company, as we talked about, this might be an easy call, because it might be a case of the whole company uses this particular framework, say it was React, everyone uses React, and therefore all we have to do is make sure our components work with React, we can build them in React, that's all fine, that sort of solves that problem before we've even started. On the other hand, you might say, okay, if we're building for a client, they might use 2 or 3 languages. So do we build in a way where they can output these components in whichever language they need, whichever framework they need? So there are things that do this, like Stencil, that where you build things in Stencil and then you say, okay, give me an Angular version of these components people can use, and give me a Vue version and a React version that people can use. But also if you're working with the general public, this can be a whole lot of extra work, because there are so many frameworks all around that people might be using that can have an impact on how they can use your components. In that case, what you might want to say is, how do we build a framework agnostic version of these components? How do we make sure that they can be used if someone is using this framework or that framework or no framework at all? And what's the best way for us to do that in a way that, keeps it a very smooth experience for everyone? So here's an example of a particular component that you might build. It's a fairly standard sort of alert message. So I've given here, there's some code of how your user, the developer, might use this component. So they would say, okay, it's a warning type of message, and that is a way of customizing the component. So you're not letting them say, this is what the color should be, this is what the icon should be. You're saying, this is a warning, and then internal to your component, you say every warning alert should have this type of icon, every warning alert should have this color behind it. What you are letting them say is the text, so say, I want it to say review at the bottom, I want it to say this message, and I want the link that says review to go to a certain place. We're also letting them control the dismissal, so that's the behavior. So in this place, the behavior is built into the component, and they just get a choice. Do you want it to go away by itself after a certain amount of time, or do you not? Whereas there'll be other things that are internal to this component that we haven't exposed, so the border, the size of the component, where it might be positioned on a page, because those are things that you probably want to keep consistent, because for the end user's sake, every time they have an alert, they will want it to be in the same place so they know where it is. They don't want it to come up in a different place in every page. So that's something that we might not want to let end users control, because it can end up with a messier experience. So the next big thing with all of this is documentation. You can build all of these components with all of these options, but if you don't document them effectively, then it's not going to be used, it's not going to be convenient for people. So the biggest question in this is, where will your documentation live? If you're building internally to your own company, there might be specific places where people expect to look. Sometimes this is just the README within the GitHub repo or whatever repo you're using, and that might be enough. If you're building to hand over to a client, you might need to build it in a specific way that is a kind of documentation that they understand. If you're building it for the general public, you might want to think about, do we need to build our own website? Do we need to host this somewhere that people can follow along? And what you need to think about then is, what's in the documentation? What do people need to know? They need to know how to install the components, how to build them into their own website or app, how to use an individual component. So what do I need to pass in? What's optional to pass in? What can I do with it? You want to showcase those components if possible. So things like Storybook can give a way for you to give an interactive example of each component, so someone can play around with it And this also lets them confirm that this is going to be the right use case for what they want. So you don't want someone to say, I want a slider to pick a date, because they can slide along to pick the day of the month, but that's going to not be what they expect, and it's not going to be comfortable. So giving someone this showcase to play around with these components can really help them know what to use and when. And then one of the biggest things that comes along with documentation is versioning. So it's unlikely that you will build a component library once at a set time and then be done with it and never have to change anything ever again. It's just not a reality in modern web development. So there will be things that you need to change. There might be bugs that appear, and that's partly something we'll come on to again later, but you need to be able to tell people there's a new version out, or this version is compatible with this, or hey, we've updated this because there was a bug and we fixed it. And if there is a new version, is it breaking changes? Will you have to do a whole lot of work when you upgrade to have things work, or can you upgrade smoothly and everything will just update itself? So part of that falls under then the end user. So we need to think about, for the person that's using these components, they are building for someone else. They're not just building for the sake of building. So we still need to consider how our components affect that end user of the site or app or whatever they're building. So the biggest benefits with a component library to that end user is that you can enforce best practices on the people who use your components. So as we talked about with accessibility, for example, I can enforce that people pass me in the correct behaviors or the correct information that I need to make an accessible component. We can also build in some of those behaviors ourselves, like things like alerts not dismissing after 3 seconds, because we know that that's difficult for users to navigate and to see and understand in that time frame. So you can sort of prevent the people using your components from building inaccessible websites by not giving them those options and not giving them that level of control, and by requiring them to give you a certain amount of information. And also localization is a big part of this, as we discussed earlier. If I have a component library, it means that I don't have to build multiple versions of each component to handle a certain language. What you want to do is, in these components, you want to build in support for things like right to left versus left to right languages, vertical versus horizontal languages. You need to be able to think about those things, because it means that those end users will have a familiar and consistent experience without the people that are using your components having to really hack and mess around with your components, which is what I'm next going to talk about, which is you want to be careful in how you build this in terms of thinking about how your user is reaching the end user. You don't want your user, the person, the developer who's using the thing you've built, to have to hack it. You don't want them to have to say, I wanted this to do X, but it doesn't quite do it, so now I need to tear it apart, or I need to force things into it or force behaviors around it. If that's happening, then you might not have built the component correctly, or it might not be fulfilling the purpose that you think it is fulfilling, or there might not be the component that you want or that people want, and therefore they're having to manipulate another component. So you want to make sure they know what component they're using for a particular thing, what is expected for a particular behavior. You also want to make sure that someone can have multiple components on one page. I might need a whole form, so I have multiple inputs on the same page. I might have 2 or 3 buttons. I might have a menu and a toolbar, and you need to make sure that those things can work side by side, that they don't clash, that they don't create an issue where someone is saying, well, if I hit this button on the toolbar, it triggers this other button on the sidebar because they are tagged the same way or labeled the same way. And this also falls back to the same thing with accessibility. You need to make sure that you're allowing people to individually and uniquely identify every component on the page, or that you're doing that yourself in some way. And one of the biggest difficulties with bringing components like this that are built outside of your app into an app is events and data. So you need to build these components in such a way and document them in such a way that people understand, if I have a button, how will my page know that that button was pressed? Do I tell the button what to do? Or does the button tell me that it was pressed and I decide what happens? And the same with your data. Does the component manipulate the data, or do you manipulate the data and pass it in and out of that component? So one thing that we talked about in terms of some of these things and bugs is contributions. So say if the example we talked about, there's not the component that somebody needs or they want something that's very slightly different but very similar to what you already have, do you want people to be able to feedback? So do you want external contributions? Do you want other people to say, hey, you have this component, but it's not quite what I wanted, so I've built you like a different version, or I have updated your component so it does what I need as well. If this is an internal company, that can be easier to police because it's people that you work side by side with. So there are already those standards there, there are already potentially those methods of communication between teams. It might be a case where they just have feedback and they just say, we need this component, and you go, okay, well, we'll put that ticket in, we'll make a point of making that at a certain time. Or it might be where they say, we need this component and we have 3 developers that aren't busy, so they can make it for us. If it is more public or more used by external people outside of your own company, then it becomes a more difficult question. Because you might say, okay, yes, we will let people come back to us with alterations or with new components, but you don't just want to allow every single piece of work that everyone has done without checking it, because that can lead to someone saying, well, I changed this component because it needs to do this for me, but they might have accidentally broken a different piece of functionality that they didn't need or weren't caring about. Or they might contribute something, but it doesn't follow the standards that your other components have in terms of things like accessibility or best practices, and you don't want to start and muddy up your component library with things that don't follow those standards, that then you have to go back and try and update those, and it just becomes a bigger cycle of work. But to prevent that happening, ideally then you need staffing, you need time for people outside of building components to look at the stuff that's coming in from other people and go through it and say, does this match what we need? Do we accept it and make changes? Do we push back and say, no, we won't accept it until this? And also more documentation, because you need to then explain to people, how do I work with this locally? How do I build components? How do I submit components that I've built? And if you don't want to accept work from other people, then you need to think of another way of having them contact you potentially. So whether that's an issues form or a feedback form of some kind where people can say, I want this but slightly different, and then you can put that on your list of to-dos, things that you will get to, and maybe order those priority, how much people want them. And how do you handle bugs and updates? If someone says, this is a breaking bug and I can't use any of your components, that's probably higher priority than someone saying, well, this would be a little bit easier for me to use if I could do this. So how do you prioritize those things? And when they're done, how do you push them out? How do you tell people, we have fixed this bug and you can come and use it now? So, in conclusion, I'm going to go through the positives, negatives, and my general opinion overall from some experience with working with component libraries. So the biggest positives for me are that it's a really good way to avoid doing repeated work, doing the same work over and over again. If you have 5 apps that need to do the exact same thing, or if you have an app that needs to have the same thing on 5 different pages, you don't want to have to do that work of building that over and over again. And yeah, technically you could just go copy and paste it and put it in your new project, but that's probably not the best way to do it either, because then you're having to do a whole lot of changing things around, and you could just build it once and then allow people to make it work in all those different contexts. It also provides a consistent experience for both your developers and your end users. So your developers will know, if I jump into this project and I want to use these buttons, I've used these buttons and I know how they work, and they work at the same they work the same way no matter which place I put them. And for your end users, then they don't have any horrible surprises where a button worked one way on one page and a different way on a different page, or this image was accessible and this image wasn't, because you've enforced that. It allows you to ensure high quality because you're controlling what these components are, and you don't release a component into the library until it's high enough quality that it meets the standards you've set. And it also allows apps and sites to feel familiar. So again, this covers both your developers and your end users, or their end users. So from a developer perspective, if I'm using a particular component library, then I could jump into any project that uses that component library, and I know how to make the sidebar work. I know how to pass a piece of text into a button. And if I'm an end user, coming back to things like material design that people are very familiar with, whenever they jump onto a website, they know what's supposed to happen. They see 3 lines, they know that means there's a menu. if they see a certain icon beside a piece of text, they might know that that means they can hover or click to find out more. Whereas if you didn't have that component library, that might be different in every place, and it might be a lot harder for your end users to figure out what they were looking at. The downsides of this is you have to be very careful. It can be really easy to over-engineer a component library, to make way too many versions of components that are really similar, to allow people to pass in and out way too much more than you really want them to be able to do with a particular component if you want it to all feel like it's in the same library, and just make it feel really laborious for people to use. If your components are too difficult to use when they have to do too much themselves, or if they're far too restrictive where they can't say, actually, I want this to be very slightly different, they won't use those components. They'll just skip it, and then they'll have parts of their app or parts of their site that don't fit in. And the other difficulty is it can be sometimes quite hard to build components without the context of where they're going to live. So if I'm building a menu, I might not know how many levels deep that menu needs to go because I don't know where it's going. And it can sometimes be harder to design and develop that without that context. So, conclusion within a conclusion, I would say a component library for me is a really good tool. It is really nice from the control side of being able to say, this is how you have to build your website because I'm making you be accessible and I'm making you follow these good practices. But it's also really good from the developer side because it means I don't have to do that work every time, and I don't have to go and figure out what's the best way to do this, what's the common practice way to do this, because someone's figured that out and I just lift their version. It can be a really good experience for the end user because it does have that consistency, and every page in my app or every button on my website will work the way I expect it to because they're all the same button. But you have to be aware that you don't overcomplicate it, you don't make it too hard to use or too frustrating to use, because then people won't use it at all. So thanks, that's been me. Hopefully some of you will try out component libraries, whether that's making one or using some that you find around that someone else has already built. But yeah, I'm free. I'm on Twitter, I'm on Slack. If anyone has questions or wants to chat to me, feel free. And that's it, thank you.
Some brilliant talks there from Claire and Niall, not Andrew and Kieran as previously described. Apologies. Next up, we have a lot more talks the rest of the day, so we're just coming to the last two. Track 2, we will continue on with talks through the afternoon, whereas track 1, we will be handing off to Raspberry Jam after lunchtime. But for the meantime, we have Arno Roger of Rapid 7 on track 2 on the examination of mindset and what science says about it. And then track 1, we have Jordan Colgan live from the studio on the principles of simple, hard, effective, and how these will make our software better. If you've got questions, pop them in the Slido. But over to you, Jordan.
Simple, hard, effective at the Northern Ireland Developer Conference 2020. So before we get started, check this out. To change, you must first change the way you think. So this is going to be a pretty important concept later on. And hopefully we're going to change the way we think about simple, hard, and effective. So let's get started. What if you were told that simple and hard makes effective results? We're talking about doing simple things as it gets hard and it being effective. If that doesn't make sense, don't worry, we're going to prove it using some logic and reasoning. So, if we take the opposite of simple, which is complicated, if you were to think of something complicated and hard, what do you think it would be? Think of a time that you were working on something, maybe you got stuck at a point, so you went off and searched some information. So, you tried a solution, but it didn't work. You tried another solution, didn't work. You tried maybe something slightly different, didn't work. You kept going and going and going and going and going until finally it works. So you go back through your changes to figure out what was it that made it work, and oh dear, you can't figure out what it was that was the change to make it work. So you just leave it as it is. It works for now. Maybe someday you'll fix it. This is a pretty good example of something complicated and hard not being effective. So we say that complicated and hard is the least effective that we can be. With complicated and hard being the least effective, what would be the most effective? The most effective would be the opposite of complicated and hard, which would be simple and easy. This talk is entitled Simple, Easy, Effective. That's because it can't always be easy, and we're going to figure out why that is later on. So if you fill in the gaps in between and staying on easy, we can have complicated and easy. What do you think complicated and easy would be? It's not so effective, and why is that? Because it's still complicated. When something is complicated, it's difficult to track what changed to create the result. And eventually, it's going to turn into complicated and hard, and we will figure out later on why that is. So with complicated and easy being not so effective, what's the next gap that we can fill in? It's effective. And what would effective be? Well, it's opposite of complicated and easy, and it's the next step of simple and easy. And that would be simple and hard. So that's where we get simple and hard being effective from. But we're not just going to stop there. We're going to delve deeper in and figure out why this really is. So if we take the first part, simple, why do we say simple? We want simple because we often have to deal with complicated things. You probably work trying to solve complicated problems every day in your job. So we're trying to do the simple things to tackle those complicated problems. This idea of simple has been around for quite a while. There's this thing called the KISS principle. It's a design principle noted by the US Navy in the 1960s. And it states that most systems work best if they're kept simple rather than made complicated. So a key goal in system design is to avoid unnecessary complexity. And what does KISS stand for? It stands for Keep It Simple, Stupid. Now, before you think that's being mean, think about it this way. KISS isn't to use against others. When we do complex things, we think we're being smart, but we're actually being stupid. Have you ever produced a complex piece of work? Were you proud of it? Complexity used to be a way to measure how senior you were. It was seen as a way to ensure your job security, because only you could understand that. But what if you leave? Well, some people have to figure out what that complexity is. But what if you're still there? What's going to happen if it breaks? They're going to come to you to fix it. So that stupid part is for you, is to protect you against yourself. So we've seen why we want simple. What about that second part, hard? Why do we say hard? Hard work sucks, doesn't it? When you work to be better at something, the longer you do it, the harder it gets to be better. And this is just nature. This is the law of diminishing returns. So when you start something new, the progress is pretty quick at the start, but the more you get into it, the harder and harder it gets to make that progress. You can summarize this pretty well by saying, the longer you train, the harder the gains. And this brings us into our next segment. Because this idea of simple and hard being effective comes from some people who figured this out by lifting weights. But before we continue, we're going to take an interesting turn. But before we get there, there's a bit of some information about that. So using analogies can be good to explain or describe something, but without knowing enough about the original context may create all sorts of understandings. So we're going to try to build some context here, so then we can use some analogies to further explain why simple and hard is effective. The older you are, the harder it is to interact with the world. Maybe for some of the younger people, this isn't so prominent, but maybe for those with some years under the belt, they notice that things are just starting to get harder. Things like carrying their groceries, playing with their children, or walking up the stairs. Some people figure out that the stronger you are, the easier it is to interact with the world. But when we say stronger, we're not talking about this image of balls to the walls effort. We're just talking about simple people who are just getting a tiny bit stronger and improving their quality of life. So maybe your doctor's saying, hey, maybe you should try the gym, build some more muscle to prevent your deterioration later on. So you go to the gym, you don't really know what you're doing, you might hire a personal trainer. They've got you doing this, this, and this, and this. Maybe some complexities involved. And pretty similar to how we talked about being senior was how complex you could understand stuff. So too might they add some complexity to make it seem like they really know what they're doing. Or maybe you go online and search for some information, and people are saying do that, 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 and that. But so too is this pretty similar to our little story of doing lots of things and it being complicated. And we know that we don't want to do complicated because it's going to get hard. We've already proven that complicated and hard is not effective. So some people figured out, with using the law of diminishing returns, that actually at the start, you're going to make progress no matter what you do. So why not, while we're doing those things at the start, we do simple things and get really good at them. So they decided, well, we need some simple tools to use, so they came up with some really simple criteria to build those tools. So they came up with the tools, they're like, well, we need some techniques to use those tools with, so they came up with the techniques, and they decided, well, we need something to drive those tools and techniques with. So it's all relatively kept simple, and no matter who comes to them, they still do those simple things. So the person pictured here is 72 years old, yet here he is in his first session with a barbell on his back. And it really does work. This isn't the same person from before, but this is a gentleman who is older, yet here he is with a greatly significant quality of life improvement and repping some heavy weight. So hopefully you stayed on track there. Hopefully we didn't create more misunderstandings, because the whole point of that was to create a better understanding of why we say simple and hard. These people figure out that it's going to get hard anyway, so you can't change that part. Rather than keep doing these complicated things, we can change the first part of the equation. So would you rather do complicated, or would you rather be simple? And we proved that simple and hard is effective. Maybe you're tuning in right now and you're thinking, well, why are we talking about lifting weights? Is this the right track? Or what's going on? What does this have to do with software, you think? Turns out it's everything to do with software. If we build some analogies of what we just talked about against software, we can think of the body as the software we build, where you don't want a frail body, you want a strong body, and so too should we have stronger software. Those people who go to the coaches, they were paying them and relying on them to build a stronger body, and so too does the business hire us as developers to improve the quality of life of the business with better software. And probably the most significant analogy that we can think of is that those coaches realized most people coming to them are just normal or older people. They don't always get to work with the athletes who can really progress quite well. So they have to be really careful with what they do and make sure that any changes that happen, they can track and be effective. And so too, with the software that we work with, most of the software is probably legacy systems. You don't always get to start on that new project. And even if you do, those who have worked on new projects before know very quickly it turns into the legacy system. So of course, we can take these lessons learnt through building stronger bodies and making better quality of life, and we can apply them to the software that we build. So maybe we won't be invited back if we don't actually talk about some software stuff. So here is some simple things you can do in software development that are hard to get good at but make effective results. And we're going to have 3 things. Oops. And these 3 things, we're just going to say how they're simple, what might be a way they get hard, and how are they effective. So the first one you've probably seen there was test-driven development. How is test-driven development simple? You write a test before your implementation. Before you write any production code, you write your test first. And you might be thinking, well, okay, and you make sure it passes. So even if it's an empty test, you make sure it passes so your framework is working fine. And then you write a failing test. You write enough code to satisfy the requirement you're trying to work on, or part of the requirement you're trying to work on. And then once you have a failing test, then you update your production code with just enough code to pass. And once you get a passing test, you iterate maybe with a new requirement as a new test, or you just update the test you're working on. And you keep going until all your requirements are complete. So how would this get hard? Well, you're probably not going to do it right at the start. You're probably going to want to write more code than you actually have to. And maybe you're not used to actually writing tests at all. Or maybe you're working with bad code, code that hasn't been tested, code that has been decoupled in a way that it can't be tested easily. Or maybe you're going to encounter skeptics who say, we don't need to do test-driven development, we know our code works. But it is incredibly effective. It reduces the complexity and over-engineering. It means that you can only focus on one thing at a time. It gives you confidence. You build a test suite over time that you can be sure works, and therefore it brings value to the business. You're not shipping out code that you have an uncertainty if it even works. You know that it works. So that was number one, test-driven development. Number two is pair programming. So pair programming is just about regularly pairing up with various teammates and just rotating each time. So how would this be hard? You're going to encounter lots of personalities. You're going to encounter people who don't want to work as a team, maybe just like working by themselves. And you might be pressured to deliver on time. Maybe your manager's going to freak out that you're two people are working on one task. But really, in the long run, it saves time. No longer are you in this cycle of putting up a pull request and waiting for people to comment it and get feedback. And you're getting quick, immediate feedback. If somebody doesn't like something you've done, or they can suggest a change, they can suggest it immediately. And improves teamwork. You're really getting to know your teammates, you're getting to know how each other works, and you can suggest in real time how to improve. So that was number two, pair programming. Number three is leave the code cleaner. This is pretty simple because just improving code in areas you're working on. This means just cleaning up things as you go along. But it's hard because you're going to want to do more than you should. So actually the opposite. You're going to want to do more than you should. So there might be, as you go on in time, you might notice more things that you can clean up. Or maybe there's no test to back up your changes. You don't know that that cleanup you've done is going to work. Well, how is it effective? The code doesn't rot. As you clean code over time, it prevents further rotting. And we know from that analogy of the bodies getting frail over time and us trying to prevent that, so too we should apply that to our software. We don't want it to get more frail over time. So that was three simple things, and these are things that you could actually go off and do straight away. So we didn't really cover too much there. That was pretty brief. So if you are interested in learning more about this kind of stuff, there is the Belfast Software Craftsmanship Community. I want to preface and say this talk is not an advertisement for this community. The proposal for this talk was actually submitted before this community even existed. But there's a pretty good community if you're interested in these kind of things that we talked about. And there is a couple of events coming up, and everybody is welcome. Craftsmanship, it doesn't matter who you are, what your age is, your experience, your gender, whatever. And craftsmanship is all about building better professional attitudes, because your attitude matters. It's your attitude that drives you to want to change. But you can't change if you don't first change the way you think. We said at the start this is going to be a pretty important slide, and this is actually the overarching theme of this talk. Has the way you think about simple, hard, and effective changed? This could have been a talk just about simple things to build better software, but actually that was quite insignificant compared to what we talked about. The whole idea was to build up that without doing these simple things, as it gets hard, we can't really be effective. Maybe you're thinking, I don't know, first we were talking about memes, then we were talking about old people lifting weight. Kind of lost. Well, no matter what you got from this, everybody can take away that simple and hard makes the complicated easier. That is the end of the talk. Thank you very much.
that was a fantastic talk from Jordan there. I hope everyone's been enjoying the day so far. There's been a lot of talks out there, and I'm struggling to keep up. There's just too many good talks going on. So we've got plenty more after lunchtime, especially track 2. A lot more talks on track 2. We have specifically Jordan McDonald from Allstate. He'll be giving a talk, and Mark McCavanagh from Signified. He actually has my favourite title so far, Whale, 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 What Do We Have Here? So Jordan's talk is at 1 o'clock on track 2, and Mark's at 1:45 on track 2. And there are plenty more around that as well. And I think, Art, you want to talk about track 1?
Track 1 is actually going to be quite special because it's going to be the very first debut for the very popular NI Raspberry Jam. After the lockdown, they have been inactive for a while. They have had to stay at home just like the rest of us, and they're trying out how can we keep kids engaged, how can we keep up the interests while we can't meet in person. So you'll be seeing quite a bit from them this afternoon. So if your kids club, coding club is in lockdown, join in this afternoon, both on either your current ticket that you're watching on right now, or there is a special young people's tickets on our website as well. You'll hear more about that wrapping up to 1 p.m. But in the meantime, as we're wrapping up for lunch, keep an eye out on Twitter because we're about to start the next game with a prize coming time box between 12 p.m. and 1 p.m. You have to play it then to be entered for the competition.
And then we'll be playing lots of videos from our sponsors from between 12 and 1 as well. So if you're interested in any of the sponsors this year, have a look and check out what they do. And so far, just enjoy lunch, and we'll see you at 1 o'clock.
Hi everyone, we're here at Flexera for the Northern Ireland Developers Conference, and I have two of my Flexera colleagues with me who are going to tell us a little bit about what it's like to work at Flexera. So, Hajani, could you tell us a little bit about what your role is at Flexera?
Yeah, sure. I'm a senior software engineer currently, and I'm working on a cloud management product. In fact, this week we have just released a new capability to allow our customers to add data from public or private cloud.
That's great, Hajani, thank you. And Johnny, same question to you.
Sure, I work on the team responsible for the back services which export and enrich customers' IT asset data.
Thanks, Johnny. And Hajani, as a senior member on your team, what are your thoughts about the direction that your career is taking you?
That's a great question. Flexera offers many opportunities to us, and the first one, I had the opportunity to join a cross-functional team, which is a group of people from different parts of the organization, as sales, marketing, engineering, and architecture. And we work together to shorten the feedback loop and align the expectation across the organization.
And Johnny, what have you found most rewarding about your work on the IT visibility team?
I've really enjoyed learning the technologies and the architectures, so things like Golang and microservice architecture are really interesting from a technical point of view. But from a cultural point of view, I really love that the company is people-focused in terms of both our customers and how we operate internally. It's really good that you can ask questions or raise suggestions to improve, and they're always considered.
What technology are you most interested in learning at the moment, or even bringing into your team?
I'm keen to increase our usage and how we leverage our sort of automation and automatic monitoring solutions. So leveraging technologies such as Travis CI or Prometheus to set up alerts and automatic deployments really helps save time. And the more time we save, the more we can put it back into the product.
That's great, Johnny, thank you. And then lastly, Hajani, Flexera's corporate values are candor, professionalism, keep score, celebrate success, passion, and give back. Which one of these resonates most with you and why?
It's difficult to pick only one. And for me, there are three that I identify with most. That is candor, passion, and give back. Why candor? It's because I believe we need to be honest, raise our hands, and when something's wrong, or even to give a new idea. It's picking up helps our team just to make better decisions. And also it's important to love what you do, because you always give your best, you never stop learning, and you're self-motivated to find the best solutions for the problems that you face. Last but not least, I think helping others is extremely important as well. And for me, it makes me feel like a mission accomplished.
Hajani and Johnny, thank you very much for joining us today at the conference.
With three different sort of product lines. We've got a chatbot team, we've got a transcription service, so changing voice transcriptions of phone calls to text. And then the team that I'm currently working on is the optical character recognition team, which is taking scanned documents and then digitizing that text.
At Allstate, we're always given new problems to solve. That's really satisfying because you have to think of innovative new ways to solve that, and then you go and investigate, you go and research, you speak to other people. By doing that, you'll learn how to use new technologies, you'll meet loads of new people.
A good machine learning engineer would be inquisitive, be willing to do the research, try things out. It's important to try things and know that it might not necessarily go somewhere, and not put all your eggs in one basket. But yeah, research is really important. So.
That was one of the things that really appealed to me about Allstate, is that coming in you get all these career paths presented to you. There's loads of training available, there's mentorship, there's career guidance,
My manager is very keen for me to take on new things so that I can develop in my own team as well. Also, I think Allstate is very good at offering you opportunities outside of your current team as well. So if you want to move around in the organisation, that's a very easy thing to do. So I think internally in your team and externally, there's a lot you can do.
Allstate, I've seen the transferable skills, to bring me on in the first place, and they have again and other colleagues who have picked up the role well and are performing well.
Although there are people who kind of specialise in certain areas, there's always crossover between different roles. They're really forward thinking and they're really progressive here, and that they understand that having a really good work-life balance and having all of these social events and these opportunities for people to just unwind and live a healthier life, and they really invest in that.
I think you come into this role if you've got that interest and ability to learn new skills and willingness to give it a try. There's the support to learn those skills and to be successful at it.
Hello, I'm here with Andrew Goff, the co-founder and managing director of GCD Technologies, a custom software development company based in Northern Ireland. And we're here to find out a bit more about what GCD Technologies do. So Andrew, welcome.
Hi.
Do you like to tell me a little bit more about how GCD started?
Yeah, so GCD started life back in 1999 when we got approached by a local business to create an e-commerce website. It was myself and my co-founder, Andrew Cuthbert. We were students at Queen's at the time. And GCD has grown quite a bit from those humble beginnings of the two of us to a large team of 40.
Wow, that sounds fantastic. So tell me a little bit more about what you do and what you've worked on in the past.
Yeah, so GCD builds custom software solutions on behalf of a whole range of clients. We build mobile apps and web apps, including portals like propertynews.com and NIDevConf. We've also built apps for utility companies to measure real-time energy usage. We've also worked on some interesting startups, including a startup called Taxis app that were Uber before Uber.
That's absolutely fantastic, Andrew. So in your talk, you mentioned about building custom products, the latest being Status.
Yeah.
Love to find out a bit more about it.
Yes, Status started out as an internal tool that we built to really surface users' status within Slack and display them on a board. Mm-hmm. And we had this displayed around our office when we were all back in the office. But whenever we had to move remote back in March, we actually found this tool really useful for helping our team stay connected. It allowed us to share little incidental bits of information that didn't make sense in chat to allow people to find out what was happening in your life. So it might have been that you were out for a run, or indeed you were working with the kids for the day. There was lots of different things going on. And we sort of got to think that if this is useful for us, helping our team feel more connected, then maybe it could be useful for other teams as well.
That sounds like a fantastic tool. Maybe I might have to bring it in.
Absolutely.
Yeah. And what's the future for Status?
So we're actually just really launching it here at the NIDevConf. And really we've been following, and if you listen to my talk, you'll hear me talk about the lean startup methodology. And really we're looking to learn from the product. So very much it is an MVP. We're in a beta phase at the minute, but we'd love people to sign up and try the product. You get full premium features for 30 days, but actually we are extending an offer for NIDevConf users where we'll extend a full free year of premium access.
That sounds absolutely brilliant. And thank you very much for coming in and talking to us.
All right, thank you very much.
At Rapid7,
we are all the keepers of the culture.
And it's all of our responsibility
to embrace and live it
every single day.
Together, we will continue to scale our amazing culture
into the future through our willingness
to understand and internalize it.
Together, we will build a company.
Not just that changes the security landscape,
but allows you to build a remarkable career
alongside some equally remarkable people.
Hello, I'm John Healy and I'm the Managing Director of Allstate Northern Ireland. I am delighted to be a gold sponsor of the Northern Ireland Developer Conference, and it's just fantastic to see what's happened in the developer scene in Northern Ireland and how it has grown over the last number of years. There are just so many opportunities out there and opportunities at Allstate as well, so please do have a look at the day in the life of AI. In terms of the type of work that we're doing at Allstate, and also take the opportunity to sign up to our newsletter. Other than that, I just really hope that you enjoy the conference and get what you need from it as a developer in Northern Ireland. Thank you.
One of the things that attracted me to Signified was the idea of small teams. So 4 to 5 people on a team with a principal developer in each team. Everyone's really approachable, really friendly. And the fact that we're a fresh team in Belfast, everyone's kind of learning together. It's one of the most attractive Java opportunities in Belfast at the minute.
Hi everyone. I'm Phil Wilkinson, Senior Director of Engineering and Belfast Site Leader for Flexera. Flexera are proud to be sponsoring the Northern Ireland Developer Conference once again in 2020, albeit this year it's a little bit different. But we're looking forward to celebrating the local talent that this community has to offer, and as we do every year, we're looking forward to learning some new things from our peers and our friends in this community. We hope you enjoy the conference.
Well, back in the day, there was no Stack Overflow, no Mozilla Developer Network, nothing like that. And most vendors charged a subscription for their documentation and for their developer content. So it was our job to be the provider of the information that developers needed. But these days, developers are drowning in documentation, blog posts, tutorials, all kinds of content. So our job is to kind of be a tour guide, and to educate them to the point where they can navigate the sea of information for themselves.
I'd say from a technical standpoint, for actually doing the job, not really. The proliferation of free tools, tutorials and information have meant that we've got some excellent developers who have been self-taught and learned through engagement in non-academic activities. But saying that, a degree will make it easier to get your foot in the door, and a higher level degree will usually command a higher starting salary. But within a few years, this usually levels off and the degree doesn't really pose much of an advantage. But in the current climate where students are learning remote and paying £9,000 for the degree, there may be a shift in the industry.
In terms of programming trends, we definitely live in interesting times. We see Kotlin and Scala continuing to drive innovation on the JVM, with many new features being added to Java as a result. TypeScript is popularizing new ideas like structural typing and type-driven development. There are new programming languages growing in popularity, like Rust, Elm, and Reason ML. Then thinking beyond languages, serverless continues to rise in popularity, and also NoSQL databases and machine learning and so on, they continue to make steady progress into mainstream IT. So there's an awful lot going on.
Just do it. Just get out there. Talk about something that you're passionate about and excited about. And if you're excited about it and you put that into your content, other people will respond naturally. I would say rehearse, and also don't try to bite off more than you can chew. I've seen some good talks go awry whenever people try to do too elaborate live demos and things like that there. So start off small and work your way up. But yeah, just get out there.
Hi, my name is Lauren Hughes. I work as a software engineer here at Rapid7. I'm a front-end developer, so a lot of the technologies that I would use on a regular basis would be JavaScript, TypeScript, and usually with a React framework. As a woman in tech, I recognise that I am pretty much a minority in this industry, and it's important to me to know that I'm with a company who recognises that that is an issue. Rapid7 has made initiatives to recognise all minority groups within the tech industry, be that because of your gender, because of your race, your age, and they have got behind a lot of STEM projects for kids in kind of secondary schools to do workshops with us to introduce them to the life of coding, hacking, doing like small hackathons with them, and I think it's a really important part of knowing that a company that you're working for is doing its best to shape the future youth of tomorrow and the people that they're going to hire in the next 10 years. And I think it's a really something that I really would have benefited from when I was at school. So that's something I'm definitely behind, and I think yet another reason that it stands out as a company in this industry. I would recommend anyone to work at Rapid7. Honestly, you know, the people that work here are not only incredibly talented at what they do, be that from a technical aspect, managerial, you know, even from leadership and right up, but there is such a sense of community. There's never a wrong question to ask anyone, and there's a real sense of family.
The Belfast office is not just an engineering centre. They have our risk team, data science, so it's kind of that they're growing the whole office as opposed to just that kind of engineering side of things.
So the main technology I'm using at Signifyd is mainly Java-based languages along with Amazon Web Services and the likes of Cassandra for a database.
We are deployed within the cloud, so we are a SaaS-based company. We leverage Kubernetes and AWS. The thing to say really about our tech stack is I can tell you what we have today, what we have tomorrow. I can't tell you, but we are continually evolving that tech stack so that it meets the business and technical requirements of the platform.
It's quite a challenge. You're building things from the ground up. So other companies might offer like, you know, just like fixing old products or kind of adding new features on, whereas we're building things from scratch.
One of the things that attracted me to Signifyd was the idea of small teams. So 4 to 5 people on a team with a principal developer in each team. It means you're not getting lost in, you know, a load of people. It's one of the most attractive Java opportunities in Belfast.
It's an agile environment where there's 2-week sprints. So really anybody can get up and take a task on the board and take it right through from design to implementation all the way through to production.
Everybody chips in, so it's a hands-on approach. So you're involved from the design, you know, DevOps work, testing as well. So there's a real kind of broad spectrum of work you take on.
We roll up our sleeves, we get on with it. Nobody at Signifyd will tell you how to do your job, but we're all there to support each other and make sure that we're all making the right decisions. If anybody needs help, we're not afraid to ask.
Every year Signifyd hold on-site meetups for everybody in the company to kind of gather in San Jose. So in May I got to head out for a week and participate in a hackathon and different activities for it.
You do turn around and help other people, you come together, and it's quite like a family in that way. You know, it's got a lovely environment to it, and it's a lot of hard-working people, which I really value that really highly.
I started with the company as a placement student back in 2003 and had the privilege of learning on the job during that placement year. Not only technical skills, but also the understanding that I wanted to work in embedded and wireless systems for my full-time career. I joined the company again in 2006 as systems design engineer, and then have had the opportunity to move through different positions into leadership roles over the years, and have now reached the position where I'm leading a large team of engineers. I think the history that I have with the company is testament to the investment that we've always put on site here with placement students and developing careers, and it's something that we really focus on for everyone in the team. The company on this site started with Schrader Electronics back in the mid-1990s, and the first product that they really took to market at scale was remote tire pressure monitoring. And as that company grew and was very successful, we were able to reach over 50% of the world market from a small company in Northern Ireland to a world leader. It's a great story. That success attracted Sensata Technologies, and in 2014 we were acquired by Sensata, and we have been integrated into Sensata, and through that integration have now started to work with lots of different end markets. One of those being the heavy truck and trailer industry, which is now an increasing area of work for us. Sensata is focused on developing sensing-rich solutions which provide insight to make our customers' operations in vehicles safer and more efficient. And as a product company, it gives us a very interesting range of technologies to work on, from the material science within mechanical design of components right through to the user interface on a website. And it's a fascinating array of technologies to work on that give opportunity for career development in many different engineering disciplines. The Smart and Connected project within Sensata has developed over the last 2 years from being a vehicle area network of wireless sensing to now being a full stack solution. And by that I mean that we go all the way from something like this, which is a wheel unit which measures tire pressure and temperature, transmitting to an ECU like this, which is processing that data in an algorithm to provide additional information to the end user, and then transmitting that up to the cloud, running algorithms in the cloud, and providing insight on a web portal. That full stack solution is something which is incredibly exciting and interesting to work on. It's something that has been a big journey for Sensata, because a couple of years ago we were not doing that, and it's something which is an area of investment for the company. We're seeing a lot of customer interest in it, and we see it as a real focus area for us in the future. There are a couple of things that really excite me about the project, and some of those are technology focused, and that could be building out the cloud and analytics aspects of the project, which are areas we had not previously had a lot of focus on within Sensata. Another area is more people focused, which is seeing team members develop new skills, both technical skills and also soft skills in working with customers and colleagues in teams right around the world. Those opportunities come whenever there is a great project to work on, and they also come within a global company. And it's something that's really, really great to see, because every week, every day, I see people reacting differently to challenges, and that shows that they're developing, and that's really, really rewarding. Sensata is a truly global company with engineering and manufacturing sites right across the globe. It's something which makes it very interesting to work with colleagues from many different cultures and backgrounds, and helps us understand locally what the needs are of our customers in those areas. I think the other highlight for Sensata is the focus that the company has on research and development, and this was demonstrated a number of years ago when an office of the CTO, or Chief Technology Officer, was set up with the charge of innovating to help Sensata prepare for all the changes that are happening in our markets, like autonomy, electrification, connectivity, And those changes have really helped us to be able to invest in new areas of development. And now we are seeing within the Smart and Connected project, those investments bring product to market. And it's great to see that the company is investing for the future, and it really is a positive not only for the employees within the company, but also for our customers who are seeing new features and products available for them. Sensata continues to invest in the team here in Northern Ireland, both in developing the skill set that we have here on site in embedded and wireless technologies, and also augmenting that with skills in other areas that are needed for the innovation projects within the company. Those are things like embedded Linux, cellular communication, cloud, back-end and front-end technologies, and really building out the portfolio of skills that we need to deliver the products of the future. It's a really exciting time to work in the company here. We have a lot of opportunity, both for personal and company development, and it's something I'm very proud to be part of.
GCD are a custom software development company, and we believe that great design being put into software along with solid engineering can create great experiences for our users.
We're quite a small company, but we take on problems that traditionally much larger companies would take on. Our values at GCD boil down to roughly three things. One is technical excellence, so we build great things here. Second is good humour. We're always happy to share a joke and have a laugh about things. Third thing for me would be that we go the extra mile. It's easy to say that, but for us we really do put that into action.
Hi, I'm Charlene Hughes. I work for Sensata Technologies and I manage the project managers for Smart and Connected division. Smart and Connected runs like a startup business, which means that we are very much in the early stages of developing new technologies. And the technologies we develop are for heavy vehicles and trailers. So we work really closely with a large majority of the OEMs across the world and also with large fleets across the world. My team, work with the engineering department on all the new exciting stuff, right through from a piece of hardware development, right up to software, and now even better, the team are working on a full IoT full stack. They're looking at web portals, phone app developments, and this is all geared towards these customers, these OEMs, these fleets. The good thing about being a project manager for S&C is that you get to see something on paper right through to the end solution. You get to see a piece of hardware, you get to see the full solution going onto a vehicle, and what makes it even more exciting is you get to work closely with those customers who absolutely love the technology. If you want to learn more about Sensata and what we do, and even the project management team, please feel free to reach out at any time. We're always looking for new talent to come and join our team because we're forever expanding and growing.
Hi everyone, we're here at Flexera for the Northern Ireland Developers Conference, and I have two of my Flexera colleagues with me who are going to tell us a little bit about what it's like to work at Flexera. So, Hajani, could you tell us a little bit about what your role is at Flexera?
Yeah, sure. I'm a senior software engineer currently, and I'm working on a cloud management product. In fact, this week we have just released a new capability to allow our customers to add data from public or private cloud.
That's great, Hajani, thank you. And Johnny, same question to you.
Sure, I work on the team responsible for the back services which export and enrich customers' IT asset data.
Thanks, Johnny. And Hajani, as a senior member on your team, what are your thoughts about the direction that your career is taking you?
That's a great question. Flexera offers many opportunities to us, And the first one, I had the opportunity to join a cross-functional team, which is a group of people from different parts of the organization, as sales, marketing, engineering, and architecture. And we work together to shorten the feedback loop and align the expectation across the organization.
And Johnny, what have you found most rewarding about your work on the IT visibility team?
I've really enjoyed learning the technologies and the architecture, so things like Golang and microservices architecture are really interesting from a technical point of view. But from a cultural point of view, I really love that the company is people-focused in terms of both our customers and how we operate internally. It's really good that you can ask questions or raise suggestions to improve, and they're always considered.
What technology are you most interested in learning at the moment, or even bringing into your team?
I'm keen to increase our usage and how we leverage our sort of automation and automatic monitoring solutions. So leveraging technologies such as Travis CI or Prometheus to set up alerts and automatic deployments really helps save time. And the more time we save, the more we can put it back into the product.
That's great, Johnny, thank you. And then lastly, Hajani, Flexera's corporate values are candor, professionalism, keep score, celebrate success, passion, and give back. Which one of these resonates most with you and why?
It's difficult to pick only one. And for me, there are three that I identify with most. That it's candor, passion, and give back. Why candor? It's because I believe we need to be honest, raise our hands, and when something's wrong, or even to give a new idea. It's picking up helps our team just to make better decisions. And also it's important to love what you do, because you always give your best, you never stop learning, and you're self-motivated to find the best solutions for the problems that you face. Last but not least, I think helping others is extremely important as well. And for me, it makes me feel like a mission accomplished.
Hajani and Johnny, thank you very much for joining us today at the conference.
With three different sort of product lines. We've got a chatbot team, we've got a transcription service, so changing voice transcriptions of phone calls to text. And then the team that I'm currently working on is the optical character recognition team, which is taking scanned documents and then digitizing that text.
At Allstate, we're always given new problems to solve. That's really satisfying because you have to think of innovative new ways to solve that, and then you go and investigate, you go and research, you speak to other people. By doing that, you'll learn how to use new technologies, you'll meet loads of new people.
A good machine learning engineer would be inquisitive, be willing to do the research, try things out. It's important to try things and know that it might not necessarily go somewhere, and not put all your eggs in one basket. But yeah, research is really important. So.
That was one of the things that really appealed to me about Allstate, is that coming in you get all these career paths presented to you. There's loads of training available, there's mentorship, there's career guidance.
My manager is very keen for me to take on new things so that I can develop in my own team. As well, I think Allstate is very good at offering you opportunities outside your current team as well. So if you want to move around in the organisation, that's a very easy thing to do. So I think internally in your team, and externally, there's a lot you can do.
Allstate, I've seen the transferable skills, to bring me on in the first place, and they have, again, and other colleagues who have picked up the role well and are performing well.
Although there are people who kind of specialise in certain areas, there's always crossover between different roles. They're really forward thinking and they're really progressive here, and that they understand that having a really good work-life balance and having all of these social events and these opportunities for people to basically unwind and live a healthier life, and they really invest in that.
I think you come into this role if you've got that interest and ability to learn new skills and willingness to give it a try. There's the support to learn those skills and to be successful at it.
Hello, I'm here with Andrew Goff, the co-founder and managing director of GCD Technologies, a custom software development company based in Northern Ireland. And we're here to find out a bit more about what GCD Technologies do. So Andrew, welcome.
Hi.
Would you like to tell me a little bit more about how GCD started?
Yeah, so GCD started life back in 1999 when we got approached by a local business to create an e-commerce website. It was myself and my co-founder Andrew Cuthbert. We were students at Queen's at the time. And GCD has grown quite a bit from those humble beginnings of the two of us to a large team of 40.
Wow, that sounds fantastic. So tell me a little bit more about what you do and what you've worked on in the past.
Yeah, so GCD builds custom software solutions on behalf of a whole range of clients. We build mobile apps and web apps, including portals like propertynews.com and NIJobFinder. We've also built apps for utility companies to measure real-time energy usage. We've also worked on some interesting startups, including a startup called Taxis app that were Uber before Uber.
That's absolutely fantastic, Andrew. So in your talk, you mentioned about building custom products, the latest being Status.
Yeah.
Love to find out a bit more about it.
Yes, Status started out as an internal tool that we built to really surface users' status within Slack and display them on a board. Mm-hmm. And we had this displayed around our office when we were all back in the office. But whenever we had to move remote back in March, we actually found this tool really useful for helping our team stay connected. It allowed us to share little incidental bits of information that didn't make sense in chat to allow people to find out what was happening in your life. So it might have been that you were out for a run, or indeed you were working with the kids for the day. There was lots of different things going on. And we sort of got to think that if this is useful for us, helping our team feel more connected, then maybe it could be useful for other teams as well.
That sounds like a fantastic tool. Maybe I might have to bring it in.
Absolutely.
Yeah. And what's the future for Status?
So we're actually just really launching it here at the NIDevConf. And really we've been following, and if you listen to my talk, you'll hear me talk about the lean startup methodology. And really we're looking to learn from the product. So very much it is an MVP. We're in a beta phase at the minute, but we'd love people to sign up and try the product. You get full premium features for 30 days, but actually we are extending an offer for NIDev conference users where we'll extend a full free year of premium access.
That sounds absolutely brilliant. And thank you very much for coming in and talking to us.
All right, thank you very much.
At Rapid 7,
we are all the keepers of the culture.
And it's all of our responsibility
to embrace and live it
every single day.
Together,
we will continue to scale our amazing culture
into the future through our willingness
to understand and internalize it.
Together, we will build a company.
Not just that changes the security landscape,
but allows you to build a remarkable career
alongside some equally remarkable people.
Hello, I'm John Healy and I'm the Managing Director of Allstate Northern Ireland. I am delighted to be a gold sponsor of the Northern Ireland Developer Conference and it's just fantastic to see what's happened in the developer scene in Northern Ireland and how it has grown over the last number of years. There are just so many opportunities out there and opportunities at Allstate as well. So please do have a look at the day in the life of AI. In terms of the type of work that we're doing at Allstate, and also take the opportunity to sign up to our newsletter. Other than that, I just really hope that you enjoy the conference and get what you need from it as a developer in Northern Ireland. Thank you.
One of the things that attracted me to Signified was the idea of small teams. So 4 to 5 people on a team with a principal developer in each team. Everyone's really approachable, really friendly. And the fact that we're a fresh team in Belfast, everyone's kind of learning together. It's one of the most attractive Java opportunities in Belfast at the minute.
Hi everyone, I'm Phil Wilkinson, Senior Director of Engineering and Belfast Site Leader for Flexera. Flexera are proud to be sponsoring the Northern Ireland Developer Conference once again in 2020, albeit this year it's a little bit different. But we're looking forward to celebrating the local talent that this community has to offer, and as we do every year, we're looking forward to learning some new things from our peers and our friends in this community. We hope you enjoy the conference.
Well, back in the day, there was no Stack Overflow, no Mozilla Developer Network, nothing like that. And most vendors charged a subscription for their documentation and for their developer content. So it was our job to be the provider of the information that developers needed. But these days, developers are drowning in documentation, blog posts, tutorials, all kinds of content. So our job is to kind of be a tour guide, and to educate them to the point where they can navigate the sea of information for themselves.
I'd say from a technical standpoint, for actually doing the job, not really. The proliferation of free tools, tutorials and information have meant that we've got some excellent developers who have been self-taught and learned through engagement in non-academic activities. But saying that, a degree will make it easier to get your foot in the door, and a higher level degree will usually command a higher starting salary. But within a few years, this usually levels off and the degree doesn't really pose much of an advantage. But in the current climate where students are learning remote and paying £9,000 for the degree, there may be a shift in the industry.
In terms of programming trends, we definitely live in interesting times. We see Kotlin and Scala continuing to drive innovation on the JVM, with many new features being added to Java as a result. TypeScript is popularizing new ideas like structural typing and type-driven development. There are new programming languages growing in popularity, like Rust, Elm, and Reason ML. Then thinking beyond languages, serverless continues to rise in popularity, and also NoSQL databases and machine learning and so on, they continue to make steady progress into mainstream IT. So there's an awful lot going on.
Just do it. Just get out there. Talk about something that you're passionate about and excited about. And if you're excited about it and you put that into your content, other people will respond naturally. I would say rehearse, and also don't try to bite off more than you can chew. I've seen some good talks go awry whenever people try to do too elaborate live demos and things like that there. So start off small and work your way up. But yeah, just get out there.
Hi, my name is Lauren Hughes. I work as a software engineer here at Rapid7. I'm a front-end developer, so a lot of the technologies that I would use on a regular basis would be JavaScript, TypeScript, and usually with a React framework. As a woman in tech, I recognise that I am pretty much a minority in this industry. And it's important to me to know that I'm with a company who recognises that that is an issue. Rapid7 has made initiatives to recognise all minority groups within the tech industry, be that because of your gender, because of your race, your age, and they have got behind a lot of STEM projects for kids in kind of secondary schools to do workshops with us to introduce them to the life of coding, hacking, doing like small hackathons with them, and I think it's a really important part of knowing that a company that you're working for is doing its best to shape the future youth of tomorrow and the people that they're going to hire in the next 10 years. And I think it's really something that I really would have benefited from when I was at school. So that's something I'm definitely behind, and I think yet another reason that it stands out as a company in this industry. I would recommend anyone to work at Rapid7. Honestly, you know, the people that work here are not only incredibly talented at what they do, be that from a technical aspect, managerial, you know, even from leadership and right up, but there is such a sense of community. There's never a wrong question to ask anyone, and there's a real sense of family.
The Belfast office is not just an engineering centre. They have our risk team, data science, so it's kind of that they're growing the whole office as opposed to just that kind of engineering side of things.
So the main technology I'm using at Signifyd is mainly Java-based languages along with Amazon Web Services and the likes of Cassandra for a database.
We are deployed within the cloud, so we are a SaaS-based company. We leverage Kubernetes and AWS. The thing to say really about our tech stack is I can tell you what we have today, what we have tomorrow. I can't tell you, but we are continually evolving that tech stack so that it meets the business and technical requirements of the platform.
It's quite a challenge. You're building things from the ground up. So other companies might offer like, you know, just like fixing old products or kind of adding new features on, whereas we're building things from scratch.
One of the things that attracted me to Signifyd was the idea of small teams. So 4 to 5 people on a team with a principal developer in each team means you're not getting lost in, you know, a load of people. It's one of the most attractive Java opportunities in Belfast.
It's an agile environment where there's 2-week sprints. So really anybody can get up and take a task on the board and take it right through from design to implementation all the way through to production.
Everybody chips in, so there's a hands-on approach. So you're involved from the design, you know, DevOps work, testing as well. So there's a real kind of broad spectrum of work you take on.
We roll up our sleeves, we get on with it. Nobody at Signifyd will tell you how to do your job, but we're all there to support each other and make sure that we're all making the right decisions. If anybody needs help, we're not afraid to ask.
Every year Signifyd hold on-site meetups for everybody in the company to kind of gather in San Jose. So in May I got to head out for a week and participate in a hackathon and different activities for it.
You do turn around and help other people, you come together, and it's quite like a family in that way. You know, it's got a lovely environment to it, and it's a lot of hard-working people, which I really value that really highly.
I started with the company as a placement student back in 2003 and had the privilege of learning on the job during that placement year. Not only technical skills, but also the understanding that I wanted to work in embedded and wireless systems for my full-time career. I joined the company again in 2006 as a systems design engineer, and then have had the opportunity to move through different positions into leadership roles over the years, and have now reached the position where I'm leading a large team of engineers. I think the history that I have with the company is testament to the investment that we've always put on site here with placement students and developing careers, and it's something that we really focus on for everyone in the team. The company on this site started with Schrader Electronics back in the mid-1990s, and the first product that they really took to market at scale was remote tire pressure monitoring. And as that company grew and was very successful, we were able to reach over 50% of the world market, from a small company in Northern Ireland to a world leader. It's a great story. That success attracted Sensata Technologies, and in 2014 we were acquired by Sensata, and we have been integrated into Sensata, and through that integration have now started to work with lots of different end markets. One of those being the heavy truck and trailer industry, which is now an increasing area of work for us. Sensata is focused on developing sensing-rich solutions which provide insight to make our customers' operations in vehicles safer and more efficient. And as a product company, it gives us a very interesting range of technologies to work on, from the material science within mechanical design of components right through to the user interface on a website. And it's a fascinating array of technologies to work on that give opportunity for career development in many different engineering disciplines. The Smart and Connected project within Sensata has developed over the last 2 years from being a vehicle area network of wireless sensing to now being a full stack solution. And by that I mean that we go all the way from something like this, which is a wheel unit which measures
Welcome back, everyone. And for those who have just joined us, welcome to NIDC 2020, and especially to the kids who are joining us for the Raspberry Jam track. Just very quickly, just wanted to let you know that on track 2, we have Jordan McDonald currently giving his talk on why your AI teams should resist the lure of skill specialism. And at 13:45, we have Signified's talk of, well, what do we have here? From Mark McCavanagh. There are a couple of changes to the schedule on track 2, so just keep an eye on the Hopin chat for that. And as well as that, we've got a little special interview with David, the man who's been running the production behind the scenes all week. That'll be from 4:30 whenever Raspberry Jam hand over back to NIDC. And just a little bit more about NIDC or Raspberry Jam, Art?
So many of you have been to the Raspberry Jam for years and know it's an amazing event to go to in person, both when it happened in Farset Labs and now that it was happening in Queen's. But they haven't been around for a little bit. They've been looking for a way.
Technical difficulties hidden.
Can anybody hear me? Good. Is there a microphone I can take? How's that sound? Is that much better? Yeah? All good to go? Is this on? Is this good? Hello?
Knew this morning was going a bit too smoothly, folks.
How about this? You know, May, how about you do this?
How about I do this? Okay. Art's the expert in our Raspberry Jam section, but basically we'll have a fantastic afternoon of talks, workshops, and videos for kids. And you can watch along both if you have a general admission ticket and if you have a Raspberry Jam ticket as well. It's available on both streams. And you know, I'm excited. I'm looking forward to seeing this because there have been kits that have been sent out as well for kids to get involved. But I'm going to have Kaylin take over now. So it's officially going to be the Raspberry Jam at NIDC track. Take it away, Kaylin.
Hello everyone, good afternoon and welcome to the first ever virtual Northern Ireland Raspberry Jam here at NIDC. Many of you will already be familiar with the Jam, but for those of you who, for this, is your first time at one of our events, welcome to you. Obviously we did really be at the Queen's Maths and Physics Centre right now, but as many of you know, we had to cancel all of our events from February onwards due to the coronavirus pandemic. So we're really thankful to the team here at NIDC for giving us this opportunity to do what we love, really. Inspiring and educating young people about STEM and the opportunities available here. So throughout the day we've got an incredible lineup for you with talks from leading industry experts across tech and games here in Northern Ireland. And we've got two great workshops lined up, including a circuit playground workshop from Lucy Bell, which many of you will receive free kit for thanks to our generous sponsors. If you're watching along here at home on Hopin, please remember to get involved by chatting and asking questions. We'll have plenty of opportunities later on to ask questions directly to our speakers, so be sure to be involved in that. Our first speaker today is Gina Chaco, an engineer and STEM ambassador who grew up in a village and learned programming without compiling, and is now surviving well with a bunch of good engineers at Global Payments. She's going to start off the afternoon talking about why you should try programming and why you may just fall in love. Take it away.
Hi everyone, I'm Gina. I'm working as a senior software engineer for Global Payments in Belfast. I'm here for presenting you Try Programming, you may fall in love with it. I'm also a STEM ambassador for the last 10 years. I'm taking this opportunity to appreciate Raspberry Jam team to deliver this virtually. And I usually, when I used to do the face-to-face presentation, I really miss all those enthusiastic smiles and all the beautiful faces when we deliver usually face-to-face. I am here to explain you like how I started programming, how I started enjoying programming. 20 years back in India, in a small village, a 15-year-old girl was confused about what kind of profession, what kind of career she needed to select for her future. So she was confused, thinking whether she needs to go in the medical stream, whether she needs to go into the engineering stream. But her mom was inspiring her to select medical, because if in India it is like majority of parents know about only two professions. Either your son or daughter needs to be a doctor or an engineer. Many other careers are like, they don't think that there is any other careers exist. So in A levels, you have to select either the science subjects or the math subjects. And then if you're selecting math subjects, you will end up in engineering, or if you're not passing out, then you will end up into some other careers. And if you are selecting your science topics, you will be ending up in medicine. So my mom asked me to select science subjects, so I selected science. And even though I was so much fearful of handling blood and everything, I thought, okay, let me try and see how it goes. So while I was filling the application form for the school, I found that we can also add additional maths as a subject. But the problem is, no one will be teaching you maths in school, but you have to study by yourself. The only subject which you have selected will be taught by the teachers. So I took the risk of taking additional maths along with me, thinking, okay, I will go ahead, trying medicine, trying medical, trying science subjects, and also at the same time, I will keep my passion along with me. But the risk is, if you fail in maths, then you can't go to university. So I still remember my first day in the biology lab. There, the first task was to dissect a cockroach. So it was really hard, and I was almost at the stage of fainting. And then later it was about dissecting a frog. So it was so scary. But I managed to finish my science A-levels like in 2 years, and the results came up. I got 80% for my biology, and I got 94% for my maths. So that helped me to showcase to my mom, see, I don't think medicine is the right subject for me, but I think I need to try engineering. But my mom was really worried, like whether you will be successful in that. But then I tried to convince her, and I selected engineering as my discipline. And then I gone for my graduation, I selected electronics and communication engineering, and we built circuits. I enjoyed all the engineering subject and everything. And in electronics and communication, there was only a little bit about programming. So I didn't get any opportunity to learn programming much while I was graduating in electronics and communication. Then for my first job interview, it was with a software company. It was one of the famous company in India, which is Wipro. They select graduates from different streams, and they then train them for whatever projects they need. So the first, I got selected in Wipro, and they gave me the option for system engineering, network engineering, and programming. So I thought, why don't I try programming, even though it's a little bit risky, because after 3 months, they will be doing an exam. So if you don't pass in that exam, then you will not be absorbed into the company. So I thought, even though it is something new for me, I thought, let me try programming and see how it goes. So that is my first step towards programming. That's where I started thinking or selecting programming as an option. It started becoming more interesting for me whenever I got into the project. The project was like, it is always like customer-facing problems. Problems will be coming, we have to fix various bugs. And realizing that, oh, this is the line of the code, or this is the function we have to fix to resolve this problem is the most interesting bit I found. So I was really enjoying it, and it was also motivating. So that was my first step towards programming. Always when I talk to people, like what you are doing, what is your profession? I always say, okay, I'm a software engineer. Then people will be like so much surprised. Like, how can maybe you're a clever person to go into programming? There are lots of myths around programmers. I picked certainly 5 myths which is around programmers. One is only mathematical genius can write code. Even though I like maths, it's a huge help, but I always say I don't think that you need to be a mathematician to do programming. Understanding maths and having that basic skill is really good. If you're not writing any much algorithm or complex problems, I don't think you'll be using that much maths in programming. So anybody, even though your knowledge in maths is basic, I think still you can try programming. The second thing is only adults can learn programming. I don't believe so, because as per studies, people say that from 5 year to 20 year is the best age you can study anything. So if you can read English and if you can follow the instructions, you can start learning programming at the age of from 7, I think, at the age of 7. So I think it's not only for adults, it's for everybody. Everybody can try programming. And the third thing which I come across is it's necessary to memorize all the syntax to become a good programmer. I don't think these days anybody will memorize anything. So we ask Google or we ask Alexa, but you need to have a little bit of knowledge. I mean, you need to have knowledge about the language, but if you forget about a syntax or something, still you can look around and you can figure out what it is. And the fourth one is the most annoying one. It's a woman cannot code. If you see the picture in my presentation, it's Ada Lovelace, and she is the first computer programmer. And she is not the first women computer programmer, she's the first computer programmer. So I think everybody can code, everybody can learn programming. It's not like women can't code. I think if I count the number of female engineers in my company, I can count them with my fingers. But I think the reason maybe girls might not have tried. If they have tried programming, I think we can increase the number of female engineers. And fifth one, which is learn a single programming language and be an expert, and that is sufficient. I don't believe so, because if you learn a programming language, it depends upon the problem in front of you, what kind of project in front of you. You will be learning more languages and you will be solving that problem with that language. So even if you're expert in one language, you still may need to learn other languages to solve the problem in front of you. So learning one single language is not sufficient, but that will give you a base, and from that you can learn other languages. So what's actually the programming language means? People communicate each other using German, Chinese, English, and everything. To talk to computer, we need to talk to computer using binary. So it's almost impossible for a human to talk to computer using binary language. That's where programming language comes into picture. So programming language acts as a mediator in between human and computer, so that whatever instruction human wants to give to the computer will be translated through programming languages. According to Wikipedia, there are 700 programming languages out there. But I don't think any expert programmer will be learning all those 700 programming languages. So it is like maybe 1 or 2, maybe 5, maybe 10, maybe during your lifetime you will be learning. So you don't need to know every computer languages to be a programmer, And why I'm asking you to try programming is there is a software skill shortage currently in the industry. So as of 2018, 95% of 16 to 24-year-old have a smartphone. That means not only 16 to 24-year-old, I think most of us, we start the moment we wake up from bed to the moment we go back to bed, we use different kinds of softwares and programs. So all these softwares are running by the programs written by programmers. So it is an essential skill. I think learning how to code is a valuable skill, and I think anybody can do it. And in fact, it is 0.3% of the world population know how to code also. So I think it is really an important skill to learn. So what are the steps to try for programming? So first, I will say, before you jump into go and sign up for some costly programs or learning modules or something, find as much free resources as possible and try a couple of languages and find the problem which you want to solve. For example, maybe it is a board game, you want to convert that into a software program, or maybe it is something like a shopping list which you are creating, and then that needs to be converted into an app or something like that. So first identify what is the problem you want to solve. So learning coding is actually helping you to solve the problems in front of you. Coding and programming is a tool to help you. And solve with your favorite language, and then try new problems. And once you are good with your language, try to pair up with your friends and teach what you have learned and learn from them. I just placed 2 links over here, the Free Code Camp and Khan Academy. Lots of useful resources are there that you can go and figure out, and you can learn programming languages. And if you're in the age of 7 to 10-year-old, I think maybe Scratch is the best thing to start with, and maybe Kids Python is there. There are lots of other languages are there. I'm not pointing to one single language, but try and figure out what will be the best one which is suitable for you. So finally, all I want to say is a magical world of software is awaiting for you. The key to that magical world is programming, and programming will help you to unlock and get into that magical world. And I take this opportunity to wish you a good luck to all the young minds listening to me, and try programming and get into that magical world. Thank you.
So, now we're going to pass it on to Andrew Bolster. Andrew is a data scientist, a hackerspace director, an art studio trustee who previously programmed smart submarines, designed lie detector underpants, and created quizzes that know when you were sweating. He now teaches machines how to break machines, and is talking robo-psychology and other careers that don't exist. Pass on to him.
Hi everyone. So today I'm going to be talking to you about robo-psychology and other careers that don't exist yet. In Isaac Asimov's stories, the technical, social and personal impacts of advanced robotics and artificial intelligence are explored. One creation in his books was the career of robot psychologist, a combination of mathematician, programmer and shrink that diagnose and treat misbehaving AI. In this talk, we're going to discuss how on earth you can prepare for a career in robo-psychology and other careers that just simply don't exist yet. Isaac Asimov is primarily known for being one of the most prolific and impactful science fiction writers ever. And as you would expect, while wandering around these fictional worlds, he came up with a few sciencey sounding mumbo-jumbo terms such as positronic and psychohistory, and he's literally the father of the word robotics. He first used the term in his 1941 story Liar about a robot called Herbie that develops telepathic abilities and can read people's thoughts. However, because the robot's core operating principles, or programming, still included the first law of robotics, that is, not to hurt people, Herbie starts lying to people to make them feel happy. This leads to Herbie leading a robo-psychologist called Susan Calvin to believe that a co-worker fancies her. And when she finds out that this isn't true, and Herbie just told her this because Herbie knew that the idea would make her feel better, she was very hurt. This first law is part of Asimov's 3 laws of robotics, which were officially codified the following year in 1942 as a robot may not injure a human being or through inaction allow a human being to come to harm. A robot must comply or must obey the orders given it by human beings except where such orders would conflict with the first law. A robot must protect its own existence as long as such protections do not conflict with the first or second law. These simple laws that were programmed into all robots collided with the very human tendencies of wanting to be loved and cared for, and created this imaginary field of research called robo-psychology. This is a field of research that today doesn't really exist, but I first read about it in 2014 whenever I was on a packed commuter train in California, having just left Google's Mountain View complex where I'd met a university friend who was a programmer there. I'd spent the previous 5 years in a master's program at Queen's University Belfast studying electronics and software engineering, a course that's now called Software and Electronic Systems Engineering, and I would highly recommend it, so if you're interested, ask me afterwards. It focused on the overlap between 2 fields that in my eyes were obviously part of one bigger field. The electrical engineering side, how do you put lightning into glass to make it add numbers together? And then the computer science side, how do you take that act of adding numbers together and trick it into imagining that it's thinking? The physical world of computation and the virtual world of programming. And the magic in between fascinated me. I wasn't a particularly stellar student. I asked lots of awkward questions and never did particularly well in exams. But I just kind of resigned myself to going down the standard engineering pathway. Get a degree, join big company, write banking software for 30 years, retire. But my discovery of this weird term, robo-psychology, kind of kicked me in the behind. After that, I gave up on the prospective banking analyst job and took up a postgraduate research exploring how smart submarines could collaborate and interact with each other for environmental and predominantly military applications, including how do you hide a nuclear submarine using sound, and how do you use atomic clocks to build underwater GPS systems, as well as doing all of this under the assumption that somebody can take control of one or more of your submarines and make it lie or behave badly. The research eventually became too classified for me to continue work on, but I know that I contributed to international agreements on how autonomous systems are allowed to integrate into military chains of command. I'll never know whether this actually matters, but we'll find out. But anyway, this interplay between how fixed, rule-based programmed systems like computers and robots and the fuzzy, fluffy, mushy stuff that comes from people and communities has more or less driven my career since then. I spent 2 years developing smartwatch applications that could tell how stressed you were, culminating in developing particularly shameful lie-detecting underwear, as well as a survey system for a deodorant manufacturer that only asked you questions about the product when it knew that you were sweating. We also developed a universal emotional translator based on some research where we literally threw people down mountains on motorbikes and worked out how stressed they were. After that, I leapt back into my old alma mater of cybersecurity, developing smart algorithms that watched the world's internet traffic, sniffing out hackers, trying to predict their next moves and detect the faintest wisps of exploration and exploitation, fully aware that the hackers were doing exactly the same thing on the other side, automating intelligence gathering and teaching that lightning how to think, and how to think for them. In my current role, I lead a team of data scientists, a term that didn't really exist when I was on that train in California only 6 years ago. We develop and monitor intelligence systems that watch company websites for security vulnerabilities. My day job is to work out better ways to try and pretend to be a hacker and work out how to automate the boring bits of the professional white hat hackers that I work with. When I was your age, these jobs just didn't exist. The internet as we know it today didn't exist. We didn't know what we didn't know. So when my careers teacher told me in around 2004 that I should look at being an insurance adjuster because I was good with numbers, she didn't know that the job would effectively be automated out of existence. So I ended up being a data scientist, not because it's what my careers teacher or parents or friends told me. And it's not because it's on some skills or employability map or because the output of some assessment tests. The job role didn't exist. And I guarantee you that most of you watching now will end up working in and creating jobs that simply don't exist today. This could be bit farming or crypto influencer or quantum annealer or indeed robo-psychiatrist. So as you go through your studies, don't allow yourself to fixate or judge yourself against what jobs are out there now. Your parents and your teachers and your friends genuinely want what's best for you, so they will suggest and encourage you to follow certain paths, generally because it's advice they wish they could give themselves 20 years ago based on their own experiences since then. But the thing is that the past 20 years was theirs. The next 20 years is yours. There are no robo-psychiatrist jobs out there, yet. Build your own paths and experiences. Read widely, care deeply, and don't be afraid of being directionless or meandering. Because if you make your own luck, you might just end up in the right place at the right time with the right skills to realize that you're being lied to by a telepathic robot. Thank you for your time, and I'm happy to take any questions either online or just randomly. Also, I'll be hiring for the next few years, so if you think my line of work sounds fun, give me a shout.
So, that was Andrew Bolster talking about robo-psychology and other careers that don't exist yet. Next, I'm going to hand it over to Lauren Taylor, a now graduated computer science student from Queen's University Belfast. She's the founder of Corgi Undergraduate Women in Tech Group and is interested in AR, AWS, and technology communities around Belfast. Here she is explaining the power of augmented reality and what you can build in just 15 minutes. I'll hand it over to her.
Hello everyone, welcome to NIDC 2020 Virtual Edition. I hope you're doing well, I hope your Wi-Fi connections are strong, and shout out to anyone watching this in your pyjamas. I know you're out there. You're doing great, sweetie. Today I'm going to be getting you through the wondrous world of AR development, showing you how you can create your very first app in just 1 week. First things first, a little about me. Hi, I'm Lauren. I just graduated computer science from Queen's University Belfast. I founded Corgi Undergraduate Women in Tech Community last summer, and I'm generally heavily involved with technology societies such as Queen's Computing Society and a load of other fun stuff that you probably don't care about. At this point in time, I've worked 1 year in Industry of Chaos working on hardcore government websites, and I recently completed an internship with Yellow Design as an immersive engineer. How this came about was due to my final year project, which researched the capabilities of AR on VR headsets. Prior to this, I had absolutely no idea how to create my own AR app, let alone even navigate Unity itself. And here's what we're going to cover. I'll begin by giving you all a brief intro to AR to remind you what it is, how it works, and how it's useful. And then we're going to get stuck into some demos. I'll start by showing you an app I made in just 15 minutes. Very basic, but pretty cool how quickly you can get stuff up and running. Then I'm going to demo an app I made after a full week of development, show you what features I managed to build in that time, and how you can use AR technology to solve real-world problems. Lastly, we're going to finish off with an epic gamer montage, giving the people what they want. So stay tuned to the end for that. Right! We've got plenty to cover today, so let's get started. AR, what is it? How does it work? Why is it useful? AR, or augmented reality, is the rendering of digital images or data onto real-world objects. It essentially merges both the real and digital world together. It can be experienced across multiple sensory modalities, including visual, auditory, haptic, somatosensory, and olfactory. In other words, AR can encompass what you see, hear, feel, and smell. But why? What's the point? How does this provide any value? AR can be applied to many industries, including medical training, retail, maintenance, design and modelling, tourism, education, and field service. To put that into perspective, in business logistics, DHL has already implemented AR smart glasses in some of its warehouses, where the lenses are used to tell the workers the shortest route to pick up items that need shipped. In entertainment, brands are seeing AR as a marketing opportunity to build deeper bonds between their characters and their audience by providing an engaging and rich user interface. If anyone remembers that summer in 2016 when Pokemon Go was released and the internet went wild, that app was created by Niantic Labs, and they had so much success that they ended up releasing a Harry Potter and Witcher themed app shortly afterwards. TLDR, AR is mostly used to either solve real-world problems that require technology information in real time, or to promote customer engagement. Right, now that I'm done explaining what AR is, let's get stuck into the demos. First up, I'm going to show you an app I made in just 15 minutes. I started off by creating a surface scanner. All you do is wave your phone around a room and it'll automatically start detecting planes around you. You can choose to have it either detect floors, walls, or both. I chose both for funsies. And here we are, entering the real world. Hi, that's me. 10 out of 10 lockdown apparel, if I do say so myself. You should almost instantly see the surfaces begin to map out. Just wave your phone around and it'll start detecting. Pretty neat for only 5 minutes of setup. Here's me trying out on my staircase now, as demonstrated by my dog Cotton. If you give it enough time, it'll actually start to pick up individual stairs and the side paneling, which is pretty neat. Next, I went to create an object that I could digitally place into the room. I started off with a super simple orange cube just to test the waters. Here's me rescanning a room. All you need to do is then tap your screen anywhere on a plane that's been detected and your cube should appear. You can also drag it around, walk around it, and it'll stay in the same spot. Okay, this looks fine, but we can do better. So I decided to download this furniture package from the Unity Asset Store and import it in, mostly because I spotted a Monstera planter and I am a massive sucker for a good houseplant. And here's a demo of my new houseplant in action. AR Foundation seems to do a really good job in daylight with non-reflective surfaces, especially floors with lots of landmark objects lying around. I've noticed it struggles to pick up on large areas such as big plain walls or empty floors. It definitely seems to work better during the day or in rooms with good lighting. However, it is super quick to correct itself, so I can't really fault it for that. Next up, I'm going to show you what I curated after a full week of development. This app here is based off the Lunch Break app, but with added functionality. You can now take a photo of any object, crop it to size, and it will remove the background and turn it into a 2D AR object. This means you can visualize practically anything on the internet in your house first before making a terrible purchase. Additionally, you can move items that already exist in your house to try out a new look. For example, I relocated this piece of artwork on the wall to a different room, and I think it looks better here if I do say so myself. This 1 week app also lets you select a photo from your gallery to place as a 2D AR object. This works best with PNG images with transparent backgrounds and makes for some very fun content if you get creative. There you go, that concludes my demonstration of what you can create in AR in just 15 minutes versus a full week. Between the two, there's certainly a difference in user experience, but overall, the quality of the plane detection and tracking is exactly the same. Thank you so much for listening. You can find me on Twitter if you wish, @LornieDawn. And lastly, I think it's about time we give the people what they want. Cue the montage.
Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed. She was looking kind of dumb with her finger and her thumb in the shape of an L on her forehead. Well, the years start coming and they don't stop coming. Fed to the rules and I hit the ground running. Didn't make sense not to live for fun. Your brain gets smart but your head gets dumb. So much to do, so much to see. So what's wrong with taking the back streets? You'll never know if you don't go. You'll never shine if you don't glow. Hey now, you're an all-star. Get your game on, go play. Hey now, you're a rock star. Get the show on, get paid. All that glitters is gold. Only shooting stars break the mold. It's a cool place, and they say it gets colder. You're bundled up now, wait till you get older. But the media men beg to differ, judging by the hole in the satellite picture. The ice we skate is getting pretty thin. The water's getting warm, so you might as well swim. My world's on fire, how about yours? That's the way I like it, and I'll never get bored. Hey now, you're an all-star. Get your game on, go play. Hey now, you're a rock star. Get the show on, get paid. All that glitters is gold. Only shooting stars break the mold. Hey now, you're an all-star. Get your game on, go play. Hey now, you're a rock star. Get the show on, get paid. And all that glitters is gold. Only shooting stars. Somebody once asked, could I spare some change for gas? I need to get myself away from this place. I said, yep.
So that was one trailer with her talk. Now we're going to have a little bit of fun and play a couple of games of Kahoot. Hopefully you can all join at home and we'll present all the information for how to join on the webpage. Everything should be on the screen now and we're going to go through the questions, but we're going to give you a couple of minutes just to get in. if you could go to kahoot.it, and then the code is currently on the screen. Six six 2491. So, just a reminder that kahoot.it So for those who don't know, Kahoot is basically a multiple choice quiz game where we will present you a question on the screen and you'll have 4 options to pick from. One will each will have different colors, different shapes, and they will match the colors and shapes on screen. And essentially, whichever answer you think is correct, you select that box on your device and it will replicate and tell us on our end. And then whoever is correct, it will say and then tell you if you've been correct or incorrect. So, fortunately, just we issue on our end, we've had to restart the Kahoot, so if you could go back to kahoot.it and everything should be on your screen again, or a new game pin. Kahoot.it. The pin code is 6278891. So we'll just give you a couple of minutes just to go in. And just a reminder, there is a prize, which so we can see you're slowly coming into the group. It's good to see a lot of people coming on. We'll give it a couple of minutes just to make sure, just to make sure people get in time. Got a bit of a time limit, so just whenever you can. That's it. Plenty of ones coming in. Perfect. If you're playing on from home or from a screen, it's good to hear. And hope that you enjoy the questions. 3, 2, 1. And that's us started. So our first question. Oh, still more coming in, sorry. Okay, so first question. The ghosts in Pac-Man are named Inky, Blinky, Pinky, and what? So if you pick one of the buttons, red, blue, yellow, or green, and the one that matches on the screen, it should give you an answer that you can select. Whichever one sounds correct. So the answer was Clyde. Next question. So, which of the following games came first? So the answers you can pick are Mario, Tetris, Pac-Man, or Donkey Kong. So, question 3. In which year, or in what year, did Nintendo release its first game console in North America? Was it 1979, 1982, 1895, or 1989? So the answer for that was 1985. Edward seems to be at the top of the leaderboard. Good job, Edward. So, question 4. The classic arcade game Pong was manufactured by which company? Was it Atari, Sega, Nintendo, or Commodore? And now the leaderboard. Edward, no, what's happened? Question number 5. Well, what is the average amount of time a player of the game Fortnite spends enjoying the game weekly? Is it 1 to 3 hours, 3 to 6, 6 to 10, or 10 to 15 hours? Crazy Frog has jumped up quite a bit, so has. So, question 6. How many different types of 4 connected blocks are there in Tetris? 5, 6, 7, or 8? So question 7 now. Which video game holds the record for having the highest budget ever produced? Is it GTA 5 or Grand Theft Auto 5, Call of Duty Modern Warfare 2, Halo 2, or Destiny? Question 8. Which of these are the best-selling video game franchise of all time? Is it Mario, Tetris, Pokemon, or Call of Duty? Question 9 now. Which of these films made over $1 million at the box office? Was it Minions, Finding Nemo, Harry Potter and the Philosopher's Stone, or Avatar? So, we better change this one. Who is the founder of Apple, the company that sells iPhones and such? Is it Steve Jobs, Tim Cook, Bill Gates, or Jeff Bezos? Good to see most of you got that right. So, question 11 now. The current richest man in the world, Jeff Bezos, is CEO and president of which online retailer? eBay, AliExpress, Amazon, or Steam? Okay, so what year did the first Apple iPhone launch? Was it 2002, 2005, 2007, or 2011? So, bit of a historical twist to this one now. What is the name of the British computer scientist who invented the World Wide Web in 1989? Was it Alan Turing, Tim Berners-Lee, Ada Lovelace, or Tom Scott? Okay, so number 14, for those who are observant, who or what song featured in Lauren Taylor's AR Talk? Was it All Star, Never Gonna Give You Up, Take On Me, or Sandstorm? So, which science fiction writer, referred to in Andrew Bolster's taunt, invented the term robotics? Was it Arthur C. Clarke, Isaac Asimov, apologies, Ray Bradbury, or Philip K. Dick? So, final two tiebreaker questions. What does NIDC stand for? Northern Ireland Developer Conference, Northern Ireland Developer Community, Northern Ireland Developer Company, or Northern Irish Delicious Croissants? Okay, so the very final question is, what is my name? The person who's currently speaking. Is it Sam, Dan, Stuart, or Eugene? So, interesting answers. So, congratulations. Third place. Perfect. So, we're going to check out those results and keep note of them, and we're going to go and put them into the raffle later. We'll let you know how it goes on. But for now, we're going to carry on to our next spot, which is digital making at home. So, a lot of you currently are stuck in the house, maybe going to school, and there's many different things happening. But maybe you were a Jam volunteer or maybe a Jam attendee before, and you now miss the entire environment of it. So do we, trust me, we love doing it. And this is why we're here today. We're going to give a couple of pointers and a bit of advice on different resources you can use online and actually access to do digital making at home. Obviously, we know that equipment might be not as plentiful as it was at the Jam. We had sensors, we had Pis, we had computers and everything set up for you, but unfortunately that's not the case in every house. So we've got a lot of resources online, both free and kits that are available. We've got websites and everything set up just for you to keep an eye on, just to see if we can put on any offers or any actual equipment, and lots of links for you to kind of scurry around and keep an eye on. So for future reference, a lot of the stuff, even the follow-on from the later on workshops, will be available on www.niraspberryjam.com/NIDC. You'll find a lot of links and resources there that'll point you to different directions, and a couple of which I'll go over now. So obviously you have different things such as the Raspberry Pi, and you have other boards like the Arduino. You have ones that are like wee tiny Node MCUs with maybe Wi-Fi chips and everything built on them. We don't expect to cover everything in the 10 minutes we have now, but we're going to give you a bit of a flavor of where you can go to for different things and different resources. So obviously the Raspberry Pi, wee tiny wee computer, you can buy these online and get a hold of them. And quite a lot of different retailers obviously post it to you contact free and safe. If you have your hands on one of these, you can do lots of resources. There's many resources on the Raspberry Pi Foundation website, raspberrypi.org, and that'll lead you into a website that you can search for projects on. You can see other people's tutorials and what they built, and other different projects that you can kind of either research and base your own project off and make your own spin on it, or if you want, you can follow theirs and make your own version. There's stuff like web servers. You can, well, for me personally, I did sellotape my Raspberry Pi to a wall. That didn't go very smoothly. I would not recommend doing that, but again, you can do lots of different projects without sellotaping to the wall. There's online resources, and especially for things like the microbit and such, you'll have websites, and the websites will contain lots of different tutorials. You can kind of gauge your eyes and kind of go through. Maybe you're the kind of person who likes a step-by-step tutorial, not a problem. You can just go through, it's got the steps everything laid out for you. It gives you hints when you're struggling a little bit and you're thinking, maybe you don't know what's happening. It'll explain everything for you, and you'll learn, slowly but surely. This website, makecode.microbit.org, so makecode, M-A-K-E-C-O-D-E, .microbit, M-I-C-R-O-B-I-T.org. That will lead you to the main interface, which will allow you to create new projects, or use existing projects, or use tutorials, whichever tickles your fancy. If you're really wanting to go into it, you can just go straight into the code builder, mess about, maybe turn on a few sensors, turn on the lights. But your main question might be, what if I don't have a microbit? Not a problem. There's a web one built in, and you can use it as an emulator, and you can see what would happen if you'd actually put it on a microbit. Thankfully, it does save you time, and does make it much easier instead of plugging it in, downloading the script onto it. But if you do have a microbit, you can do just that. It'll have all the instructions on the website just for you to use and guide you through on how to use them. We recommend a Chrome browser for that because it makes it much easier, because they have software built in to plug in and recognize a microbit, and it just puts it straight onto the device for you. Moving on from that, we're going to go and talk quickly about Magpie. Now, Magpie do many, many different things, from magazines to different kind of articles and tutorials from all sorts of communities and makers all around the world. Just one central place. Now, Magpie is the official Raspberry Pi magazine by Raspberry Pi creators. Lots of different creators that you may meet in person sometime in the future. Lots of different ones do workshops around both Northern Ireland, Ireland, and all the UK. So you'll most likely bump into them. If you do give them a shout. But all of everything on the actual Magpie website, such as the actual magazines, this is quite an old one. I'm quite old, so matches. Magazines like this do come with a lot of different information, a lot of different articles that you can just kind of flick through, and you can actually kind of go through and just, well, this one is, for example, making your own Babbage Bear, which hooks up to Twitter, and you can actually make a tweet on your behalf. Obviously, if you're creating accounts and such, make sure your parents do that, parent or guardian's behalf, because you're too young. But you can do projects like this, hook it up to Twitter, have a bear with a little camera in it, so when you go past it, it takes a picture. You've obviously got ones, now this one advertises home automation. Do not plug your Raspberry Pi directly into water faucets or whatever. That will not fix your water, and that will not fix your Pi either. But it will give you different kind of projects you can do at home using sensors. Maybe you want to create like a door sensor using tinfoil and wires, not a problem. Everything is contained in this book. Now, These are available on the website for free. You just go on and every month there's a new one sitting there ready for you to download. And these can be downloaded free of charge off the website onto your device, on your computer. You can even view it in your browser. You can also buy these physically in dead tree format. And these are going to be delivered straight to your door, just as any other post or parcel. And you can buy annual subscriptions if you're really interested in it, or maybe a month one, or maybe you want just a single one. It could be from years ago, and they'll just publish it, they'll just print it and send it straight to your door. Moving on from that though, we have guides. Magpie also do little books, and I mean little books, considering that they're a fraction of the size, on specific actual topics or areas. This one is the Minecraft one. Now, I know a lot of kids at the Jam, a lot of people at the Jam in general, love going around and blowing up each other's worlds. Unfortunately, and fortunately actually, you can't do that in your own house, which is a bit safer, especially for us, because we have to restart the files, which is a bit unfortunate. But all of the actual information that we base all of our workshops, and we can base new future workshops, or anything that if you want to create them, can be found in this book. It's got a wide variety of content, it's got different activities from the start to finish, it's got lots of TNT, which we all know you love and blowing up with, and there's lots of different actual activities. Now, there are specific things about this to note. Books like this will cover things in Python. You have ones that cover a language called C. It's very, very, not advanced, but if you go through the book at a good pace, you'll understand it, you'll learn it. But books like this come with little guides at the back as well for all the code you use and little walkthroughs on any information. Like block types, so if you're an experienced Minecraft user, you know that every block has an ID, and you can find that on the back page. Easy to get, all in one book, and roughly costs the same price as the magazine. And again, if you don't want to buy the physical copy, these are quite good though, you just download it for free. You can just go on, it's got things from Pygame, using the terminal, the actual kind of command line interface, it's very cool. You can make it change colors and such. And even from just making games, using terminal, or Minecraft, whatever tickles your fancy. But again, for things such like the Arduino, Arduino's website has a lot of different resources you can find, and in general, if you Google for something, like maybe you want to create like a sensor for a door again, or just a temperature sensor, you can hook up remotes and everything to this. So you have like an infrared sensor, and you can have a TV remote respond, have it react to a TV remote from a good distance away. All of them, just stick it into Google, and it should be able to get you an associated kind of walkthrough or guide. Usually there's no like central resource, but there is a lot of resources in general to find about the Arduino. Lots of different Arduinos as well, just to make sure. So this is the Arduino Uno, just for reference. Very nice wee board, but twice the size of the Raspberry Pi Zero. So yes. So that's going to wrap up this part of the section. If you have any questions, by all means, ask us on Hopin. We have resources online on www.niraspberryjam.com/NIDC. You can find resources to Magpie magazine, you can find all the different resources, and all the links to, or more links to different topics and to different guides. Again, any questions, ask us online, and we're going to move on now. So, this now will lead us to a short break where we're going to show you a nice wee video just to pass the time. Make sure you get yourself rehydrated, a wee bit of water, maybe a couple of biscuits or something, but we'll join you straight after that with Lucy's talk on using the circuit playground.
Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engines running. We have a liftoff. Liftoff on Apollo 11. Okay, engine stop. Tranquility Base here. The Eagle has landed.
I get to be a part of an unprecedented microgravity laboratory, a big, super cool laboratory with all these different facilities, and these experiments, they get to float. It's the only place on Earth you can do experiments with gravity being gone.
I get to train the astronauts that go to the space station, and I also get to work in mission control. When you go to school to become an engineer, you're taught to think critically, you're taught to solve problems, and you're taught to think outside the box to get a job done. And all of those skills I have to use here at my job on a daily basis.
When I was in middle school, IT was not what it is today. Not by a landslide. We studied DOS in our 6th grade computer science classes.
I didn't really know about engineering or science, technology. I didn't know about STEM fields. I think engineering is really solving problems, figuring out ways to solve problems. Engineering is inventing and coming up with new ideas.
I would say that I loved math. I loved everything about math, but I just couldn't see exactly how I would use math in my everyday life once I grew up and got a job. And it's actually one of the foundations to what I do today. We have to figure out what is the right amount of breathing air to give an astronaut while they're in the spacesuit. If we miscalculate or we do our math incorrectly, then the astronaut will not get enough breathing air.
There are days where my job is to go out and spend the entire day outside in a field, either holding a button so that if the robot does something bad, I can make it stop, or testing out my software, or helping other colleagues test out their software. So it's a great day when you actually get to spend your day outside testing things out that you developed and they worked and everything was successful.
It's such an exciting thing to think about, is the idea of humans living and breathing in an environment completely independent of Earth, in some place that's 6 months away.
Scientists these days are some of the most diverse people I've seen. I think the old stereotype of the white lab coat and the pocket protector and the glasses is probably out. In fact, I know some pretty cool women with stiletto heels who are scientists, and I think they're fantastic.
Right now we have a space station. We've been to the moon. Well, we need to set up a base on the moon. We need to set up a base on Mars. And so we always think ahead to the next step. Even though we may not have people there yet, we're trying to bridge that gap to get us to those places.
As a woman, you can do anything you put your heart to. Like, don't let anyone limit you. Don't let anyone hold you back. You should always strive for everything that you want. If you want something, go out there and get it. Don't let anyone hold you back or anything hold you back. You are someone, and you are somebody that can make a big difference in this world, and you just have to go out there and do it.
I also love the idea that I'm working on a human mission to Mars. The work that I do will have helped put a human on another planet.
Technology can be intimidating, but what I can say is there's a technology for everybody. There's something.
We're doing things that nobody's ever done before. We're developing brand new things that have never, before 2 years ago, didn't exist. And we're making them better and making them into something that we can actually use. And that's really cool.
Just because it hasn't been done before doesn't mean that it can't. Just because there aren't more women sitting in that room doesn't mean that there never will be. And that you have the power to change that. Take advantage of every opportunity that you can. Make sure that you do what makes you happy and that you pick something that you are truly interested in. You just have to take a step back and look at the big picture and realize that at the end of the day, you're working for something that's really great.
Welcome back. We hope you enjoyed the break and you got lots of water in you just to rehydrate your body. So at this point, we're going to pass it over to a workshop. For everyone who has a circuit playground, if you get your hands on it just to get ready for this, and make sure you have your kit by your side. If not, not a problem. But I'm going to pass it over to Lucy.
Hiya, my name's Lucy. I'm a software engineer at Queen's University Belfast, and I'm the treasurer of the Northern Ireland Raspberry Jam. Part of my role at the Jam is to help create new workshops, and this is a workshop that we created specifically for the Northern Ireland Dev Conference, but it's similar to a lot of workshops that we've run before. So if everyone has their kit in front of them, the important thing we're going to need to make sure that you have is your batteries are in your holder the right way up, and that you have everything that you're going to need before you get started. So today we'll be using the Circuit Playground, which is a board that has been developed specifically for young people to learn, or any people, to learn how to program and how to make code work with electronics and stuff. So the first thing that I'm going to show you how to do is to wire up your Circuit Playground and how to take it away from your computer as well, so that it's wired away from your computer. And then I'll show you how you can access MakeCode and then get started programming. So the first thing that we have is our Circuit Playground board has two sides to it. One is a micro USB and one is a JST port, which is typically just used for battery packs and stuff. So in order to get the code onto the Circuit Playground once you have it done, you need to take your USB cable and plug the smaller end into the micro USB port and the larger end into your computer once we're ready for that step. And then whenever you need to take your Circuit Playground away from your computer, you then plug the battery pack into the other side, and it should show up a ring of red lights once you turn it on to show that it's on, and then it'll show whatever code you already have on it, which I already have code on this one. The Circuit Playground's a really easy board to use. We love using it at the Jam because it's got so many features on it. It's got so many sensors and outputs that it can make. So it has a speaker as well as the 10 LEDs, which are called NeoPixels whenever they're made by Adafruit. The NeoPixels are programmable, which means we can tell each one of the NeoPixels a different color to be, and it can handle that by itself. And they're also RGB, which means they can take on any color that you can imagine because they use a mixture of red, green, and blue light. That's why sometimes you'll hear people call it like an RGB keyboard. They mean that the lights in it are RGB, and that's where RGB comes from. So once you're familiar with all of your digital kit, all of your physical kit that you need to use, we're going to go over to our browser. So I have the instructions open just on another screen. You'll all have instructions at home, but for people who didn't receive the kit, these are our instructions as well. I think they'll be available on the website afterwards if you already have this kit or if you just want to get started with it at home. And we're going to go to MakeCode, if I can type, .adafruit.com, and it should show up this screen. And obviously I have some projects that I've already worked on, but you will need to click on New Project. And it should open a screen like this. So if any of you have programmed in school, typically primary schools and junior years or secondary schools will program using Scratch or App Inventor, which is a block-based programming language, and it means that you drag and drop all of your components into where you need them to be. So I'm just going to make this bigger. So this is what you'll probably see on your screen. And you can see that it starts off with one block, but all of the blocks are in here. So it's important to take some time to familiarize yourself with the blocks that you're looking at and what aspects of code you need, because each of these will send an instruction to the Circuit Playground. And it's important to be familiar with where you're looking for different aspects of your code. But I think that MakeCode is really good for learning how to figure out where to get those different aspects. So one of the first things that we're going to use today, if I just go back to my instructions, we're going to try dragging out one of the input blocks so that whenever we have an input to our physical Circuit Playground, then we can program it to do something whenever that input is accepted. So for that, you go into input and you drag out this block, which is on light dark. So the point of this workshop today is we're going to make a nightlight. Should have clarified that. So that in the darker hours it turns on and in the lighter hours it turns off. Obviously we're in a studio today, so I'll just simulate darkness however I can. But the point of the nightlight is we want it to be off whenever it's bright and on whenever it's dark. And how we can do that is pull out this block, and this block is a direct representation of what your circuit playground is. And you can see that whenever you have some code into your workspace, it'll show up on the left hand side in the emulated circuit playground. So this emulated circuit playground is a really good way of testing your code before you actually put it onto your board. And whenever you use the light sensor, you can see that you have to scroll up and down this little circle to modify the light levels. So whenever it's really dark, it'll turn on, and whenever it's really bright, it should turn off. Oh, I haven't given it anything to do whenever it's really bright, that's why. So I can also pull out another one, and whenever you see a drop-down tab in any of these blocks, you can click on it, and it will drop down all of the options that you can be given. So the other option other than dark is obviously bright, and then whenever we want it to be off, we can select the grey in the center of the circuit playground diagram, and that will just blank out all of your lights. And this is a bit tedious, but there we go. So we essentially have a working nightlight at this point. So whenever it's dark, the lights go red, and whenever it's bright, the lights turn off. And you can see that emulated in your circuit playground over to the side. So the next step now is we have all of this code written. So this is what your code should look like, and this is what mine does look like. The next thing that we want to do is download the code. Now, I'm quite good at writing instructions, but I'm not very good at checking that they work. So the instructions that I've written on the worksheet aren't exactly right because the software inside the circuit playgrounds has changed in the past month since I wrote the worksheet. So what we're going to do is plug in our circuit playground into our computer the way that we talked about earlier. So micro USB into the silver port, and then bigger USB into any USB port on your computer. And there are a couple of ways that you can download onto your computer. So obviously that's bringing it up because it's recognizing that there's a device plugged into the computer, but I don't need that right now. What I can do is, if you're on some browsers, so I know it definitely works on Chrome, but some other browsers, you might be able to go into the cog at the top right and go to pair device. And my computer generally already knows it's there because I do it so much. And then you're looking for C Play Express, which is what your circuit playground is. It's a Circuit Playground Express developer board. And you want to just pair your device to your computer so that they can talk to each other and you don't have to look in the file system to find your device. And what should happen is you click download and it should, yeah, so that's right. So whenever if I turn it over so that it gets dark, you can see that, ignore that error message, so that doesn't mean anything. Whenever it gets dark, you can see that the lights come on, and whenever it's much brighter, I can probably hold it up to that light. Yeah, the lights go off. So you've got all your code written and downloaded to your circuit playground. The other way that you can go about doing it, so I'm just going to change the colors so that you can see that I've downloaded new code. So I'm just going to change all the colors to pink, and then I'll show you the longer way of downloading code, because sometimes some browsers don't support it, and I'd like it if you were able to also join in if you didn't have the right kind of browser. So we won't pair it this time, but I'll just make sure it's not paired. No, I want to unpair it. So instead, what you can sometimes do is click download, and it should download it to your browser. And then you'll move the downloaded file. Yeah, so you want to click on this button, Circuit Playground Untitled, because I haven't given a name to our project yet, because I was going to do that in a minute. So once you download the actual file, it should show up in the bottom of your browser down at the bottom left where downloads normally show up. And then you're going to go into your file explorer and go into downloads, and then you want to move. So if you're all the lights on your Circuit Playground are off, what you need to do then is click the button until they're all on. In the worksheet I said until they're all off, but I meant all on. So it needs to have all the green lights on it to show that it's in programming mode. And then that way we can drag this new file that we've just created into here, into our folder, and it should, if I make it dark, so it's gone pink. So that's a slightly more complicated and longer way of downloading stuff onto your Circuit Playground. That's why they built the pairing device ability, so that you're able to do it really quickly and easily. For the rest of this, I'm going to use the pairing device way, but if you have any struggles with it, yeah, I've just been texted. If you have any questions, pop them into the chat and then they'll be sent to me and I'll be able to show you how to do it again, just if you get stuck with it. So the next part is, yeah, so we've downloaded it all. The next part is there are some challenges that we could work on to make our code more complicated than this. So far we do have a working nightlight. It goes dark, or it goes off whenever it's bright outside and it goes on whenever it's dark outside. So I've written 3 challenges that are of varying levels of difficulty. If you have the physical printed out version of this, the challenge will be at the bottom of the page and then the solution will be at the top of the next page so that you don't accidentally see it. But it discusses if and else blocks, as well as how to change the brightness between 0 and 255, and I'll discuss in a minute why that number is important. And then also how to use an array, because I figured I should cater it to all abilities. But the next step, if you want to keep working on the code side of it, that's great. But the next step that I'm going to do is I'm going to work on the housing that we've designed. So at the NI Raspberry Jam, we pride ourselves in being able to have a bit of fun with electronics, but then also integrate some creative stuff with it. Not everything has to be about computers and on computers. You can do a lot of like non-screen time that will still be very rewarding and still like add to your project. Because this is a great nightlight, but it would look a lot better if it had a casing. So I'm just gonna cut this out, proper Blue Peter style. Oh, in true Blue Peter fashion, I do actually have some that I made earlier, if the lights would come on. So you can see I've put a rainbow light on that, and then you just slot that over the top, and you can see whenever it's in a dark room, it glows out nicely. Kaylin, do we have any questions yet? Haven't been texted yet. Yeah, so at the Jam we do a lot of sort of making stuff, and we would do a lot of cutting and sticking because we like integrating our electronics projects into other projects. So a good example of that we have at the Jam that we run regularly is the microbit milk monsters. So a Circuit Playground is very similar to a microbit in that you can have a lot of inputs and different outputs with the microbit, but the Circuit Playground just has lights on it which are much brighter, and you can change the colors and stuff, so it's why I like using it. But the microbit is great for integrating with like motors and stuff and servos. So a servo is a motor that can turn in both directions, and we use that at the Jam to create these milk monsters out of old-fashioned like milk cartons or orange juice cartons, like the Tetra Pak ones that we cut the teeth out of, and then we install a servo so that the mouth opens and closes. And it's a great way to get kids to learn without realizing that they're actually doing some learning. Because in that they'd have to figure out directions of rotation and stuff. But with this project, we just have nice, easy, simple lights. So I designed this this casing based on the casing that we have for a similar workshop, which is the microbit nightlight. It was designed like a little house, and I decided that I wanted our Circuit Playground design to be like a spaceship because I was watching Apollo documentaries, so that's where that came from. And I decided to make it, I'm not even cutting that. I decided to make it based on a pentagon because it just looked a lot cooler and it was a bit more complicated. And I like showing the process of whenever I make stuff, how I design it. So the first one started off like this. It was just I think we've got the top-down camera. It was just a piece of scrap paper that I had that I drew out all the shapes that I knew I needed, and I worked out the angles of the triangles and stuff so that it would all meet in the middle, and I just taped it up. And then after that, I took all those measurements and put them into Fusion 360, which is a CAD program, so that I could have a very accurate layout of the template. And then I put that into Autodesk Sketchbook and drew the spaceship design on it, with all the windows and the bolts and the little space person inside, a little astronaut or cosmonaut. I have to cut this out very carefully so that it'll stick together in the right way. Keelan's telling me you have no questions yet, so you must all be flying. Everyone's got an array in theirs now. Everyone knows exactly what an array list is. So as I spoke about, the first challenge uses an if-then-else block, which is really good for understanding how computers make decisions. And a lot of people always tell me programming using blocks isn't really programming, which I always disagree with, because the point of it isn't to actually write loads and loads of code, but it's to understand what each component does, and having it separated into the blocks like you're using today really helps you figure out what each component does and why you're using it, and why it's why the if and then has to go with the else, and why that helps the computer make decisions. My computer's about to turn off. And also a great thing in MakeCode is, if you're at all familiar with JavaScript, which I can't claim that I am, there is also a JavaScript translator which turns all the code into, it turns all your blocks into real JavaScript, which is just an interesting way of learning JavaScript. One of the people that runs the Northern Ireland Raspberry Jam, Andrew Mulholland, who's our chairperson, he helped make that feature, and he said he's very proud of it. Sam's nodding at me. Yeah, so the first challenge is, can you implement the same thing using an if-then-else block instead of using the on-light or on-dark blocks? The second challenge is, how can you modify it so that you get to decide what the threshold of brightness and darkness is? And that requires an understanding of how light is measured by computers. So computers use a lot of binary. So yeah, that took me a while, but I got that cut out. And the next step, just while I interrupt my own binary talk, the next step is to fold along all of the dashed lines, and that includes all the ones up here. It's a bit easier if you have a ruler to do this, because you can fold it over the ruler and then do that, but I'm just going to do it by hand. So the second challenge is about brightness, and that means you need to understand how computers think about brightness and how they store brightness. Because obviously I could come into the studio today and be like, well, this part of the studio is quite bright, but that part's quite dark, so we have to put a numerical value on that. And computers use a lot of binary because it's an easy way for them to store things, because it can either be 0 or 1, or on or off, or yes or no. So binary means there's two states of something, and binary is base 2, and then if you put 2 to the power of 8, which is a byte, that's 256, which is why you'll see 256 or 128, which is 2 to the power 7, in a lot of different computer things, and especially in the second challenge. You'll see 255, because if you have 256 states and you include 0, that goes from 0 to 255, which is what brightness is measured in on circuit playgrounds, as well as, so that's the brightness that's coming in on the LDR, as well as the brightness that's coming out of the lights. That's also measured 0 to 255. So that's just why computers use those numbers. The tricky part now about this template is getting all of these little folds exactly right so that your spaceship can look as space-worthy as possible. Otherwise, your astronaut will be all over the place. Okay, so there's 3 done. I think I'm just going to use tape today because it's a bit quicker and I don't have to hold it till it dries. But you can use tape or glue to put these together. You can also colour it in. But today I've just decided to not. So you can see how once you've folded all those pieces together, you're starting to make the right sort of shape. So I always tape this side first. This is the long side because it's the easiest. And then I'll fiddle about with all the top bit in a minute. So take some tape. I'm just going to pop it on the inside so that it's hidden away. I'm going to put this flap on the inside of this and make sure that all of the lines line up so that all of our pieces of the spaceship work together. And just stick it like that. Oh, nice. They'll never hire me for Blue Peter now. What am I going to do? Okay, so we've got our first side done, and it's the same process, but with the 5 points, which does get a bit more fiddly. So I'll put some more tape on that on the outside. So I'll hold it all together. You can also use glue so that you can't see the tip, but it's a bit fiddlier. And then once you have this, you can slide it over your. I'll show you how you can wrap the circuit playground in the battery so that it stays nice and compact. I didn't want to have to make a massive casing just so I could fit the circuit playground in. So you can see how if you manage to get those lined up really well, then it will just naturally form a point. And then just make sure the tape's really secure on the inside. Nice. You just have to do that 4 more times. Still no questions, Keelan? Is everyone doing okay with the programming bit? Has everyone got a functioning nightlight? Nice. This is better than it would have gone at a normal jump. I would have had loads of questions by now. Oh, my computer's gone. I think I explained it a bit better and I wrote better instructions. I normally don't write instructions for the jam because we've got so many great volunteers that can just jump in and explain things. But I figured, seeing as we have all of our students today working by themselves at home or with their parents at home, I would do a bit of a better job on the worksheet. So once we have all of the points together, this is so fiddly. Why did I design this? Who designed this? Okay, one more. This one's the hard one because you have to put 2 in at the same time. And then I will run you through the rest of the, I'm just going to stick on the outside, I can't be bothered. It's too fiddly. I'll run you through the rest of the coding challenges and sort of explain how you can use arrays and stuff and how just because it's MakeCode and just because it looks very basic and it's got very bright colors doesn't mean that you can't use proper programming techniques and proper programming features. It is like a genuine thing that you're able to use and you can use it in real life projects and it will work and it's very like robust and you can trust that your code is always going to do the right thing on the circuit playground. It's never going to fail you. So there's no reason to sort of feel better if you somehow write the code in words than in blocks. So once we've got our spaceship, mine's a little bit lopsided, but the spaceman seems very happy. We're going to. Do we have a question? No compatible device found. Error when we tried to pair. So that means you need to, if you're having the no compatible device error, is that whenever you get to this point? So this is the point where you've clicked the cog and you've clicked pair, and it's brought up a security thing being like, Adafruit would like to connect to your computer. I'm not getting any live feedback. Keelan's still asking questions. I think, so if I unplug it, does it say that error? Oh, you're getting this error, no compatible device is fine. What you need to do, I think, because they change this a lot, which is why the instructions are wrong. What I think you need to do is have it on this mode. So whenever you need to press the very small center button until it goes red and then green really quick, and then you compare it. But the people who make Adafruit aren't the same people who make MakeCode, so sometimes they disagree about how this works. That's why it changes a lot, and that's why it's not right. So I think that should work once you've hit the center button until it goes green, because that means it's in programming mode, and that means that it's looking, or the computer is actively looking for it. I hope that helps. Kaelan will tell me in a minute if that helps. What I'm going to do now is show you how you can wrap up your circuit playground. So once you can unplug it from your micro USB, there's no power to this anymore, but the code is stored on it, and it's a very small amount of storage so that you can store code on it. Everyone is saying yes, okay. That probably means it's sorted. You keep interrupting me talking about storage. It's got a very small amount of storage, so you can store just enough for one program, but it can't store loads of stuff. It basically just rewrites over the last program every time you upload one. So if you plug it into your battery pack, this is quite a big, chunky thing to try and fit under our little casing. So I always wrap this part of the cable underneath the clothing hook. So this is a battery pack if you want to sew it into something or clip it onto something, which is really useful, and we should have used it in other projects, but we just bought these recently. So if you clip it under there and then set that directly on top, sometimes you can secure it with a piece of tape. This has Velcro on it for a different project, but if you secure it with some tape, then it won't move anywhere, or you can just hook it underneath this part of the cable. That means that you can set it down on the table, and it's basically going to always point upright, and your lights are always going to come out. And Sam keeps trying to show me your comments from so far away. He's tried to make the font really big so that it's under, so I can't tell. But yeah, so there we go. You slot your housing over the top of your circuit playground, and it works like that. Obviously, I'm in a very brightly lit studio. Thanks, that worked, okay. I'm in a very brightly lit studio, so it's hard for me to simulate darkness and stuff so that it can go on and off. But yeah, if it's on, then that means it thinks it's dark, which is why I've written the further challenges. But you can play about with a torch. Generally, it works really well with a torch if you turn it on and off to like shine the light directly at the circuit playground, like at this face, because that's where it's detecting the light. But obviously, very bright lights, it's kind of confused, and also the light is reflecting off the white of the paper, so that's why I wrote the other challenges, so that you get to decide what your circuit playground thinks is brightness and darkness. So there you can see the second challenge was, now that you know brightness is measured on a scale from 0 to 255, how could you make the neopixels change brightness gradually as the light around you gets brighter and darker? And you can see the code is written there. And the code is basically, mine is showing the green light but still not connected. Hold it till it's green. No, you should just have to click it once. So it's so there's two big buttons, and then there's one very small reset button in the middle, and it should go red, and then, oh no, that's only if it's plugged into the computer. It has to be plugged into the computer first, that's why it's weird. It should go red and then green very quickly as the computer recognizes it. That's what it's saying. Yeah, so there is it off, and there is red and green very quick. So that's what you're looking for. Mine is showing green light, but still not connected. Have you tried, whenever you plug it in, does it pop up with the file explorer? Is the computer recognizing that your device is there in the file explorer? Because it might just be your browser isn't recognizing that it's there. Kaelan will get back to me on if that worked. Yeah, so the second challenge was, sometimes you don't want it to just come on and off, like black or white, and you want it to fade up and fade down. So I think we could probably do this code very quick. So what we're going to do is, on start, we need to set all the pixels to one color, and it's important that we differentiate between what you do on the start of your program. What do the big buttons do? Oh, the big buttons can be used as an input as well. So instead of having the light as an input, you can use sound. So you can do something if you clap your hands in front of it, you can make it do something on that loud sound. Yeah, it is like the microbit. It has two buttons on it like the microbit. And then you can press either the A button or the B button depending on what you want it to do. Me and Sam will cover that in the next 10 minutes after this whenever we talk about all sorts of microbits and Circuit Playground projects. But yeah, in this solution 2 code, if I can ever get through it, it's important to differentiate between what you do on the start of a program and what you do continually throughout the program. And that's what I was trying to get at with this piece of code. So on the start of your program, you want to set all the pixels to pink, but you don't want to change the color of all the pixels all the time, but you don't want to continuously reset them to pink, because that would just be a waste of your Circuit Playground's computing power. And then what you want it to continuously do is measure the light level, which is the pink block in there, because that comes from the light part. Someone in chat. That comes from the pink block section, and then you want to put it in some purple blocks, which are from the maths section, or we would say maths, because then that's doing some calculations. So you can see how MakeCode looks really basic, and it is really bright colors, and it's rounded blocks and stuff, and it looks really, really simple. But you can do so much with it because it does have the aspect of like calculation and decision making, and you can implement arrays and you can set up variables and stuff. So just because we use it for the very basics doesn't mean that it in itself is only for basic things. You can really use it for anything. And we have a lot of projects that we've written in MakeCode that have gotten very complicated, and then we can go in and edit the JavaScript so that we can do some stuff that the blocks maybe can't do. But this worksheet will be uploaded, I think, to the website after this talk, which is ending shortly. And you'll be able to work away on the challenge 2 and challenge 3, which are the harder ones, which are designed more to test your like actual programming skills. But yeah, that's me. I've got a lovely wee nightlight now. Well, I've actually got 2. And I hope everyone has gotten through it and has been able to get it working. Someone has said that sometimes that issue of it not going green is an issue with the USB cable, which I have found, which is why we have so many USB cables at the jam. Sometimes it's just a dodgy connection, or we sent them out to you so we know that it's the right kind, but sometimes it can be the wrong kind of USB cable. We'll be here for a lot of the day, and you can keep putting questions in the chat if you're still working on this workshop in between now and the next workshop. And I hope to see lots of photos of nightlights tweeted at me and at the Raspberry Jam and at NIDC. I'm at astro_Lucy Bell on Twitter because I like to pretend I'm an astronaut. And we also have at NIRaspJam, RASPJAM. And then we also have NIDC and all those people. So make sure you send in loads of photos because I want to see them. I want to see the thing that I helped design in other people's hands, in other people's code. And I think me and Sam are now going to be talking about the wearables projects that we've worked on and how these sort of like workshops have come from those projects and how we've simplified the project into a workshop so that everyone can access it. And that's me. So, welcome back. Hopefully you enjoyed the entire workshop and you got your rocket to finally light up with all the different kind of components put together in MakeCode onto your Circuit Playground. Any issues, once again, fire them into Hopin chat. We'll be on straight onto them to help fix them. So at this point, we're going to have a little bit of a discussion between myself and Lucy, and we're going to talk about some of the projects that have happened in the past. Specifically, there was one where we both attended a formal, Lucy's formal to be exact, and Andrew Mulholland, the genius that he is, had recommended that we put LEDs and integrate some sort of lighting into our, well, my suit, into her dress. So today she actually has the dress. I unfortunately could not get a hold of the hat, but it's got all sorts of computing elements to it. We're going to explain through what we did and actually what happened, and hopefully
give you a bit of inspiration on what you can do in your own time. So.
The unicorn horn has the wrong code on it.
Oh, okay.
Whatever.
So
if everyone's probably wondering, why is she wearing a dress to a tech conference? What's that all about? Hopefully this should turn on. So as you can see, this was our formal dress, my formal dress, and Sam's formal hat. It doesn't read very well on a very bright studio. Do you want me to stand somewhere else? No? Oh, you're going to turn it off? Yeah. So it should be flickering and sparkling because Andrew very carefully wrote the code so that we weren't using too many of the lights at one time because there was issues with power. But this dress uses a microbit, whereas we were using circuit playgrounds a minute ago, and it uses 2 different power supplies. So it has one power supply for the microbit and one power supply for the lights, because the lights need a lot more power. And on the surface, it always seems to people like a really simple project. Put some lights in a dress, you look like a Christmas tree. But whenever you actually start working on it, you do have to do the calculations of how many volts and how much current do I need for these 10 lights, or 9 lights today because one broke, and how much of that do I need for the microbit. And if I power those 2 things off the same power supply, is that going to create a problem for the microbit, because the microbit can't handle that much electricity. So you do, what looks like a very simple project does involve like trying to figure out the difference between parallel and series circuits, because me and Andrew argued for weeks about whether a NeoPixel was a parallel or series thing, because it had 3 different ports on it, so we couldn't figure it out. And then your hat also used a microbit, but in a slightly different way. So yours didn't sparkle, yours just created a rainbow. So I'll leave the dress on, but I'll sit down so that Sam can also have some time in the spotlight.
So thankfully, I actually do have a microbit on me. And so basically this small device with all its wee pins on the bottom, we're able to power and to control the actual chain, and daisy chain of LEDs, which Lucy had put together, soldered and got working, and then Andrew helped diagnose any issues and help us out along the way. Whereas with the hat, far simpler, far simpler. Essentially, it had a battery in it, had a controller, and an LED strip. Pretty simple. So the LED strip was just like the one you use on the circuit playground. It had LEDs on it. You could just tell it, right, I want this color, and it lit up that color. And you could say, this set of LEDs, or these number of LEDs, I want you to light up this color, and set the other colors all independently. We've tried to go a bit simpler with the hat though. The actual LEDs only went rainbow, and it kind of faded across the top of the top hat because you had a tall kind of surface that you could actually shine the light onto. Very, very nice kind of look. Although it was navy, you could still see the color coming through. Now, the battery was a bit of an issue. Unfortunately, it's not as easy to get a hold of the battery, and so that was the hardest part of it. But other than that, the microbit, we also tried out what's called an Adafruit Gemma, which is basically the size of a 2p coin, and it can tie into so many different wearable technology. You've got thread, which you can sew, and you can actually... It's like a very
small circuit playground.
So
I think it has fewer lights on it.
Oh yeah, no, the thing is, the components though for it, it's all sewable thread, which should conduct electricity. And you had experience with electricity?
Yes, I had experience with electricity. You might have noticed that the circuit playground has holes all the way around, and the pads, what we'll call electrical pads, are they're sort of gold because they can be used like a pin on a Raspberry Pi. So whenever you plug something into the GPIO of a Raspberry Pi, that is like a physical connection to something else, and you can do that with the pads on a circuit playground as well. You can either use crocodile clips, it's very crocodile clip friendly, we use that a lot at the Jam, or you can use conductive thread, which you can buy from Pi Moroni, which is a UK distributor of, this is for all the parents, is a UK distributor of Adafruit, who make all of these amazing components. And it's just thread which has a little bit of steel running through it so that you can wrap it around something really tight and you'll have a physical electrical connection between that thing, but it's still really flexible and you can still integrate it into clothes and stuff. We started using steel for this dress, or we started using steel thread for this dress, or conductive thread, which sometimes has silver as well. But it was too much steel thread, so you have to think about like the length that your electricity has to go over, because it can burn out the thread, whereas it can't burn out the copper, which we eventually used. But yeah, conductive sewing is really interesting, and it's a really great way integrate electronics into much like lighter clothes, whereas a top hat is a very rigid thing, so you can just use real wires.
Mm-hmm. So that's where, with ours, all you had to do is poke a hole through the actual bottom of the hat and feed the wire through, and it went straight onto the hat, or straight into the LEDs. But other than that, the actual code side of it, a bit different. I know for Lucy, it was a make code interface.
Yeah,
and
we used make code, which we use today. It's really simple to use, and it created the rainbow pattern that's on this dress. But you used...
So this is a bit different. Essentially, the program, the Gemma, you can either do it through the Arduino library, which is a bit finicky to work with, but works, it does. But the primary use was, or the primary way to program it was, I think we dropped an Arduino script onto it, just to kind of make sure we could work with the low-level kind of components of it. There are other ways to program it through graphical user interfaces, but we unfortunately we ended up using just the script and using C just to program it all together. So yeah.
So we turned all of these projects into workshops that we can run at the Jam, like the Nightlight, which is going to be a new one. But we also created these unicorn horns, which it's a circuit playground velcroed to a hat with a battery attached to the brim of the hat and a 3D printed unicorn horn on it. It currently has the Nightlight code on it because I forgot, which is why it's not lighting up. But using 3D printing means that we can have a whole different conversation with students at the Jam about different parts of technology that we're able to use to integrate with our electronics. The same way that we did a bit of arts and crafts to cut and stick the Nightlight casing, being able to show them how we drew that in a pirated version of SolidWorks and then redrew it in Fusion, and we printed them out on Andrew's Anet A8 3D printer, which he just has at home. It's a really good way of like bringing technology that seems so futuristic like to real life with younger students.
And the thing is, with 3D printing as well, it's like if you're missing a component, you just print it. Now, granted, it does take hours, but you can do quite a lot. There was workshops that took place across in England at an event called MozFest where you used the microbit to create a lockbox, and you had basically 2 parts to print. You had the lid and the case. You slot the microbit into the case and the lid goes on, and there's little pads on the case that will click in the buttons on this to say this is armed, so you can't unlock it or else an alarm will go off. Little things like that can be quite useful for doing stuff at home, but obviously this is equipment that you'll have to get your hands on. Everything is available online, and you can actually buy it through, well, distributors like Pi-Moroni or Pi-Hut also do different components, including stuff like microbit, say Circuit Playground, and Raspberry Pi components. Also, with the Pi, you have options of hats. Now, hats are very different. Hats use the pins, or the GPIO pins on the top, which are very spiky. Make sure you don't poke them too much or they will hurt. And basically, you just plug a board straight on top of it, and you've just expanded the functionality, many more features to your Pi. You have things like the Explorer hat, which allows you to have touch capacitive pads that you can touch on, or, as Lucy was saying, crocodile clips. And the crocodile clips can then lead to a piece of tinfoil. Or if you're really adventurous and also very, very aware of the social distancing guidelines, if you and someone else in your household wanted to high five, you could high five and you could run a piece of code. Very simply done, all through Scratch and all through the same interface that was explained by Lucy through using the Circuit Playground. Now, once again, they're all available online. We do also have other projects. The Pi uses boards as well, like the Explorer hat and all that, all going on, all online that you can get. But I think for now we have a couple of questions that came through. So I'm just waiting.
Oh, in Sam's ear. I was like, where's the question?
There is a, why am I here? Could you read it out? Could you say it again? Oh,
that's a good question. We tested it so much throughout the day. So I think I started at like 9. Andrew was a student at Queen's, so he woke up at approximately 2 p.m., which was early for him. And he came over to my house and brought the dress because he had been fixing it the night before. And we were testing it so much throughout the day that we completely drained the batteries. But we didn't realize because we hadn't thought about it. And then when we got to the formal, we got in through the front door and basically sat down at the table. And I was like, the dress is off. And Sam was like, what are we going to do? Wait, I have another battery. So Sam just had another battery, which completely saved the evening. Because otherwise the dress would have been off for the entire formal and no one would have seen it. But yeah, it's really important. Today I have like 20 spare batteries just in case this stopped happening or in case the circuit playground stopped happening, purely because of Sam's ingenuity to bring a spare battery pack.
The thing is as well, one thing that was kind of like the loophole in all this that Andrew kind of like, put in the terms and conditions of this was we had to show up the next day at the jam fully dressed. I was in my suit and top hat, and Lucy was in her dress, and we had to do our workshops, the general running about, and did help out volunteering in the dress and the suit. Now, obviously, I didn't wear the suit. No, I did wear the suit. I didn't wear the dress, and Lucy didn't wear the suit. But we did have our own things that we had to work with on the day and make sure, I didn't lose a jacket or something like that.
I think the hat survived the whole time. The dress has copper wire in it, so it basically pulled out whenever I was at the jam. So only the top 3 lights worked at the jam. But everyone got to see the lovely photos from the night before. And I managed to fix it again yesterday after it being in a cupboard for 2.5 years. I fixed it again yesterday so that all of them work again.
Little projects like that as well, we do kind of like very spontaneously. There's ones where I think it was a high altitude balloon was sent up, and there were photos and such taken that we show off in talks at the jam, and we just put on Twitter. So usually if you have any interest or you see projects that we do, give us a shout. We're happy to kind of go through, usually in talks at the jam, what actually happens and how we did them.
Does Keelan have another question? Because he's making faces at us. Overheating? No, because we thought very specifically about that. So this has copper wire in it that I've twisted like 4 times around itself. I made like 20 meters of this 4-ply copper wire so that it had enough of a thickness, because I was doing AS physics at the time, so I thought I knew everything about electricity. It had enough of a thickness so that the voltage and current that was going through it, that I knew, that I calculated was going through it, wasn't going to burn it out. Whereas if we had used conductive thread, it would have burnt it out, and that's a common problem with a lot of other people's sewable projects because they use conductive thread that isn't thick enough.
Whereas in my case, my head was just very warm, and it just heated up, and then there was a bit of sweat on top of my head. And also, I didn't want the battery to have or fall on my head or anything or have overheated. So, but in general, it was kind of a case of mine was passively cold. It was just my head that was warm. But Lucy did have.
I did some maths about the overheating so that it didn't happen.
Everything was considered very carefully because she had a battery pack. We both had batteries. She had a battery pack. I had a raw battery, just to make sure we're all safe, and no one else in the formula was in any way, shape, or form going to get included in it. So yeah.
But yeah, it was a good project, and it led to a lot of the workshops that we now run at the jam. You can find out how to buy some of the components that we used, or find some of the what, Keelan?
Ooh.
Anyone, 6 to 106. It's for the young and the young at heart. We do have some jam people that come that are younger than 6 because they're with their parents, obviously, and they get a lot out of it because they've been brought up in a sort of a household and a culture of technology, so they're much better at like getting stuck in with it right away. But if you want to get involved in it more throughout your time during lockdown, whenever we can't have as many jams or we can't have as many in-person events, we do have a lot of resources on niraspberryjam.com/NIDC, and then also we tweet a lot of resources all the time on @NIRaspJam on Twitter, because we love the jam as much as anyone who goes there loves it, because it's just as much fun for us. And we are kind of like glad that we got to do this today, because it is a lot of it's a lot of the same stuff just without a huge audience, but getting the questions in means that we kind of get to feel that anyway. One last question. Running a workshop by yourself is like talking to yourself in the bathroom mirror. You completely forget that there's a camera there, and you just sort of get on with it, because running a workshop whenever you're in front of a class of 30 children, you're used to making eye contact and you're used to checking that each person is individually okay. But I think being able to answer questions as they were brought in made it a lot more sort of connected. But you just sort of forget that the camera's there, and you're just chatting to yourself about the reason that 255 is an important number.
Okay, so just pass on. That's going to be, that's I think us finished with our talk, and kind of just going through the different kind of things that have happened project-wise. What we're going to do now is we're going to pass straight on into another break, and at this point, it's just going to be get rehydrated again, make sure you're all okay, have a couple biscuits once again, but we'll see you again very shortly.
I was 13 when I first got access to a computer.
My parents bought me a Macintosh in 1984 when I was 8 years old. I was in 6th grade.
I learned to code in college. Freshman year, first semester, intro to computer science.
I wrote a program to play tic-tac-toe.
I think it was pretty humble beginnings. I think the first program I wrote asked things like, what's your favorite color? Or how old are you?
I first learned how to make a green circle and a red square appear on the screen.
The first time I actually had something come up and say, hello world, and I made a computer do that. It was just astonishing.
Learning how to program didn't start off as wanting to learn all of computer science or trying to master this discipline or anything like that. It just started off because I wanted to do this one simple thing. I wanted to make something that was fun for myself and my sisters. And I wrote this little program and then basically just added a little bit to it. And then when I needed to learn something new, I looked it up either in a book or on the internet and then added a little bit to it.
It's really not unlike kind of playing an instrument or something, or playing a sport. It starts out being very intimidating, but you kind of get the hang of it over time.
Coding is something that can be learned, and I know it can be intimidating. A lot of things are intimidating, but what isn't?
A lot of the coding that people do is actually fairly simple. It's more about the process of breaking down problems than sort of coming up with complicated algorithms as people traditionally think about it.
You don't have to be a genius to know how to code. You need to be determined.
Addition, subtraction, that's about it.
You should probably know your multiplication tables.
You don't have to be a genius to code. Do you have to be a genius to read?
Even if you want to become a race car driver or play baseball or build a house, all of these things have been turned upside down by software.
What it is, computers are everywhere. You want to work in agriculture? Do you want to work in entertainment? Do you want to work in manufacturing? It's just all over.
Here we are, 2013. We all depend on technology to communicate, to bank, information, and none of us know how to read and write code.
When I was in school, I was in this after-school group called the Whiz Kids. And when people found out, they laughed at me and, all these things. And I'm like, man, I don't care. I think it's cool. And, I'm learning a lot. And some of my friends have jobs.
Our policy is literally to hire as many talented engineers as we can find. The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
To get the very best people, we try to make the office as awesome as possible.
We have a fantastic chef.
Free food.
Breakfast, lunch, and dinner.
Free laundry.
Snacks. Even places to play and video games and scooters. There's all these kind of interesting things around the office and places where people can play or relax or go to think or play music or be creative.
Whether you're trying to make a lot of money or whether you just want to change the world, computer programming is an incredibly empowering skill to learn.
I think if someone had told me that software is really about humanity, that it's really about helping people by using computer technology, it would have changed my outlook a lot earlier.
To be able to actually come up with an idea and then see it in your hands and then be able to press a button and have it be in millions of people's hands. I think we're the first generation in the world that's really ever had that kind of experience.
Just to think that, you can start something in
your college dorm room, and you can have a set of people who haven't built a big company before come together and build something that 1 billion people use as part of their daily lives is just crazy to think about, right? It's humbling and it's amazing.
The programmers of tomorrow are the wizards of the future. You know, you're going to look like you have magic powers compared to everybody else.
I think it's amazing. I think it's the closest thing we have to a superpower.
Great coders are today's rock stars. That's it.
Welcome back. So next we have is Kevin Beamers. He currently runs an Hollywood indie video game studio called Italic Pig. For the past 8 years, him and his incredibly talented and attractive team have been developing very high concept entertainment for all platforms. Kevin is a former chairperson of Games NI and is interested in helping other communities such as the Northern Ireland Raspberry Jam with different events, helping coordinate different projects and giving you a bit of a taster of the games industry. He's going to join us now live from the workshop and give you a kind of insight on games development.
How you doing? My name's Kevin Beamers. As Sam said, I want to thank Sam for inviting me out here for one of the talks today at NIDC. I've got a talk entitled, I guess, How I Got Into Games. It might be how you could get into games. I think it's probably best to call it, it's easier to get into games than you might think. Let's start with an introduction. My name's Kevin. We did that already. I am 43 years old, which means I have a very difficult time identifying with all of you out there. I'm assuming we're talking to the Raspberry Jam sized audience, which is anywhere from, I don't know, 6 up until whenever you stop becoming a child. I guess I'm still in that bracket. Right, 43, and that means that I am older than the internet. I just think that that's a really interesting point that we have to make here, that you're all growing up in a time when the internet is there and has always been there. And a lot of us, you know, in the 43 and up age bracket, remember a time when you had to figure things out for yourselves. So this here is a dramatization. It's not a picture of me, but it's a picture of someone very much like me getting my first Atari video game system way back, I don't know, this must have been 1985, sometime around the time when Marty McFly had his DeLorean thrust upon him. At this time, the idea of a home game system was incredible. Imagine not having to go to an arcade and pay quarters, or did you want 20 P's here? I don't know. Anyway, plunking money into a machine to play games that other people have made, it was such a distant idea of a career, and finally was inside the home. On the back of that, the Commodore 64, some of you may have grown up with, or not grown up with, some of you parents would have had like a VIC-20, maybe a ZX Spectrum, maybe something like that, like way, way back we're talking. And this system needed something. This system had games, it had stuff that you could play with, it had stuff that you could hack. Stuff that you can get into the bits and pieces of and see how they worked. And this is where I learned to not only play games, but to make games. Fast forward, let's talk 30-something years into the future, and I'm now running a company called Italic Pig. Now, Italic Pig, as Sam said, we make high-concept video games, we jump around genres, we focus on strange narrative, quirky stories, goofy dialogue, that kind of a thing. First game we made was called Schrodinger's Cat and the Raiders of the Lost Quark. It was a quantum physics action adventure. Worked for quite a while on a game called Mona Lisa, which was a Renaissance art heist and forgery game. We put quite a lot of work into a game called The Infinite Hotel. The Infinite Hotel is a VR game. It's our first step into the immersive space where you play the elevator operator in a hotel with an infinite number of floors. We're currently working heavy into a game called Paleo Pines. Some of you may have seen it on social media and things like that, but it's a game where it's a management sim where you are farming with dinosaurs. And we've got this one, Quest, that's coming up the pipe. That one we've just been funded for prototype fund from the Creative Europe Media. But anyway, all these games I'd like to say they all build on the one before, but they don't. They're all completely different from the one before. Don't start a business that way anyway. But what it means is that when you make a game, you are not an expert at making games. You are an expert at making one game by the time you're finished. And then you move on to the next game, and you either build on the stuff you know, or you go, I've done that, let's try something else. Now, you came here for how to get into games. It might be easier than you think. All right, so how did I go from being that guy, jumping up and down with my Atari, to being the guy at Italic Pig? Now, I could tell you my story. It won't help you a whole lot because I don't expect anybody to follow the same path, and times have changed. Back when I was a kid, there were, I don't know if you're looking at the slides, I know I am. There were 3 possible jobs available to us. There was blacksmithing, lumberjacking, and dentistry, and nothing else to choose from. And then came this thing called computers. And computers were new, and they were exciting, and they were like, ooh, maybe there's something in this, like playing video games. Well, in fact, back then, computers were good for 2 things. One was going to the moon, the other one was for playing Pong. And so I chose Pong. I always had dreams of going to the moon, but sadly, the human race got bored with that. So, got myself an Atari. I got myself a Commodore 64. I started taking pieces apart. I started figuring out how games work behind the scenes. And it was just a case of let's see what happens. Now, one day the internet came along. This was a new and surprising thing, and suddenly everybody could start sharing knowledge, and you could get things, but it was still a little bit, what you find, you're not quite sure what's going on. You do a search because you've just learned what a search is. You have access to it here and there on a very slow connection. It wasn't the hive mind that we have today. But through the internet, I saw this, and I said, I think this internet thing is probably going to be big. So I started to teach myself HTML. HTML is a coding language that the entire web is based on, and you can look at any page and figure out how it comes together, well, the simple ones anyway, at start, through HTML. From there, I learned that things could be animated on the web, and I started getting interested in Flash. Flash at the time was Macromedia. It's now Adobe. It's now obsolete. But it was an animation language, moving pictures, moving image, whatever you want to call it. But it made it very easy to make little games. And again, you had to kind of figure it out. Worked in New York City for a while, doing developing for that. Then I took a huge trip around America where I did a blog before blog was a word. It was a travel journal back at the time. But learned how to code, learned how to do sort of CMS type stuff, coding this specifically and writing for it to tell stories. After the blog, I rode a tricycle around Australia. It has nothing to do with learning to play games, but I guess it made me an interesting person. I think that's part of the fun. Worked for the Department of Labor in New Zealand for a little while. Then I did health and safety training courses, the animation for those, which is like the most interesting part of a really boring field of study. Finally, I moved to Northern Ireland, where I was invited to be the art director on a kids' TV series, where it was called Lifeboat Luke. It was water safety. It was for 4 to 7-year-olds. But the thing that all of these things have in common is that I didn't really know how to do them before I started. I mean, I suppose that's the nature of anything. But knowing that you don't know how to do it, a lot of people use that as a barrier. It's a thing to stop you from getting started. And in fact, everybody starts at 0. So, if you think you know nothing about making games, that's okay. I was once that as well, and now I run a company. Off the back of doing this kids TV series, we tried to make another series, but actually that turned into a game. This is a game called Hector, Badge of Carnage. We're now 10 years ago. And from there, that gained the notoriety or the success, the interest of Telltale, which is was one of the biggest adventure game companies of its time. If you've ever seen Minecraft Story Mode on Netflix or played it, that was done by Telltale Games. And there were a number of things that came before that. Walking Dead, obviously one of the biggest. Right, so here we are at Italic Pig. That's how I got to games. I told you it wouldn't help. Now, I want to answer your questions of why should you get into games? Now, if you're asking why should I get into games, if you think it's because there's loads of money involved, I'm afraid the answer is no. Don't go into it for the money. There is money. Some people have it, not me, but it is possible, but it should not be the driving force that sends you there. It's art more than, it's a combination of art and business, but if you go in thinking that's where the money is, you'll spend many years searching for it, and it may be fruitless by the end. I don't want to put you off, but make sure you're going into the right reasons. Second, it's fun and easy just playing games all day. No, that's not another reason to go into games. Do not go into games because you think it's just play. As if you've ever seen a 2-hour animation, and then you've looked into the making of and found it took them 7 years to make this for your 2 hours of enjoyment and your 4 stars or whatever it is you're going to give it, that's the struggle. You are doing art and you are doing creativity and you are putting this out to people who have such a wealth of content out there that they'll look at yours and go, that's fine too, but that if you're doing it because it's fun all the time, it's a lot of work. Don't be scared though. Third, some guy at an event, like me, told me it's a worthwhile profession. That's also a no, because if I am the first person who said to you, you should be in games, I don't want to play your games. Because if you are meant to be in games, you have already said the phrase, I really love games to yourself. I want to be there. I want to do anything I can to get there. The excitement you have behind the creation of a game, the possibility of being involved in a game, that's the enthusiasm that's got to drive you through learning how to do it and being part of the industry. Anything else is you're passing through and you're possibly moving on to other things. But if you've said to yourself, I really love games, then come on in. If you haven't, and you think it's one of those other 3 reasons, well, don't worry. The world needs more dentists, and it needs more blacksmiths, and definitely more lumberjacks. So, how can I get into games? Now, easy. The answer is, make a game. You can say to yourself, but I don't know how to make a game. Well, then figure it out. Figure it out is the phrase that I want you to go home with. 3 words. If this is all you learned today, figure it out with you. Everybody has got one of these. If that picture is not clear or is not up there, it is a phone. Everyone has access to the internet. Everyone has Wi-Fi at home. If you don't have it at home, then you have it at Starbucks or we're at your school or at the public library or anything like that. And reminding you again that I am older than the internet, and yet I figured out how to do games on a Commodore 64, which has so many limitations and so many reasons not to make games on it. You have the internet, and the internet is free. And that means that access to the combined knowledge of the entire human race is free. So if you are on your phone and you are spending your entire time on your phone watching Ping Pong Trick Shots 4, or, cats falling off things, or whatever it is you happen to be doing, or starting an argument about how good a movie was, you could be using that time to figure out how to make a game, how to follow your passion. So, Google is free. YouTube is free. Tutorials are free. Stack Overflow. If you haven't heard of this, you haven't done enough coding yet. Stack Overflow is where coders help other coders. That's free. Every Game SDK. SDK stands for Standard Developers Kit. Also free. Maybe not all of them. I haven't checked out all of them. But the big ones, Unity and Unreal, that's the one that actual game developers use. So our company uses them. Everyone I know. Those are free. They want you to get started. They want you to download it. They want you to play with it. These other ones, Stencil, RPG Maker, Game Maker Studio 2, they're more accessible. They're closer to what you can just, reach out and grab and get started on. Unity and Unreal, they can be pretty daunting when you first open it up. But it's all free and it's all there and you can grab it and watch a tutorial. Just figure it out. Also coding clubs. Coding clubs like Raspberry Jam that meets once a month when there isn't a pandemic on. Those sorts of clubs are free and you can get together with other kids who are like you and have an interest and listen to talks by people like me and like Sam and everybody else in here. And just figure out that coding, you don't have to be scared of it. It's not this secret thing that happens inside a computer that's for somebody else to work on and provide you with that entertainment. You can be that person. Finally, and this, again, if you take this away, this is part of figuring it out, learning things without permission is free. And what I mean by that is I know so many people who have a barrier, who say, I'm not old enough to learn that yet, or we haven't been taught that at school yet, or I haven't come across that in my studies yet, or we do that club next month, we do. If you're interested in it, it's there. If you're interested in it, it is on the internet, it is a Google search, it is a YouTube tutorial, it's a Wikipedia page. Somebody out there has what you need to know already on display. So if you are interested in making games, then go learn something without permission and figure it out. Because if I can figure out how to do it on this, anybody can figure out how to do it on the internet. Thank you very much. I've been Kevin Beamers. I hope you enjoyed that. What happens now? Am I still on screen? What's happening?
So, welcome back. And that was Kevin Beamers with his talk on how to get into games. Now, Kevin has actually led quite a few different points around the Northern Ireland Raspberry Jam, and definitely different things in terms of his knowledge and kind of inquisitive kind of views on things, especially with stuff like Pi Wars, building robots out of Lego. He's got mountainous numbers of videos on that, and definitely have posted them into the Slack. It is quite a good kind of perspective because it's the idea of being able to find out this entire component comprises of these smaller parts, and it all goes together, works together to make one final thing. So we've got a couple of questions. We found some on the chat from the Hopin. Thank you very much. We're going to ask them now. But I'm just going to give a kind of an introduction, kind of an idea around, or a kind of an idea around what Kevin is doing. So with the games industry already booming and only getting bigger, there's only a huge and growing demand for local talent. So there hasn't been a better time to get started in the industry. Our first speaker was Kevin, and he does run the indie video game studio Italic Pig. And so for the past 8 years he's been doing that. He's been incredibly talented, talked in many different places and traveled around the world doing various things. Former chair to Games NI on steering communities in Belfast Media Festival and Digital Studies Belfast, creator of the creator of the Idea Jam and Run for the Border, a STEM ambassador, and does regular volunteering at events all around Northern Ireland. Despite all this, he has still managed to find time last year to write and produce a primary school Star Wars musical. Everything was obviously made by hand, all at home, all produced and planned. And he gladly will he'll tell you about it if you ask him. He loves it. And we did find a very good time going through what he made and the adventures he went through to get it all put together. But now we have a couple of questions for him, and we're going to go through them. So you've already explained who you are, Kevin. Mm-hmm. And out of interest, how did you get into it into the game studio? Obviously, you explained how Google is kind of your friend, or searching around the internet to learn how to do things is very, very productive. But how did you do it?
I sort of went through this twisty turny history during that presentation. The show, I traveled around here and I worked over there. I worked for the New Zealand Department of Labor, and I did rode a tricycle around Australia, and I also learned HTML. I worked in New York City during the .com boom. But all of these things came from, if I had to sum it up into how I got here, it was not being afraid to take a leap, not being afraid to say yes to things. The best career advice I tend to give to people is replace the phrase "I don't know" with "give me 15 minutes on Google." And what that shows is shows a humbleness. You're not lying and saying "I do know this." It shows that you are resourceful. It shows that you are motivated to find the answer instead of just push the job off onto someone else. And so for example, when I moved over to Northern Ireland, it was to come here to be the art director on a kids' TV series. Now, I had never worked in TV. I had never worked in, I haven't even worked in animation at the time, other than doing, say, web ads, banner ads, Flash, that kind of a thing. But, how different is animating here to animating there? Why not? I applied for the job, came over for the interview, seemed competent enough to handle it, and they took a punt on me. So there I was for the next year, working 52 episodes of 5-minute series. 5-minute episodes, 52-episode series. That was over the course of a year and a half. And then from there, that company said, well, we could turn this Hector game into a show, but why don't we try it as a game, like a throwback to the old Monkey Island Day of the Tentacle style. And so we took some of the episodes and some of the characters, and we went, yeah, this could work as a game, and we made it as a game. It's that why not? Let's try it. We've never done it before, but there's no reason why it should fail. Let's go into this assuming it's going to succeed. That's pretty much an easy philosophy. Like, why shouldn't it succeed? Is a good question to ask yourself.
Well, this is the thing. It's even from that, I don't know this much. This is actually quite insightful for me as well. But the opportunities which you can kind of gather and kind of salvage from different skills that you learn. So you didn't do TV, but then you did do TV from previous experience. It's always being able to build on something that you've already learned and done. So I'm guessing try things out, see how you get on. Yeah,
I assume that everybody's got a hidden talent, everybody's got a book in them, everybody's got a song in them. There's always something you want to get out. And you don't know what opportunity is going to lead to the next opportunity. And this is something that I would say in terms of even someone in the games industry who wants to grow their company or grow their their reach or their network is if you assume that everyone you're talking to now is going to have progressed in their career or their business or anything like that 3 years from now, there is no point in going to, say, a gaming event and saying, somebody please introduce me to all the CEOs.
Right.
Instead, meet all the interns and meet the enthusiasts.
See how they get on.
And make friends then, because today's interns are tomorrow's junior editors, and today's junior editors are tomorrow's editors, and editors are CEOs. And so it's not about climbing, but it's about treating everybody in a way that says, maybe one day in the future, we'll come back and work together because we hit it off at this thing. So it's saying yes to people, saying yes to opportunities, and don't let your lack of knowledge stop you from getting started.
I must admit, the experience with the internet and Googling stuff from a programming standpoint, it is very useful. Stack Overflow has helped so many projects, maybe even revived them. But there was a question from Mark, and he asked, is it best to join a big game company or a small games company, or would you say going down the path of creating your own game would be the best?
I think that really depends on how you're wired. Some people want to be given a list at the beginning of the day and complete that list by the end of the day. Some people want to be a cog in the machine, or just get lost in the shuffle. Give me my 8 hours and then go home and take it easy. Now, that's the world needs experts. The world needs programmers. The world needs, like I'm not saying, like a place like Rockstar. We'll have an entire floor of modelers and a second floor of animators and a third floor of coders. And they will, they'll grab all the graduates within a 500-mile radius and say, we'll take you all. And that's fine. That's you can say I worked in games. I did GTA 5, whatever you want. But if you are wired differently, you have your own ideas and you want to make them happen. Well, small companies, that's the place to do it. The indie scene. As far as I'm concerned, the innovators are in indie. Because when you get too big, when you get to the size of Rockstar or Bethesda or making these massive games, you can't gamble on things anymore.
That team is designated to do one thing.
If you're doing GTA 5, what are we doing next year? We're doing GTA 6. What are we doing next year? GTA 7. And it's because it's an easy billion. And if you're an indie, somebody chucks you 20,000 and that's like, woohoo, here we go. And then you start, that's when you make the game where it's gravity and time are reversed. And it's like, well, there's no genre for this. I know, it's the indie genre. And so we're going to play a game where I am grass. And I have to, I don't know, grow as high as I can before the lawnmower comes. I don't know. But the random weird stuff, if you ever go to a place like Gamescom, Expo, or even QCon, that sort of thing, but the really big stuff, sure, yeah, the giant battlefronts and all that stuff is great. But the indie floor is the place where you see the weird stuff, the inspiring stuff, where it's like, these are the guys that are going to invent the new genres and invent the new experiences. Instead of the ones that are just, let's do the same thing again, except in the Wild West. Let's do it again, but in space. Right?
Different kind of innovations and kind of branching off different kind of small little kind of bite-sized increments, and then bing.
Sorry, back to Mark. Yeah, the question being, I mean, you can cut your teeth as part of a big company. But if you've got a big idea, it will take a very long time before your place in the big company allows you to rise up the ranks when you can talk to somebody who actually has the ability to pull the trigger. I know plenty of people, I know a guy who worked for like 8 years on Total War and then quit the day it was launched and went and made a game about, people trying to survive a party. It was just because that grass is greener on the other side. There's always a reason why you might like being part of a huge thing, but also having something that is uniquely yours.
Thank you very much. So, a couple of questions on terms of what to do whenever you're trying to get started. Now, you explained how to get into it. So you've got the internet, obviously, it's kind of the connection there and be able to research is quite key. But equipment-wise, would you say computers obviously are quite useful, not the extent of like graphics tablets, be able to produce vector drawings and such, but what would you recommend as like a starting kind of base to maybe make games?
Well, I think the understanding, and the understanding is greatest now more than any, is how little it takes for a game to be a game. So for example, take mobile hyper-casual, right? Take anything made by Voodoo or Ketchup or anything like that. They're incredibly popular. They're insanely popular, and they're insanely simple. It's circles with some numbers on it, and things, when circles hit each other, they disappear. A game does not have to be The Witcher 3. Like if you go into the games industry going, my first game is going to be The Witcher 3, I'm sorry, that's not going to happen. But anybody with a little bit of work, it's like you can make a game out of Minecraft Redstone. Minecraft is your SDK. And if you figure out the tools that you have at your disposal, you make a game in it. You can make it in like those ones I mentioned, Game Maker Pro Studio was the other, Unity and Unreal. Stencil was one that I had over there. But yeah, these things are built so that you can pull the bricks over and pull the little cat from scratch over. It does not have to be spectacular for it to be fun. It can be squares and circles. That's totally fine. So make something with squares and circles, and if it's fun with squares and circles, anything over the top of that is a bonus. It's eye candy. It's gravy. You can do a square and circle game that eventually has space pirates in it, but it's
now.
still got to be the same level of fun.
Yeah.
It'd just be nicer to look at. So start small, think small, make a game in a day. Make a game with dice and paper before you even open a computer. You'll learn a lot more from a quick turnaround, like a game jam, like a one-day build, that kind of a thing, than you will dumping all your resources into 3 months or 6 months of learning how to use stuff you don't know how, and realizing afterward that it was fundamentally flawed from the beginning. So start small, stay small, and learn as you go. Grow as you go.
Perfect. Well, thank you very much, Kevin. That is unfortunately literally the time we have for the questions. A lot to consume, but hopefully you find that very insightful to learn and to kind of get the experience and understand, if you want to get started, what to do. So, Kevin, thanks again.
Thank you, Sam.
Now we're going to pass on to Jess. Jess is a story artist who loves dragons, mythology, and nature. Made a Games Grump animated one time. Nowadays spends her time art directing narrative games and the World of Warcraft YouTube channel. So, at this point, I'll pass on to Jess.
Hello, everyone. My name is Jess. I'm here to speak to you a little bit about what it's like to draw video games for a living, particularly in Northern Ireland. Just to give you a quick overview of what I'm going to cover, I'm first going to introduce myself and talk a little bit about where I came and what I've done. I'm going to give a very rough, very loose overview of the video game pipeline, and then I'm going to talk a little bit about where art fits into that pipeline. And then whatever time I have left, I'm just going to try and give whatever advice I can think of. Just to introduce myself, my name is Jess. I grew up in Newcastle in County Down, and I lived in Northern Ireland my whole life. I studied animation at Ulster University, and currently I'm the art director for Coffee Box Games and Better Gaming, and I've been in the games industry for 4 years now. My whole life I wanted to draw creatures and monsters for a living. I wanted to do it as a kid, and I wanted to do it when I grew up, and somehow I managed to get here. This is a drawing of my character Scrap from whenever I was 11, the first ever drawing of him. And this is one from a couple of months ago, so as you can tell, not a lot has changed, but I've just got a couple more tricks up my sleeve. My claim to fame is that I did a Game Grumps animated one time. I was a long time fan. I emailed to ask if I could do one, and they were like, yeah, sure, and then they gave me money to do it. It was the first time I'd ever experienced a lot of people seeing something that I'd made, and it was really interesting and scary, and obviously didn't go all that well all the time. My favourite game growing up was Ratchet & Clank, which, as I was making this presentation, I realised that it came out before most of the kids were born. Since then, there have been a couple more, so you've no excuse for not knowing what it is. A couple of years ago, I actually had the absolute delight of attending a workshop by the game designer of my favourite game. His name is Brian Algar, and I learned a lot, and he did these very lovely drawings for me. As I said before, I studied animation at Ulster University. I thought that I was never going to be able to do what I wanted in Northern Ireland. I thought I was going to have to go to America, and my plan was to study in England and then go to LA. But then the course lecturer managed to charm onto the course by telling me that he'd been to the birthday party of the director of my favourite movie at the time, which was How to Train Your Dragon. And obviously that worked, but more importantly, it proved to me that just because I lived in Northern Ireland, it didn't mean that resources were super limited or that I couldn't do what I wanted to do. In my third year of university, for my placement, I joined a studio called Coffee Box Games. At the time, it was very small, it was just a baby, and it had been just started by a YouTuber and a playwright. Our first game was Stanbury's Mistake. We made it for NI Screen. We never did finish it because it ended up the market had moved on at the time, and it didn't make sense for us to finish it. But I was a 2D animator, and it was a big learning experience. I even got to go to Amsterdam and Unite, where we got to go to panels and meet experts and mentors from the game engine that we were using at the time. And then I went back and graduated, and then I came back to Coffee Box Games afterwards. We got a new office, and we got started on our next project, which was How to Kill Monsters. This one was for UK Games Fund. It was a project that helped newly graduated teams make games. Again, it was side-scrolling, it was 2D, and we went to EGX and presented it to publishers and got to show it to the public, which was very scary because they're right there. It's a little bit different than comments on the internet, but it was a great experience, although we came home and realised that it was just too big a project for the team that we had at the time. So we focused a little bit for a while on the YouTube channels. We gave Get Better Gaming a makeover and made another channel so that we weren't just focused on World of Warcraft. We started a Patreon to make our own money so that we could become self-sufficient and self-publish. It meant that people could pay a certain amount a month for extra rewards, which we could do because we had a really good art team. And because we had a good art team, we decided that our next game project would be a narrative game where it was really focusing on story and what it would look like. At the time, Michael was really into 1900s expeditions and the golden ages of exploration. So we decided to do something based on the Shackleton expedition, which is where you play as a new captain who has to lead your team through the Antarctic, keep everyone alive and keep everyone happy at the same time. We've actually announced this one. There's a website and everything, and the audience knows about it, so we actually have to finish it. And we're going to do that by following the video game pipeline. There's 3 main stages to making a video game. It starts pre-production, then production, then post-production. Pre-production is all planning. It's where you do the first bits of concept art, you figure out your ideas, and you decide what you want to do. Production is making the thing. It's actually creating all of the art, all of the levels, all of the script, all of the code, and then post-production is fixing it and making it work and testing it and adding the final touches for it to actually go out into the public. And of course, artists are needed for every single step along the way. The first thing that gets, oh, I've skipped it. Sorry, I'm going back to, across the pipeline you have different kinds of artists, and some people are specialists and some people are generalists. In the AAA industry, a lot of people are specialists, where you'll have one person that does one job very, very well, and that works whenever you have really, really big teams. But in Northern Ireland, we're only indie, so we have very small teams, and everyone has to do lots of different things, which is what most people can do anyway. The first thing that gets done in any project is concept art, the goal of which is to oversee, sort of figure out and try and think of what the overall project is going to look like whenever it's finished. You have to think about tone and experience and what people are going to feel whenever they actually interact with the game when it's out. Storyboards is a little bit like a cross between animation and comics. The whole purpose of this is to take the script and the game design document and figure out what it might look like and break it down into steps for the rest of the team. Character design is very much what it says in the tin. Your purpose is to figure out the character's personality and what they do in the game and what their role in the story is, and figure out what that might look like visually. And environment design is exactly the same, but for environments. Although when it comes to games, obviously environments also go hand in hand with levels. And for both of these tasks, you'll be creating references for the rest of the team. Sometimes references are very detailed, and you have to do turnarounds and figure out what it looks like for every angle. This can either be used as reference just for drawing, or you can use it to create models, which we did in this case. We made a model of our ship so that we could turn it around in 3D space and draw it from different angles, because trying to figure out with your mind is very hard. If this were a final, if the game were 3D and final, we would unwrap this and color in the textures that way, but instead what we did was we made a grey box, which is just a scene with no textures on it to figure out where everything goes, and then we painted over it because it suited our style much better because it's a 2D game. My first job in games was an animator. For Stanbury's mistake, it was hand-drawn, so I had to hand-draw every single frame, and then you move them really fast and it makes it look like it's moving, which I love to do, but it's a lot of work. So for the next game we did rigged animation, which is pretty much the same in 2D and 3D. It's where you create your character and then you put bones into it, which you then can animate and move. Now I work as an art director, which means that basically it means that I tell the other artists what to do. But what I do is I have to figure out what this overall style of the game looks like, and I have to make sure that everyone else stays in that style. I talk to the director and I think about story, and some points that is, sometimes that means that I do drawings and I help artists figure out what everything is going to look like, and sometimes it means that I write lots of documents, which is another part of the job. Because Coffee Box is so small, I am also a producer, which means that I also make schedules, and I have to do lots of things that I don't like to do, which brings us to the first piece of advice, which is you don't always get to draw what you want to do. Getting to draw for a living is wonderful and it's amazing, but you don't always get to do what you want to do because that's just the nature of what it is whenever it's a job. There's a saying in video games that you're not a proper video game artist until you've drawn a crate, and sometimes someone has to draw the crate. Of course, because video games are so difficult and they're so intricate, there's lots of different kinds of people that are needed to work together to make it work. Communication skills, I personally believe, are more important than art skills. Your art is always going to improve no matter what, as long as you keep practicing, but communication skills sometimes take a little bit more nuance. In a good team, other people's strengths make up for your weaknesses, and the vision is shared by everyone. Sometimes it's dictated to you by a client, but very often you get to have your own flavor on your part. But sometimes you need to be able to take feedback, so you might be told that you might have to let go of ideas that you really like, and you might have to work really hard on ideas that you like less. My advice is to try and make friends with your team, because then whenever you don't like the work, at least your team can be your motivation. And sometimes they make memes, like this one about the fact that our main character looks a little bit like a character from a different video game. But yeah, just to finish off, I would like to say that when it comes to art, it isn't always, whenever it comes to art, doing it for a living means that sometimes you won't always enjoy it. And in order to cope with that, I would say that you need other interests. Whenever your art is a job, if you want to work in video games, that means you already have an interest above art. That includes video games. So that's a good start. But I would suggest to hold on to other things that give you joy, other hobbies that will keep you sanity and make you well-rounded, and other hobbies will also make your art improve. I personally really like reptiles, and that means that I study them, and I research them, and I care for them. And that means that I draw them really well whenever I do it for fun, and also means whenever I'm lucky enough to draw it for work, I can draw them pretty well then too. Am I good for time? I would just like to finish off by saying that Northern Ireland is a special place to live and it's a special place to work because everything is so small and close-knit. We don't have a lot of resources, but everything that we do is really experimental and new, and young people are the ones that are making the decisions and that are making the changes. And that means that the people that are here are special, and so are you. If you're an artist and you're passionate about something, that means that you have stories to tell and things to say. Your art belongs to you, and you're the one that makes it special. It's your individual personality, it's the things that you like, and it's the things that you enjoy, and that's what will make you shine. Yeah, the best art advice that I've ever received in my whole life is please exercise. Whenever you get older, to my age, your bones stop working and you don't feel as good anymore. You get stiff and sore, and whenever you draw, you're in the same position for a long time. So stretch, eat well, look after yourself, and then hopefully your career will last for a very long time. I'm very excited for you to get here, and thank you very much for your time. Yeah. This one? Oh, I'm going to take this with me.
So, welcome back. That was Jess just finishing off her talk, and the ideas and everything from it are very interesting in terms of what kind of experience she's had and what advice she gives. Now, obviously, kids, eat your greens. They're very good for you. Even at my age, it is, rickety bones, as my friends like to call it. But in general, just keep well and water. So now we're going to have a quick Q&A with Jess, if you'd like to come on over. And there's a microphone on the table whenever you're ready.
Hello, is
Hello?
it on? There we go.
Perfect. So, I'm just going to start off. Obviously, you mentioned about your experience with Ulster University and the fact that you studied in very different fields and your experience is kind of broad with what you've done. Mm-hmm. What kind of was the general thing, best piece of advice that you've got from that? Obviously, eat your greens, that's the main thing. But the sort of thing that you kind of learned and said, this actually is what, you would put everything. So, for example, mine might be breaking down problems into smaller chunks because Rome wasn't built in a day.
Yeah.
So, yeah.
For me, the thing that makes me a good designer, I think, is being very conscious of what the person that sees it or interacts with it is going to think. Mm-hmm. So I come from animation, but designing for animation is a little bit different from designing for games, because with games, people are going to be playing with it, they're going to be interacting with it. And as an art director, my main priority is ensuring that the art facilitates helping the player feel a certain way. Whenever you have gameplay, you want people to feel, it has to feel fun. They have to there's something called juice, which is basically just like enhancing effects and making everything really punchy, so it's good to do stuff and interact with. Okay. Whenever it comes to art, the goal is to make the player feel something and understand the gameplay and understand the story. So I guess it's thinking about who's going to see it would be my main piece.
Okay. And then out of interest, what's your favorite color to work with?
My favorite color?
To work with.
My favorite color is green or teal, like a blue-green.
You can imagine what teal is again.
It's a dark turquoise.
I know what turquoise is, actually. That was my favorite color. Okay. And then, obviously, with your software and your setup, you have a very portable idea to this. You don't have a station at home. You don't sit in an office, do everything there. You have a very kind of frolics from place to place. I do, yeah. Well, because whenever you are doing our assets specifically for the engine, you tend to have a big powerful computer and a station, but I work on an iPad because I do a lot of sketching, because most of my work is idea stuff, and I find an iPad really useful for that and working really fast. And also because things have to change a lot, and being able to adapt to that helps. Okay. I'm guessing Apple Pencil in the back?
What, sorry?
Do you have an Apple pencil?
Yeah.
I was going to say, because I was like,
Apple pencil.
So unfortunately, I have the first generation, but I was like, oh, is that AirPod? But yeah, a couple of viewers have thrown a few questions, so I'm going to bring them to you now. Do you have any recommendations on resources to help someone to learn to draw?
To learn to draw, there's lots of books and things out there. The really wonderful thing is the internet is out there. Because whenever I first started working for Coffeebox, I had very limited experience as an animator. So like for the first 2 weeks, I basically just like looked at GDC talks, which those are a little bit advanced sometimes if you're really young, like between 9 and 10. But if you're a wee bit older, they're really useful. And I looked at a lot of other animation and YouTube tutorials. In terms of actually learning to draw, there are lots of books out there. Schoolism is a course online, but obviously it's a little bit pricey. But if you're really interested and really invested, it's worth the money. Anything else? Honestly, just the internet's a really good resource. I think I heard Kevin earlier say something about being able to Google stuff. That's a superpower, I promise.
Googling is like the best resource engine ever.
Yeah, it is.
But then I'm guessing as for yourself as well, would you tend to draw characters, or would it be like environments and such? Or
I would be a character artist personally.
Okay. So
but
kind of the bodies.
Yeah, because of the Patreon, which focuses a lot on environment art, I've had to get good at environments.
But that's a progressive learning, I'm guessing.
Yeah, it's like another thing. There's like a couple of different skills that you need for like characters. It's like acting and anatomy, which I've done for a long time, so I understand. But whenever it comes to environments, something like composition and perspective is a lot more important.
Perfect. So another question is, do you work more digital or on like dead tree paper, or is it a bit of both mostly?
It can be a bit of both. Before I got my iPad, actually, I would have done a lot more traditional, but iPad has sort of replaced paper for me because it's so fast and so interactive. Whenever it comes to working on a computer, there's almost like a bit of a disconnect. Where it takes a wee bit longer for things to happen, and there's lag, and Photoshop is complicated, and there's lots of tools. But I personally use digital a lot more. But of course, paper is just as good. There's no reason why you can't do that. A lot of the drawings in the first version of The Pale Beyond, the game that we're working on, are actually they're just pencil drawings that we scanned in and used those.
And then I'm guessing with tracing, then would come in handy just to kind of say to develop on a current draft.
Yeah, of course.
Okay. And then obviously, I know for myself, I use like different notes and stuff for the iPad, but then you have a very kind of, well, I wouldn't even say niche, it'd be like a very kind of focused purpose for the pencil. Like, obviously the digital kind of upbringing of, well, not styluses, but pencils and such, and different tablets have really helped with that. Would you find digital quite different? Like, is it more useful, or would you say paper's very good to kind of get knuckled down with?
I think it depends on the person, because I know that I personally work a lot like how a traditional artist works. Like, I start with the pencil and I do the sketch and I do a lot. But I have a friend that draws with the lasso tool in Photoshop, and I know people that use a lot of the ways that digital advantages that digital has that traditional doesn't, which is stuff like filters and being able to change color really fast. Having an undo button is very nice. You don't have that in traditional.
I must admit, the amount of I know Sharpie is not a good thing to try and draw with, especially not on the wall. Granted, that was younger me, thankfully. But okay. Also, any tips on helping children be a bit more aware and a bit more creative, and potentially with their dreams, and exploring how to draw characters and such?
How to be a bit more creative, did you say?
Well, kind of exploring how to draw characters that they kind of imagine in their mind.
Okay, I guess, I would say just draw characters, but obviously that's very vague, so I mentioned in the talk that my favorite video game was Ratchet & Clank. I drew a lot of Ratchet & Clank characters when I was little, and what I would do is I would copy the characters from the game, but then I would also make my own version, which is basically just it's me, but I'm Ratchet. that sort of thing. But it's actually, honestly, I think that's a really good way to learn, because first of all, you're learning how to draw in another style, and then if you take that and try to make your own thing out of it, you're learning the process of, you have to be able to draw well to be able to draw your own characters in that style.
And the kind of the transformative aspect of that, you see something you like. I know Minecraft was mine because it's so simple. I say simple, but pixels, so simple.
Yeah, well, it's like the video game character Kirby was specifically designed to be easy to draw.
And 2 feet.
But honestly, fan art is a good way to do it because it's less intimidating than trying to come up with something from scratch. It's a good way to learn and build those muscles.
Just pulling like game covers and just, although not ruining the original one, obviously. The thing is, obviously, you have gone and traveled, and people are very different. Well, obviously, like cultures-wise, people are very different. Like, have people different approaches in different places, or is it kind of like the same thing everywhere? So if you were to walk into a company, it would kind of be the same kind of setup.
I think I'm really not sure. I don't have a lot of experience in AAA or anything. Like, I basically worked for Coffee Box my whole life, but I've worked for other animation studios. But I think everywhere is a little bit slightly different. But the principles are basically the same. So it's like we all have the same like A to B to C, but how you get there is a little bit different every time. And sometimes it gets changed. Whenever we were in York speaking to publishers for for Transfuser, one of the pieces of advice that we were given was that we kind of had an advantage being in Northern Ireland because we weren't surrounded by other teams that were all kind of sort of parroting the same ideas around each other. Even though we don't have as many veterans or mentors here, it means that we have to come up with new ideas. But it also means that we're not getting the same ideas as everyone else. Of course, the internet sort of homogenizes everything a bit, but...
accumulates everything, because obviously Pinterest and such, people have a lot of kind of fan art and such, and subreddits and different things like that. Okay. Out of interest, so you have obviously been working on your iPad, and everything's been kind of based at home. Have there been any other hobbies you've been at, during lockdown?
Oh God, yeah.
This is the side projects that started.
Yeah, I was planning to talk about it a wee bit, but obviously I'm gonna talk very long. But last year I got really into plants. Because my main hobby is that I look after reptiles. I've got a snake and I've got a leopard gecko, and it means that it's like a little tiny lizard. It's like this size, and I have a tiny snake that also is about this size. But because I always loved dragons and I loved reptiles and I wanted to look after them, so I did a lot of research and I keep them as pets. But then I got into plants as well, and again, the part I liked about that was researching. And then over lockdown, I was missing my friends a lot and missing being around the office, so I got really into baking and cooking because I was just thinking about coming back to dinner parties.
Just like presenting like a plethora of bakings.
Basically.
Okay.
Got really good at mac and cheese.
Oh, you know what, mac and cheese hits the spot. It's probably one of the best things. Although I can't really boil an egg, so not the best for me. But then plants and such, like obviously not everything that you do like hobbies-wise becomes a job. So like a hobby's not a jobby. It's like
yeah,
you
I
just,
would recommend not making a job out of all of your hobbies.
Yeah. Profitability is not the main thing, but you've obviously looked and researched. And plants, though, I'm guessing the kind of agriculture aspect, or is it like what part of plants?
Well, I keep houseplants, so it's just like I started with succulents, and succulents are very easy to look after. But what happens with them is that they grow little baby plants off. So then I had to learn how to take them off and propagate them and start new ones. But historically, I had tried to get into plants a couple times before that, but historically I was very bad at it. But then I actually took the time and read about it and learned how to look after them before I tried, and it worked.
Perfect. I'm guessing all through Google, though?
A little bit of Google, a little bit of YouTube as well.
A little bit of books as well? Dead on. Okay. Well, to be honest, that was a very informative talk, a very interesting kind of perspective on things, especially now, personally, I know I use the iPad and I find it very useful. But thank you very much for coming along. It's very appreciative of the time that you took out for this. And for now, what's going to happen is we're going to pass on to the next part of the event, which is going to be the break. So the break is going to carry on for a couple of minutes. Again, rehydrate yourself, get a wee bit to eat, a couple of biscuits, and we'll join you after that.
Hi, I'm British East astronaut Tim Peake. I'd like to say a big shout out to all of the teachers, volunteers and children taking part in code clubs up and down the UK and all over the world. The reason that people like me can fly into space is because people like you learned how to program computers and wrote the custom software that makes all of this possible. So please keep doing what you're doing, carry on with your projects, and maybe one day your code will be part of a space mission.
I'd say it's a bit like giving really precise instructions to a computer.
If you want a computer to do something, you need to give the computer instructions in a language it understands.
When you finish the instructions, if you do something, it will make it like move or light up or make a sound.
So coding is putting those instructions together.
It's something like learning a new language, that's it.
But on another level, it's so much more than that. You can be really creative and see your ideas come to life.
I think everybody should learn how to code because it's such a great opportunity to make things, to break things and make them again, and it's such a beautiful learning process.
So I don't really have a time before making. I remember as a kid, I would use all of the cardboard and all of the masking tape in the house that my parents had to create these elaborate forts for my G.I. Joes. But then I quote unquote, grew up and I became an adult. And the humdrum daily routine of working was, it's sad, but the making and creating, I lost that spark. And now it's coming back, it's full force. I've remodeled my whole house and I've built 2 kitchens and I've plumbed and yeah, I'm getting excited, I'm sorry.
How would I define maker? I would define maker as someone who creates. I feel like maker isn't limited to woodworking or electronics or welding.
It could be anything. Like everything is making. It's more an attitude than a job. Having agency over your life and over the things that surround you is very, very satisfying.
The maker community is amazing. It's a support system. It's a way to get questions answered and to share struggles and successes.
Overwhelmingly, it's just an encouraging group of people, whether you have 10 subscribers on YouTube or Instagram or 1 million, everybody's on the same level playing field, I believe.
I'm meeting all sorts of people from all different walks of making, and yet we all have this common goal of inspiring and educating and getting people to just make more.
So, welcome back. We hope you enjoyed that little break and got yourself kind of refreshed just for this next part, because very much loved Kevin. So we brought him back for another workshop on specifically crash course in games design. So I'll pass it over to Kevin. And if you have any questions during it, give us a shout, pop on Hopin, and we'll shout out to him during the chat.
How you doing? I'm Kevin Beamers, again. If you've been watching all day, you've seen me before, so I don't need an introduction. Right, game design crash course. This, in the description, it specifically says it's a pen and paper. And because we're only talking about, say, half an hour to 40 minutes, that's the length of the workshop we have here, we're not going to make an entire game. We're not going to get into how, I don't know, monetization works or the math behind balancing tower defense, if that's what you're after. I really just want everybody who's watching this to genuinely think about a game that they'd like to build, and I'm going to see if I can poke holes at it through the magic of streaming. I will let you know that I'm going to ask questions from time to time. I'll give you a little bit of lead time. I know you can only interact with me by typing. Please interact. I've got Sam, who you've seen all day. Sam is going to be the voice of the people. So if he's spotting things on the list that I need to hear about, some of your ideas, I'd love to hear stuff coming my way, because it's no fun doing a workshop when you're just one guy in a big studio. I need to know people are out there. All right, so first of all, if anybody's participating in this, I would suggest you get yourself a big sheet of paper, get a pad of paper. I love these giant things. This is my, all of my meeting notes look like this. They don't make any sense, a week after, sometimes an hour after the day, but it helps to visualize. It's so much better than a computer, or like if you're typing ideas in, everything's got to be in lines and formal and stuff like this. Something, when you're working on paper, it just means you can have lines all over the place. It's as big as small as you want. You can draw arrows connecting things and rip it apart. It doesn't matter. It's disposable. Right, diving in. Game design crash course. First, if you were to ask a lot of developers, most developers, in the question, how did you get into games? Quite honestly, the answer usually boils down to, there was a game I wanted to make, nobody made it yet, I got tired of waiting, and so I made it myself. So that's the creative side. Some people just want to be animators. Some people just want to be programmers. Like I said, waiting for the task to show up on their desk so they can be a piece of a larger puzzle. But if you're the one who's engineering the puzzle, this is your story. It's I got tired of waiting for someone else to make the game I've always wanted. So I've just figured it out for myself. So if you're at this workshop, I hope you've got one. Now, to start off, I'm going to give everybody a couple of minutes of silence. Just create 5 game ideas, okay? And as you create them, I don't mind if you write them down on your own sheet, type them directly into the, Hopin? And Sam's going to read some out to me. But I'm thinking just create the idea any way you think it has a form. I'm aware of the fact it's going to be a little bit nebulous. It's going to be sort of a bit like this and a bit like that, but whatever you think is going to inspire you to start making a game, write those ideas down. Okay? So, 2 minutes of silence. I'll get Sam to catch me, but I'll start writing my own stuff. Let's see. Okay. Is that 2 minutes? We getting close? No? About a minute left? All right, that's probably plenty. As you can see, my notes have taken on, they don't make any sense at all. I haven't made a list. I've started drawing pictures. I started drawing arrows. Started thinking about a game I'm already had in the back of my head. Anyway, Sam, I don't know if anything's come through. Just throw them out.
So Anna just posted an idea. A story game about an astronaut in space in future, where you travel to each planet, which would be considered a level, to save each planet. The last and hardest apple will have a name that will be planned across all the other planets and the same. The planets from the sky.
Okay, so you're an astronaut. It is in the future. There's someone on each planet. And, right, saving each planet as you go. So we're at 8 levels, unless we include Pluto as a bonus level. That always makes everybody a little bit sad, doesn't it, when they mention Pluto? Okay, right, any other things have come through?
personally I have one.
Okay, go on.
So you're a frog.
Frog.
You go from lily pad to lily pad. There are like 3 columns, and you have to get a certain score by the end of it. So you're trying to get a certain score, so you score the top, and you like try and increment.
Okay, so it's like frog. The lily pads have value, and you're trying to hit a target as opposed to get as far as you want. Right. Okay. So it's I'm going to call that lily pad maths, but it's probably more interesting than that. But okay. Has anything else popped through?
Someone's recommended The Light Beyond the Sky is about a girl who discovers she is a kid girl, and the next 3 comments come out.
Sorry, say again.
The Light Beyond the Sky is about a girl who discovers she is a kid girl. Just gonna wait.
Okay. So the light beyond the sky. So three have come in from the audience.
She joins a group of kitten heroes on a castle above the clouds.
Okay. Kitten heroes. Clouds. Above the clouds. Right. Okay. So this is a few that have just come through. We got an astronaut, we got a frog. The one that I was looking over here was one we've put. I've thought a little bit at the studio. It's where you're it's a memory locked inside a brain, and it has to make it out of the brain in order to be remembered. Okay, so so these I've asked a few questions of myself here. I've drawn a few pictures. I've drawn some boxes on a grid. Now, with each of these things, the astronaut saving each planet, the frog with the lily pads, light beyond the sky, and the kitten heroes. Right. What I want to get a little deeper into this, because all I did was say, "Hey, game idea, go." Right. So the things we got to consider right from the very beginning. One of them is going to be platform. A platform sounds a bit technical to be jumping straight into, because some games work across the board, but some games are very specific to the tool, the device that you're playing them on. So platform, what I'm talking about with platform, we've got a console. Right, so this is your Xbox, PS4, Switch. Anybody else got any answers to platform? I'm going to give you another one. I'm going to say immersive, while you guys come up with the other ones. Immersive, we're talking VR. You can play a game in that, and obviously a game that you play in VR is going to be completely different from a game that you play on a console. Third, yeah, what's that? Augmented reality. I'm going to pop that in immersive as well. Mobile, perfect. Great stuff coming in from there. There's one that's missing. It's usually hand in hand with console, but keyboard and mouse, Steam, PC. Now, these 4 here they're your big 4. I'm sure there's others I missed. There's other ways. Tabletop. 2 people sitting across the table from each other without any tools whatsoever. There's loads of different ways to play games. The definition of a game is so wide. But right now, assuming we're talking about digital, assuming we're talking about video game design that involves coding, we're talking about, is this going to be played with keys and mouse? Is it going to be played with a controller? Is it going to be played with your eyes? Is it going to be played with how you move your head or how you move your body? Obviously, Kitten Heroes in the Clouds, playing that on Steam versus playing that in VR, if you think about that from the very beginning, it's a totally different experience. Are you surrounded by cats? Are you in the clouds? As opposed to watching the cats do other things on the screen. Platform, right. Second thing I want you to, what have I got there? Console, PC, mobile, immersive, tabletop, excellent. So along with platform come answers like how do the controls work? What is your audience? And I put price on the slide as well. And price, I'm really sort of talking about free-to-play mobile versus a 30-pound game on Switch or something like that. The expectations of what's inside your game. It used to be that you paid for all games. And now there's free stuff, and there's the way the Fortnite model works. It's completely different from there's a whole range of how you can get money from your product. But the only way it works is if you build that in from the very beginning. A game you play on mobile is a completely different experience than a game you play on Steam or in VR. So think about how the platform, the limitations of the platform and the advantages of the platform can turn your game into something you hadn't expected before. or flip your game on its head. I never thought of it in VR before, but run down that path for a while. Next, genre. Now, genre is it's I guess a categorization, a grouping of what your game comes from. I've got these beautiful things here. I one time participated in a BAFTA Young Game Designers Awards. Every year they do a Young Game Designers Award, and this wonderful set of cards here is just a bunch of idea inspirers. So, for example, racing, educational, simulation. Oh, that's blank. I guess that's up to you. Role-playing, action, arcade, one-touch. There you go. Might as well throw them all out here. Strategy, puzzle, adventure. This is not by any means all of them. You can search by anything in in Steam, and find stuff that's been pigeonholed or stuff that doesn't fit into anything at all. The first game that I made as Italic Pig, Schrodinger's Cat and the Raiders of the Lost Quark, it had platforming, it had puzzle solving, it was somewhat procedurally generated, so the levels were different every time you played it, and it had dialogue and narrative and characters. So it didn't really fit into anything, and I mean that could work for you and against you, because the for you is that somebody goes, that's something I've never seen before, and the against is, I'm looking for a platformer. This isn't really that. I'm looking for a narrative adventure. It's not really that either. So there's elements, when you try to do two things, people tend to like one, and they might like the other. They might be drawn in. So it's anybody's guess. So with all of these, again, working off the astronaut, saving each planet. Now, that firsthand makes me think it's definitely adventure. Might be puzzle, might be strategy. I'm not sure exactly how the gameplay is going to work. Or, for example, if it was a mobile, it might be one touch. It might be a Jetpack Joyride style game where you're just avoiding things or getting out of the way. Strategy tends to be slower paced. You spend a lot more time getting into the designer's mind, trying to figure out what they want you to do in this game. Well, I don't know. It could even be, dare I say it, educational. Educational is always a tricky market to go running down because kids are like, is this educational? Please. I'd rather do something else. So lily pad maths might fit into that please section. But again, Frog Fractions was one of the most fun games I've ever played. All right, that's genre. Genre, there's a whole bunch I've listed there. What's not here? Hyper-casual, sim, first-person shooter. Real-time strategy, yeah, honestly, go on Steam and look at the games that inspired you. Chances are you have a list of games that you pull from and you're like, I want another one of those. And if you were going to make one, it might just be down that same realm. Genre also helps you define things like story and characters, and game style and pace. So something like, if you were to put a narrative on top of it, you don't necessarily get a narrative in a hyper-casual game, doesn't mean it's not fun. Playing Legend of Zelda versus playing Tetris, they're completely different types of game. And it is all about what sort of pace and what kind of drive and what kind of style of game you want to be putting forward this. But try a few. Like I said, like I was saying about the kittens and the platforms, a different genre just might be the shake-up that you hadn't thought of before. If you think it comes into your head fully formed, it never does. You branch out and you pull back in. Third is I want you to think about progression. By the way, I'm going to ask you to apply all of these things to some of the ideas you wrote down earlier. So if you've got your list of five ideas in 2 minutes is pretty tight. But if you look at any one of those, you say, that's probably the one. Start, even right now, start thinking about genres, start thinking about platform, and progression is a third thing. Progression is kind of like the goal, it's kind of like the gameplay. Let me see. How do I get better? How do I know I'm getting better? And what keeps me coming back? So progression could be, you got it's morning, the clock has just run out and you got more stuff to do. It might be that you just find it satisfying or you're trying to get better than everybody you're working against. I've got down here a bunch of things like, is it skills and levels? Is it earnings that keep you back? Am I the richest person in town? Do I need more energy? Do I need more gems? Is it competition against other people that keeps me coming back? I mean, you look at a game like Candy Crush. It's a single-player strategy game that has this competition element dropped on top of it, and that's a second driver. It's where are my friends compared to me? I got to do 3 more levels before Tuesday so I can elbow them at the office, right? Right, so where was I? Progression? I have lost one set of my cards. Nope, there they are. Right, so as we get into brainstorming, picking a few or one of your games from earlier, start writing down stuff about platform, genre, and progression. And while you're doing that, so we're not just sitting here in 2 minutes of silence, I'm going to drop some of these lovely BAFTA Game Designer cards on the sheet here to inspire you on things you might do in terms of a progression. So for example, the goal might be to remove all your enemies. Kill everybody on the level, or remove them all, get rid of the virus, lose the bacteria. In the astronaut game, saving the planet, are there minions that you gotta get rid of? Are there rocks in the way? I don't know. Lily pad maths. Do you have to hit everything? No, you have to be strategic about the ones that you jump on. Do you mark them in such a way? Do you have to do mental maths as you're doing Twitch play? I don't know. Here's a few more. Let me throw down, we got escape. I don't know what you're escaping from. Might feed into that. Complete the puzzle. Find all the items. Use all the items. These are good. Okay, so destroy objects, survive, capture, reach a destination, and rescue. And again, this is by no means the list. This is not a be-all, end-all. What you should be doing is puzzling through this and go, how can I thought I was going to go down one path. I thought I had one goal in mind, but I hadn't considered, is it survive as long as I can, or survive until I get to the finish line, or is it survive until I've collected all the items? These elements of gameplay, you should, at the beginning, I mean, we've only been doing this for, what, 15 minutes at most? I don't know how long I've been talking. I have no clock up here. But the fact is, the brainstorming period, the development period, that is the most fun part of the game development time. It's before you think of a budget, and it's before you gotta nail down the number of people you need. It's all blue sky thinking. It's all the parts of the game where you say, this could be anything. Let's not limit ourselves. The word brainstorm, the thing about brainstorming is that when you're in a brainstorming session, the goal is there's no such thing as a bad idea. You write down everything. If you start debating the merit of one idea during a brainstorming session, this is evaluation. It's a completely different thing. Brainstorm should be just keep writing things down on paper. And I guarantee you that if you write down 20, the thing you're going to go with is not going to be number 1. It's going to be somewhere around 9, 10, 11. But try everything, keep adapting. Yes. Let's hear a few. What do we got from you, Sam?
So it was mentioned that someone's game would be to survive and rescue.
Yes.
And then another one said to survive and actually like save, restore, something like that. Like conserve currency maybe?
Okay. So that's sort of a, sorry, you've got, I shouldn't put those away. So somebody's mentioned survive and rescue. That's rescues, there we are. Survive and rescue. Is this related to one of the 3 games we've got already? Or is this another one? Because saying, I'm doing a survive game, it's a good place to start. It's a good mechanic. If you caught my interview with Sam earlier, it's talking about building a game with squares and circles. Now, we can have a game where we survive in space, and we can have a game where we rescue in space. But we can also have a game where we survive in the Wild West, and we can survive underwater, and we can survive, in a nuclear bunker. And so the environment shapes what survival is open to us. And survival, I mean, Doodle Jump is a survival game. How high can you jump before you run out of platforms? How long can Tetris is a survival game. So it doesn't have to be people surviving, it can just be you. It can be you living as long as you can and then try to beat that record. That's a completely different style of game than something where you're trying to solve a puzzle to get to the next level.
That was Light Beyond the Sky. That one.
Oh, right.
There's also a recommendation of like an idea of surviving rescue and like a reaching final destination, and that would be the astronaut game. So you jump from planet to planet, and then your destination would be the final one.
Okay, just a question for whoever presented the astronaut game. Do we have a name? I'm going to call you Astronaut. Okay, dear Astronaut, can you perhaps elaborate on whether or not this is a fast-paced game or a strategy game? Is it, do you picture it being something on mobile that is play forever, short loops, play forever, or do you see it as a limited experience, a paid game where you're solving, say, over the course of 8 worlds, like a Mario? I'm sort of talking to myself here because I know that there's a bit of a delay on how long it takes for things to come in. But yeah, even if you ask yourself those questions of how does my astronaut game, what platform would I see it on, how long would I play it for, how long is a level? You know, I would have to assume that a planet is a world. Within that world, you'd have a number of levels on the inside, or perhaps it's survive as long as you can until you gain the resources to get to the center. Have we got something?
So, Astronaut said it would be a strategy type game, and she pictures it on being mobile, and it would be a 3-life system, kind of similar to Mario.
Okay. 3-life system is interesting. I'm going to go off on a tangent here for a second. I remember when Tomb Raider came out. What are we at? 25th anniversary at least now? It's very possible. When Tomb Raider first came out, you played that and it was like you had your guns, and then a wolf would come out the side of the pyramid at you or whatever, and you would die and you get chucked all the way back to the beginning. And it was built in the style of the old arcade games. An arcade gave you 3 lives because you were paying by the game. So you put in your quarter and you get 3 lives, and if you were dead, you had to put in another quarter. You had to continue. Mobile eliminated the idea, well, a lot of games eliminated the idea of the 3-life system, because once you bought a console, the idea of dying in a long, people wanted you to finish the game. So they gave you loads of lives, or they gave you infinite lives, or they gave you a checkpoint, and that sort of thing. They eliminated that idea of your game is over, because game over is a break in your day to go, I guess I'll go do something else, or yeah, one more. So having infinite lives makes for a totally different experience. And this is where I'm going back to the Tomb Raider example, is when they re-released the 20-year anniversary of Tomb Raider, they actually had to change the game format slightly because the audience, the way people played games, had evolved from 20 years ago to now. So that idea of I'm dead, you gotta start again, forget this, had to be turned into something more of a checkpoint system. They had to adapt it ever so slightly in order to work for today's audience. So it's a total side story, but it just shows you that a game that was made 20, 25 years ago versus games that are made now have completely different methods of how they keep you hooked. Right, time for a twist. I don't even know what the twist is because I made this PowerPoint last night. The development. Okay, development is not just making the game. No game is ever a case of I write my game design document and then I give it to people, and then 12 months later it comes back to me exactly the way it lived in that game design document. Nothing comes out of your head and onto paper fully formed. Development is growth and change, okay? The only way something is the same at the beginning as it is at the end is if you are an army of one. If you're a teammate, if you don't have a team, if you can do everything yourself and you grow and evolve as part of the project, then everything comes out of your head and into the game. But if you're working with a team, the team has input, the budget has constraints, the size of the game you're trying to make will always be different from what you thought it was going to be at the start. So I've met, there's a writer that I know, a games writer, who one time had a story where they knew that they were going to have, say, 5 acts, but then they ran out of budget, and they had to pull the entire 4th act out of the game. And they had a voice actor who had done all their work and was super expensive, and they couldn't get that person back. So the writer had to cobble together something that would work with the lines that existed and still tie the story together. And they had cut about 6 scenes out of it, and it was meant to be this big development between the main guy and his daughter and all that stuff. But it turned out that they were able to do in one scene what they thought needed 6 scenes before. And the final product ended up being better than any of them anticipated. So on the day somebody comes in and says, sorry, we can't get Vin Diesel for this script, we've got Adam Sandler instead, the writer or the developer or the designer would just, throw your hands up, chuck everything we've done out the window, this is going to be a failure. And then after a good night's sleep and punching a few holes in the walls, you get up and you go, actually, no, this might be a good thing. Every game twists, every game changes during the course of development. So I like the question, but what if it isn't? That's my favorite thing to ask during a brainstorming session, is what if we take what you think we're going to do and we flip it over, we turn it on its head. So everybody out there who's been writing some stuff down, I'm going to throw another set of cards out on the table here, and they're just, I want you to pick one at random. In fact, hold on a second. 2, 3, 4, 5, 6, 7, 8, 9. I got 10, maybe 11. I didn't really count that. There we go, 11. Pick a number between 1 and 11. And I'm going to start laying these out. And let's assume that you have to apply one of these to the game that you've been working on. All right? So, what do we got here? Adapt. Number 1, you've only got 1 life. You die, start over from the beginning. That eliminates the entire story I told earlier, but why not? A lot of games work that way. Permadeath. Here's number 2. You can only move forwards. Mario works like that. Yeah, it cuts off the back, doesn't it? All right. You can only select connecting items. I don't even know what that means, but if it applies to your game and you chose 3, good luck with it. Bounce off walls is number 4. Avoid enemies, number 5. Limited inventory. I don't know how that applies to a frog, but okay. Can't touch the floor. Limited time, that's number 8. Must not be seen is number 9. And 10 is can't do the same thing twice in a row. Again, if all games were the same, and we could apply all, I didn't do 11, by the way, because there's nothing on it, so that's anybody's choice. But if you've been making a game that's taken you down one path, something like this, a twist where, right now I'm obviously not talking about, we're talking about design. If I was talking about, I'm sorry, you gotta lose a chunk of your game, or we're not able to do this particular mechanic, or guess what, there's a Switch 2 coming out. And the Switch 2 is like the Wii. You wave it around and there's only 1 button on it. So we got to adapt to that. So these are the sorts of things where, especially in a game that you've been making over the course of 7 years, a big studio game has to start thinking ahead. Can we build this for the PS6? Because that's how long it's going to take to get this thing out. Now, everybody here, I'm assuming again, we're here with the NI Raspberry Jam audience, which is in the under 20 category, sort of the learning to code, figuring all this stuff out. This should be sort of dream space. Imagine yourself just taking something you've done and say, but what if it isn't? Pick one of your games from earlier and turn it on its head. And so, I don't know if that slide is up on the screen there now, but how to turn something on its head. Think of a new genre. Think of a new platform, change the controls, the mechanic, the art style, change the environment. It's the same thing, but in space. Or it's the same thing, what merits come with it? We have anti-gravity now, or the astronaut planet game. Is it a platformer where we are just running sideways the same way we would in Mario, or is it what if it's a round platformer? Suddenly we're on a tiny planet, we're jumping around asteroids that aren't much bigger than us, so we have to learn how to jump in an arc. That might make for a completely new mechanic that you may not have seen on a game before. Anything that you have created so far, as I said, we began this talk, and you probably had something in your head that you wanted to build. Just make sure that there is room in the thing that you wanted to build for adaptation and for somebody to batter it around, for changes to happen to the technology, and for things to happen with, let's say, hey, your team might change, the hardware might change, how games are paid, how games are acquired. Any of those things might happen, and if you can't adapt, it's going to be more difficult to get something out the door. Okay, where are we? Let's hear a few. I've just heard that I don't have that much time left. So if you've got something, Sam, that you wanted to bring my way, we can do it. Otherwise, I can move on to a bit of conclusion. What do you think?
Well, people talk about how you can sneak around and not be noticed or seen by an enemy.
Yep.
Strategy or the stealth kind of games or something. Reminds me of different kinds of games. Among Us was one.
Among Us is fantastic. Among Us isn't hard to make. The graphics, the images, they're not, again, they're not Witcher 3, they're nothing, they're adorable in what they are, and the social aspect is brilliant. So it shows you that, one killer in a room full of FTL sort of fix the shit type stuff, that's a fantastic, simple game that doesn't take much, well, shouldn't take much to build, but gives a whole lot of people a lot of joy. So again, yeah, Astronaut might be stealth, Astronaut might be strategy, Astronaut might be avoid all the things being flung at you at once. All right, I gotta sum this up fairly quickly. I hope I've given you some stuff to think about along the way. But I am gonna leave you, because there isn't really a whole lot of interaction going on, with the idea, not interaction going on. There is interaction, but in a room full of people, I would usually end a talk like this, getting people to stand up and pitching their ideas. Because one of the most important things about idea creation, about making a game, the only way you're ever going to make it is if you talk to people about it and they think that's a good idea. And the only way they're going to think that's a good idea is if you've got something solid to pitch and you can talk about it in a concise, interesting way. If you come in and say, well, there's a bit of this and there's a bit of that and there's a thing and it's a little bit like and blah, 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 but you don't have any kind of a story that you're telling, then the pitch is going to fall flat. You may be sitting on the bus next to the head of Sony and talking casually about your game, and they go, yeah, why not? Here, have 100,000. Go make that thing. And it's an opportunity because you were able to pitch with some sort of clarity. Hustling through. Is your title catchy? That's first thing. Second, concept. Can you explain it in one sentence? If you can't, it might be too complicated. Okay? I know there's loads of details. I know there's lots of energy and ideas that have been put into this thing, but it's got to come down into one sentence. If your title's good, somebody will say, tell me more. You explain it in a sentence. If that's good, they'll say, tell me more. Inspiration, what is it like? My favorite inspiration sentence, do not be afraid to compare your game to other games. So, A plus B with a twist of C. So, is your game, for example, Call of Duty meets Pac-Man with a twist of Candy Crush? Now, I don't know what that game is like, but I've said 3 very popular games that a lot of people really enjoy, and that would make me say, tell me more. Find out if it's true. Okay? Think about your game. What would you compare it to? It's, like Among Us meets, right? If that's part of your game, just pick the things that are going to rope people in. The opposite side of this, the hook. Inspiration and hook. Imagine those being 2 sides of the same coin. What makes it unique? And this is you saying, it's like a game you've seen before, but here's what makes mine different. And the other reason is, again, to compare your game to other things, you got to say, look, it's like Lemmings, or it's like Candy Crush, and that eliminates the 95% of the things that are similar. You don't have to get into, well, you do a match 3 and you push the things together and there's levels, and that's covered by the words Candy Crush, but you spend the rest of the time talking about what makes yours different. So, pitch. My game is called, here's the one-sentence concept. It's a genre game for platform where you do this and that as part of the progression. It's a bit like Inspiration, but it's got a hook. If you can put a pitch together like that, that's one paragraph, and that's you talking about your game in a clear way. And if you're up against the right person, they'll listen, they'll say, cool, tell me more. More is a word that you want to hear out of the person you're pitching to, because you've now got them involved. And that's the same for players. Players want to play more. I've played level 1, give me more. I've run out of content, give me more content. If people are saying, give me more, then your game has legs. I think that is a good place to wrap this up, because I think we're right at the end of the day. So I want to thank everybody here, NIDC, Raspberry Jam, for inviting me out to talk to you about all this stuff, and I hope some of this has inspired you to get into the games industry. So, thank you very much. I've been Kevin Beamers.
Yes, thank you, Kevin. Of course, the indie game scene here has been exploding recently, with the likes of Hypixel Studios having been acquired by League of Legends creator Riot Games earlier this year. Italic Pig, Kevin's from Brain and Nerd, recently receiving Creative Europe funding for their upcoming projects, and dozens of other local companies such as Whitepot Studios, Level 91 Entertainment, Starpoint Studios, Billy Goat Coffee Box, and Out of Tune, all working on everything from short mobile games to blockbuster PC titles. Thank you to Kevin and Jess for coming out here today and giving us an insight into the games industry here. And of course, thank you to all of our speakers, everyone here at the NIDC team, all our crew, volunteers, the studio that we're in. I don't think I can say the name. But thank you, and especially to all of you for watching at home today. I'm going to hand off now to Art and May from the NIDC team, who are going to take over for today. And for all of the Jam folks, thank you for coming.
That was a fantastic afternoon, wasn't it, Art? So track 2 continues on with a couple more talks, but that's us at Raspberry Jam for the time. And huge thanks to Kaylin and Sam who've been running behind the scenes, making sure everything's organised. Huge thanks as well to all of the speakers, the workshoppers, and of course to everyone who got involved too. So it's been really good seeing all the conversation and the chat around social media on it as well. So brilliant, thank you. And you know, at the end of the day, that's what we want to see. We want to try and get more kids involved in STEAM and just get that enthusiasm started early and continue it on. So hopefully you got your technical difficulties. It's not your day for sound, is it, Art?
Well, we'll figure it out.
No worries. Would you like to say anything else about the Raspberry Jam?
I know some of you, hopefully everybody really enjoyed the jam. Hopefully everybody really enjoyed the jam. And because it has taken us maybe 3 to 4 months to organize with quite a few groups trying to figure out what we could try to make it good for you and the kids at home. So big thank you to the Jam team that's been working in the background for this. And hopefully we'll see them again very soon.
So, because we had quite a lot of people asking about the technicalities of running an online conference, especially one where there's a live element to the studio, and of the challenges that we experience, we decided to try and pull in David Kane, who's been behind the scenes. He's been working hard to get everything running, and he and his team have done a stellar job of just pulling everything together, getting all the video shots, getting the live production set up, and this should be you know, it's made the weekend as it is, and it'll just be a case of, we've got loads of questions in around the technical aspects of it, but also just around the difficulties as well, the challenges of putting on such a production. And hopefully, if David's ready to step on, we'll do a very quick 5 to 10 interview, 5 to 10 minute interview. Get to see a bit of behind the scenes. Here. So you might need to take the mask off for this one. So we've got loads of questions come in from Slido. And are you ready for them?
Yeah, this is. I enjoy the fact that you've decided to try and interview me at short notice as we're closing the entire thing.
I think we know who to blame for that.
So I have people behind the scenes here doing their best octopus impression on the desk and the cameras. So we'll see how that goes.
They are working very hard. So, first question. Any thoughts on integrating the broadcast into the in-person event when it's back?
Yeah, I mean, definitely. I think it's one of those things where obviously we all would prefer to be, in Riddle Hall again. Mm-hmm. And I think there are some positives to doing an online broadcast. But, I mean, there's certain things, we've all covered it, there's certain things at an in-person event that you can only do at an in-person event. But by the same token, you can bring some of those benefits of doing an online event into the in-person event. And I think one of the key ones, certainly for me personally, is having recordings after the fact, particularly whenever somebody's doing a code walkthrough or a live demo, because at the time things click. Now, maybe people out there have much better memories than I do. Mm-hmm. But certainly I find that at the time things click, and then you're sort of going to try and replicate it later, and you're thinking, I'm just missing that one critical step. The other thing that I think is good whenever you're doing an online event is that you get that focus on a more. You can have a wider audience. You can have an audience that is from outside of Belfast, outside of Northern Ireland, and they can bring something additional into the whole experience. And I think sort of focusing on your question of how might we do that in combination, I think it really is as simple as just getting 1 or 2 cameras in each room and somebody mixing them. Is what I'm thinking on that.
Do you think that'll be a bigger challenge than doing a fully live production, or?
Yeah, I mean, yeah, it's possible. I think in some ways it's probably less of a challenge because it's a different animal. It's not really. It's not the main thing that most of the audience is watching, although, in COVID-19 times, mm-hmm. It could well still be. I don't know how the audience numbers will look for an in-person event this time, next year. But I think that it probably presents fewer technical challenges because your venue is already set up for a live audience. And people know this, so there doesn't have to be that conceit to getting things as well lit and as well sort of done in that respect.
Okay. This one's definitely for you. What is the setup like to actually stream this? How do you get the feeds going in?
So how much of a technical answer do you want?
It depends on the person answering, and well, they haven't given their name.
Okay. I'll give the sort of the overview of the technology, which is by no means perfect, and definitely any mistakes are mine and mine alone. But what we are doing is we have track 1 and we have track 2, and track 1 is going out through a mixing desk into a piece of hardware built by a company called technologists, and it does it compresses the stream and transmits it via a variety of protocols, and we were originally planning on hitting Hopin, the conference platform that some of you are watching on, most of you are watching on. We were originally planning on hitting it with RTMP directly, but we decided instead to use technologists' own service, So we are streaming this to their cloud service, and their cloud service is then doing the fan out to the second Hopin for the Raspberry Jam track, and the Twitter and YouTube streams. Track 2 was a bit of a weird one because originally track 2 was meant to be, and you know this as well, you've done a lot of the behind the scenes work on Hopin. Track 2 was originally meant to be done via YouTube videos because Hopin had a very useful feature where you could queue up some YouTube videos and use their CDN, and it would all be nice and easy. And then play them into the sessions. And I don't know quite what went wrong there. I think Hopin is a company that is growing, and they just discovered that they maybe had some teething problems, but they took that feature out about a week before we were due to go live. So track 2 is currently going out from a 5-year-old MacBook Pro running OBS. So if there are any dropped frames, I really do apologize. And it's hitting the Hopin. It's going out as a webcam into Hopin, which is not what I would have preferred, but hopefully it's worked well enough. So.
Well, I've had a couple of really useful hints and tips as well from.
Yeah, I mean, this is the other thing. You know, obviously, whenever you're doing something like a developer conference, the problem is that the audience also knows what they're talking about.
Exactly. So that's been fantastic. And biggest single technical surprise?
Biggest single technical surprise. So I wanted to talk about one success and one failure, because I mean there have been problems on this production, and you know, some of them probably should have seen coming. Others are just one of those things where I don't think you could. Let's talk about a couple of the problems first, and then get on to success. So, for instance, I think the biggest sort of surprise was that we were using broadcast quality recorders from a pretty large, well-known company, and we were also using their software we were using their recorders to record the pre-records, bringing them into their own software to then just chop the top and tail of us kind of going, okay, you're good to go, and then putting it onto their recorder to play back into the stream. And we followed everything, you know, in the manual to the letter, and it just wasn't working. And then we did get it working, and this is the point where, you know, really I should have probably had a better backup plan in place. We then went home on the Thursday evening and said, well, we have that going. And probably the biggest technical surprise in failure terms was turning everything on at sort of 8:30 on Friday morning and discovering that it just refused to play those back. And if anybody wants a more in-depth technical discussion on that, feel free to ping me afterwards. In terms of successes, though, the thing that I think surprised me the most was that we brought 2 relatively new cameras from a company called Zcam to this production. So Alan, who's also on the team, also purchased one, and we were expecting them to be, you know, pretty good. But the other cameras in the production are a bit higher end, and we were expecting those to be the much better cameras. And if you saw any of the kind of wide shots, the very wide shots of this set, with the cranes in the background and the sky and so on, that was the cheaper cameras. Okay. And to be honest with you, all 3 of the crew here have been a lot more impressed with their dynamic range and their color output and so on and so forth. So yeah, that's a surprise, but it is a pleasant one.
That's really nice to see, especially with a newer challenger company coming up with better equipment. So it's always good to see new innovation, and that's the whole point of the conference, isn't it? Now these are going to be the funny ones. So
no.
I'm going to merge 2 together. One of them is from Claire, and the other's anonymous. So Claire's asking, how tired are you right now?
Yeah. So just the schedule, it was a bit of a crunch, and I think. I mean, I think the rest of the NIDC committee and the rest of the crew and a lot of the volunteers are the same, but I haven't had much sleep. Now, funnily enough, last night I actually got the most sleep from about the last 10 days. But we've been out, you know, recording some of those sponsor videos. We've been getting all the pre-recording done, and even just getting the load-in done in here. I mean, the rental equipment came on a pallet. It weighs nearly 1/4 of a metric ton. So you can imagine, even with multiple hands that takes quite a bit of effort, you know. So yeah, pretty tired. I'm looking forward to tonight, you know.
I'm sure you are. And then I think this is quite topical. When do you get your knighthood?
When do I get my knighthood?
That was a genuine question.
I'm not certain. I think probably it's unlikely unless the questioner is indeed the Queen.
Just a more practical one, will the videos be available for viewing after the event?
Yeah, they should be. The aforementioned technical problem with the recorders means that there's maybe a couple of live ones on the Friday morning that we might have to pull off kind of YouTube stream or something like that. But every other video has been recorded in a nice fat high rate codec at 1080p, so they will be made available after the event.
Fantastic. Thank you so much, Dave. Really appreciate you coming on just for a last minute interview.
Fantastic. All right.
No worries.
Thank you very much.
No problem. So everyone, I'm going to hand you off to Arts, because this is the bit that everyone wants to know about, and that's all the announcements of the winners of the games that Art has very, very much been pulling together. And so hopefully we'll see a few winners. So I shall pass over to Art.
Your winner. All right, so we did mention a little bit of a track 3 this morning that has been happening for the past 2 days. So it's time to see the winners. Some of you may already know who won what, if you've been following Twitter very closely, but let's see what's been going on. Starting with yesterday's game of Tetris. Now, this was quite an impressive victory by Michael Martin, who I found out wins something every year, just like me. Although I don't think I'll be winning anything this year. Big congratulations to Michael with the prize sponsored by Van Rath, with quite a few people in competition. Michael wins even more Tetris and an Amazon voucher sponsored by Van Rath. Next up was the lunchtime game today, Pac-Man, keeping with the retro theme, which was again by a massive landslide won by Michael Martin. However, he did say that he would prefer to share in the victory and pass on the prize to the second place, which goes to Caroline. So congratulations, Caroline. We'll be in touch over Twitter to get your prize, sponsored by Van Rath, which is the Even More Pac-Man lamp and an Amazon voucher of £50. Now, it's not just the two sponsors, Vertical Structure and Van Rath, that have been making this conference happen. So to help you learn a little bit more about them, we created a crossword where as long as you could match the corporate slogan to the sponsor's company name, you were entered in for the raffle. So we had quite a few entries, and congratulations to Claire Wilger, who wins this prize sponsored by Vertical Structure, a £50 Amazon voucher. Congratulations, Claire. We also had the retweeting competition that was going on, valid from 9 a.m. on 8th of October until right now. Congratulations to Lauren Taylor with this prize sponsored by Vertical Structure. Where do you win? Guess what? Keeping in with the theme. Even more Twitter, where you get to have your tweet on a mug and the £50 Amazon voucher. Congratulations, Claire. Congratulations, Lauren. Also, congratulations, Claire. But that was a previous person. So, what do we got left? Yesterday we had a quiz around some of the things that have been happening on set of NIDC. Some of you may recognize a question from yesterday's quiz relating to the mysterious bottle that had just appeared on the shelf behind me. The way the quiz works is the more answers you get correctly and the faster you get them, the more points you get, and each point gets you a ticket in the raffle. So this morning we rolled the raffle for yesterday, and congratulations, Will, if you get in touch with us. I'm not sure who Will is, it's not enough information. You will get your prize sponsored by Vertical Structure, which is the Club Mate bottle you spotted in the background, and a £50 Amazon voucher. If Will, you do not get in touch with us, we will keep rolling the raffle on the rest of the people, so please do reach out as soon as you can. Now, that's not all. to say thank you for sticking around with us until the very end of the conference, which is a very long day for us, even longer than the usual, with filming starting very early this week and only finishing pretty much right now compared to the one-day conference we usually have. So a big thank you for you, to you for following along. So this is a raffle that will work between anybody that had a ticket for NIDC who can respond to me right now and Hopin. There is a 15-second delay, so I will probably be off camera by the time we are responding, but I will roll 5 names, and if the first name is able to respond in Hopin, you get the prize. If they're not, we go to the second, the third, and so forth. Whoever responds first gets the prize of £50 Amazon voucher sponsored by Vertical Structure. So let's roll that now. The first name is Dylan Rafferty. The second name is Tamsin Maley. Lee Baldrick. Ross Wooten. And Ali Clark. Now, there's only one prize, so whoever responds to me in priority order, if Dylan responds, Dylan gets the prize. If Dylan does not respond, Tamsin, and so forth. Now, that's not all from us, because I'm not sure why I'm leaning forward because of the clicker. There is still one more thing to go today, which is the quiz for today's things that have been happening on the NIDC set, and you may recognize some similarly themed questions with a prize sponsored by Vertical Structure of £50. Please join me at 5:30 on Hopin sessions for today's quiz. Spotting yet another Club Mate bottle for a £50 Amazon voucher. There will also be a Hubs game that will be happening this evening. If you have been playing on Hubs and having a look around, you may have a small advantage knowing all the controls and be familiar with the terrain. But this evening, after the quiz, jump onto Hubs with links posted on Hopin, Twitter, and all our social media, where you'll be able to enjoy a bit of an interesting game and something unusual to keep our conference standing out from the typical corporate get-together. The winning team will win Amazon vouchers of £50 to split between them. And lastly, I have Kaylin here from Raspberry Jam standing over here, that the Jam Kahoot £20 Amazon voucher winner is Anna. We will figure out how to get in touch with you. So thank you very much, and we'll see you at the hide and seek of Hubs after the quiz, and before that at the quiz at 5:30 on Hopin sessions. Is that us?
Nope.
Oh, I was about to walk off. Well,
all right, we talked about this. So, what to do, of course, the wrap-up is not a wrap-up without the thanks. So, I'm going to start off with the sponsors. Again, BCS, they've been fantastic. They do a lot of work in the community behind the scenes that just isn't really visible unless you're actually actively involved. And they've supported us again this year. And of course, then we have our silver sponsors, ESO, Farset Labs, HHA Exchange, Open Data NI, Carrick, I think I'll eventually get round to pronouncing that correctly, Shopkeep and SpotX. And then our gold sponsors are Allstate, Flexera, GCD, ItStill, Rapid7 and Signified. And of course, not forgetting our platinum sponsor, Sensata, so they've been fantastic this year. And I suppose then that's really it for me. Or do you have other things to
well, there have been quite a lot of people that have been helping NIDC Hopin this year. Some of these people are off screen right now as I'm breaking the fourth wall with Megan, Alan, David from the AV team behind the camera, and Sam and Kaylin from the Raspberry Jam, and Lucy's still sticking around here. A lot of people have been behind the scenes doing a lot of work to bring this to you. So if you enjoyed it, please thank them on Twitter and and thank them whenever you chat with them on Slack or anywhere. Because this year we really took a big leap of faith in trying to see if this would even work in such a different world for us. We didn't know if anybody would show up, so thanks to you for attending. We didn't know if anybody would sponsor us, so thank you to our sponsors. And we didn't know if we could even make it happen if we got the support. So the AV team here has been a massive help in guiding us along, as well as the Raspberry Jam team for making the kids track happen and helping kids stay engaged. You know, we as adults can stick around for a webcam call on Zoom for a couple of hours and annoy about it or get annoyed about it over coffee. But getting kids engaged is really difficult, so thank you to the Jam team. And I think thanks to the committee, May, I know you didn't expect me to say this, but a lot of work has been happening here with May running crazy, telling us what to do, saying, right, let's nail this down, here's the schedule, make sure everything is on time. It has been a lot of effort that kept yourself up very late some nights that I've noticed. Phil is over there doing many, many, many things, managing problems that I cannot even list. Joan is at home helping us do, I cannot even name there's so many things happening, and Mark that was up here at, I think, even before me, having lived very much further away. And who else? There's also me, there's you, there's Phil, there's Joan, and there's Mark. I think that's all of us. Yeah. But it's all coming to an end, and with this leap of faith coming to something successful, it's really something.
Yeah.
What do you think, May?
No, absolutely. I mean, of course, you've got the viewers as well. You know, it wouldn't be what it is without the community. You know, we've had over 450 people actively come on and engage and watch videos and chat. So thank you so much. It's gone way beyond our expectations. Like, honestly, we genuinely didn't really expect as many as we did. We thought we might hit the same numbers as we would with our in-person event, and we went beyond that. So thank you to everyone watching. So I'm just speechless at this. But yes, I think it's weird to say this, but I think that's really it. And stick around, we do have one more surprise. I will very, very much recommend that if you think this next bit is over, then it isn't. Just hang on for a bit at the second after this ends.
Treat it like a Marvel movie credit.
But with like the superstars and...
Maybe with the stunts?
Yeah, some of the stunts.
Cliffhangers?
Cliffhangers.
More to come?
It might look more like a blooper reel though. You know, so, but on behalf of Art, myself, and the NIDC committee in total, Mark, Joan, Phil, who's doing his best impression of an octopus right now, trying to navigate two laptops. Thank you and goodbye. 2020, the year of Zoom calls, pajamas, and bad internet connections. This year, NIDC is a little bit different. We'll be missing the hallway tracks, the ability to put faces to Slack handles, and of course, the little bit of chaos that happens every year. Oh, I think Art's going to be okay. We'll find out once he gets out from A&E. So where was I? Yes. We will be back next year at Riddle Hall. Yay! And we'll be back the same range of diverse talks, the networking, and of course the 15s. And on top of that, for all the parents out there, you can rest assured that you can bring your kids to the conference and leave them in the hands of Patricia and a fantastic team at MK Wedding Childcare. So, we're looking forward to seeing you again next year.
We look forward to seeing you next year.